distinguished guests, esteemed speakers, industry leaders, innovators, and delegates, a very good morning to all of you, and welcome to Day 3 GRIDCON 2025. Great things happen when great minds come together. And after the grand inauguration on 9th, yesterday, we have witnessed exactly that a congregation of visionaries, innovators, and experts coming together to shape the future of power transmission. Day 2 was a power packed journey to the future of energy transmission, covering cutting edge advancements in offshore transmission networks, hybrid, HVDC, MVDC, and LVDC systems, and the operational experience of UHVAC. We also delved into the transformative role of virtual protection, automation, and control in modern substations. The engaging panel discussions provided invaluable perspectives on India's power sector in 2047, global energy transition trends, and cross-border energy governance. Our deepest gratitude goes to our distinguished speakers, panelists, and thought leaders who have not only shared their knowledge but have also sparked dialogues that will drive real change in the energy landscape. And today, we embark on the final day of GRIDCON 2025. We are not slowing down. The momentum is only building. We have a power-packed agenda featuring high-impact plenary sessions, thought-provoking panel discussions, and expert insights on disaster-resilient transmission design, energy storage, digital transformation, and the evolving landscape of utilities. So, let's make this final day as engaging, insightful, and inspiring as ever. Can we have a huge round of applause to begin this amazing day all together, ladies and gentlemen? Thank you so much. Ladies and gentlemen, to begin today's sessions, we focus on a subject of paramount importance, disaster-resilient infrastructure design, transmission lines. In an era of increasing climate uncertainties, ensuring that our transmission lines withstand extreme conditions is not just a necessity but a priority. To enlighten us on this topic, we are honored to have Dr. Pierre Van Dyke, a globally recognized expert from Hydro-Quebec, Canada. Please join me in welcoming Dr. Pierre Van Dyke to the stage.
Thank you very much.
Before we begin, let me introduce our esteemed speaker. Dr. Pierre Van Dyke is an expert in conductor dynamics with over 30 years of experience at the Hydro-Quebec Research Institute. An internationally recognized researcher, he is specializing in Elion vibrations, subspan, oscillations, and conductor galloping. His work has led to the development of solutions to mitigate ice accretion effects on power transmission lines. Currently, serving as the chair of SIGRE Study Committee B2 on overhead lines, he plays a key role in international technical exchanges, training, and consulting. He has authored or co-authored over 50 publications and contributed to major technical books, including the EPI Orange Book, Atmospheric Icing of Power Networks, and SIGRE's Overhead Lines Green Book. His excellence has been recognized with several prestigious awards, including the SIGRE B2 Technical Council Award 2020 and the Masood Farzani Award 2022. Ladies and gentlemen, let's put our hands together for Dr. Pierre Van Dyke.
Thank you very much. Some of you may know that Hydro-Quebec and I work for Hydro-Quebec and PGCL have a long relationship, fruitful relationship. So it's my great pleasure to be here with you this morning. So my presentation is about disaster-resilient infrastructure design of transmission lines. Doesn't work. Oh, thank you. Perfect. So I will talk about recent international disasters. I will talk about the 1998 ice storm, extreme ice storm that we had in Quebec, Canada. And I will finish with the design of a transmission line in a challenging environment. So my colleagues from SIGRI were nice enough to send me a collection of disasters that they had on their own network recently, which I will share with you. The first one happened in Japan. It was a snow accretion wet snow accretion that happened on the OPGW, on the ground wire, I'm sorry. So as you can see, the top of the load on the ground wire was too high, so the top of the towers collapsed because of that. So the solution in that case, what they did is they used snow rings combined with pendulums. The pendulums prevent the ground wire from rotating, and then the wet snow will slide along the strands and hit the ring and then shed from the conductor. So that's how they prevent an excessive wet snow accretion on the ground wire. And they did that on all the lines that were susceptible to experience the same kind of event. Second case was again in Japan. They had again wet snow, but contaminated with salt. They experienced flashover on the insulators, and it impacted 37 lines. It took 10 hours to recover the system. And so what they decided after that was the fact that they use long rod insulators on their lines. Long rod insulators, the distance between each elet, each shed, is too narrow. So when you have a big ice or big pollution contaminant adhering all of a sudden, it doesn't perform well. So suspension insulators are better in that regard. So what they did, they decided to keep one circuit with the existing long rod insulators. So because it performs well when you have long-term accumulation of pollution, and change the insulators on the second circuit to use suspension insulators. You have probably heard about the massive flooding that they had in Spain with 200 millimeters of water or rain in 2 hours. The impact was over 200 deaths, major damages on buildings and infrastructures. So you see they lost hundreds of thousands of vehicles. The impact on the infrastructures was massive, bridges, highways, everything. And the main damages happened on the distribution grid. Transmission grid was also affected because of flooding of 2 substations and micro tornadoes that destroyed 23 towers. So you see here some of the towers which collapsed because of the micro tornadoes. Same here. And you see in that case, one line fell on another one. So it was a double impact. And flooded substations, you can see the water went up to that level in that case. So what they learned from that event was that when it happens, you must have a quick assessment of the damages and coordinate with the army, use helicopter, drones, and centralized coordination is what must be done. Temporary solutions to feed certain areas, access to sites, so they needed heavy machinery. And because the communications were down, they used a satellite phone to communicate together. And you must have also sufficient spare materials and tools. So this is the reconstruction phase. They expect that it will be completed very soon, within 3 months. Another flooding, this time in South Africa, not as massive. So it affected towers between 9 and 15 and 2 more towers a little further away. So this is the the towers that were affected, as you can located in this valley. And you see this tower, the tower arm is collapsed. And in this case, you cannot see it very well, but there was a tower right here. It's not there anymore. So gabion wall, which was destroyed. Also sliding of the soil, which went into the substation. So in this case, the solution was to make the site and towers safe as best as possible, prevent existing towers from further damage, and conduct a complete assessment of all the damage. In Australia this time, they had micro tornadoes, a mini tornado, one in 2020 with 6 towers going down. And what they did, they used the emergency restoration system to install new temporary towers to hold the line. And they used 100 concrete block, but they realized at one point that they didn't have enough, so they had to pour more concrete and make some on the way. So you see here the reconstruction and the towers which fell down. Same thing here. And again in 2024, they had the tornado. Some towers fell, 6 towers collapsed. So the lessons learned in that case is that you have to consider the whole of life of the project. So consider everything right at the beginning, mobilization, construction, inspection, and maintenance. Even if you use temporary structures, you have to plan for the permanent structures that will be installed later on. And earthing is important for the safety of the line workers. Foundation design is critical. And that was it for the recent event. I will not now talk about the 1998 extreme ice storm in Quebec, Canada. I will begin by describing a little bit our network. So this is province of Quebec. We have 9 million people living in the province of Quebec. Half of them live in the Montreal area, so this is where most of the electricity consumption is done. But the generation is mainly done north or northeast of the province, 1,000 kilometers away. And we have interconnections with another province in Ontario, and another province, New Brunswick, and in the south with the US. We sell electricity regularly to those provinces and to US. Just a quick overview. We have 37,000 installed capacity that belong to Hydro-Québec. Hydro-Québec is a governmental company, and 11,000 installed in Quebec, to which we have full access, and some in the US. So what was exceptional about the 1998 ice storm was the fact that, in fact, it was 3 successive ice storms, one after the other. So that's why the ice accretion was so high. It was between 50 to 70 millimeter, even up to 75 millimeter in some areas of ice accretion, so it was unexpected. The ice storm lasted from January 5th to 5 to 10, and this is where all the system went down. Not all of them, but a lot of them. So you can see that that kind of collapse was. We saw that everywhere in the southern part of the province. Of course, it had a massive impact on our technical, organizational, social, economical, and all those aspects, reputational, and so business model, because we could not fulfill our contract. We were supposed to sell electricity at that time. And the impact was major. We lost 24,000 poles, 900 steel towers, and 3,000 kilometers of line. And the cost was $1.2 US billion. It took 1 month to rebuild the system, the whole line, to connect the last customer. We had help. You can see the blue truck belonged to Hydro-Quebec, but the gray one, there was white one. We have agreement with our neighboring provinces and with the US that with the utilities, that we will help each other in case of issues like that. Sometimes tornadoes, sometimes other adverse event. So sometimes we help them, but in this case, they helped us to rebuild the system. So communication was very important, because the population, not having electricity, in the old time, people, they had fireplace, so they could heat their house, but it was minus, maybe minus 10, minus 20, sometimes degrees Celsius, so people heated the house with electricity in Quebec, so it was a major issue. And the Prime Minister and the President of Hydro-Quebec, they were broadcasting on television every day what was the progress for the recovery of the transmission lines and the whole system. So after the last customer was connected, we did a lot of R&D to understand the icing events and how to mitigate them. Test line was built to understand what will fail in what order, what was critical, what was not. We produced also new maps to show on the province of Quebec what kind of ice accretion we will have in this area. So maybe in this case 75 millimeter, other places 65, other places 50. So that and then we changed the standard for the future construction of transmission lines, so that they would reflect, or they would be able to sustain that kind of load. So more than 900 kilometers of line were rehabilitated to more robust design criteria. When we had 2 lines in parallel, one would be rehabilitated at higher, the new standard, and then the one just beside it, we would leave it as it is. And I forgot to mention in the first slide also, when we were building lines, so from when we were building new lines, in the old time would use 1 corridor for each line, so they would be built one beside the other. Now, if we are going to build a new line, we'll make sure that it follows another path. So if we have an adverse event in one location, then the other line will still be standing. Other preventive measures, especially for distribution line vegetation control, because a lot of issues came from the trees falling in the distribution lines. We already had real-time ice storm management, and we worked on the de-icing method also, and tower in reserve at the line's emergency bank. So the adaptation phase, number one, this is what was decided. Service continuity must be assured following events most likely to occur in the power system. The power system must include ways of avoiding system-wide power failures under extreme contingencies. The strategic equipment must not sustain any damage in the event of a general outage, so that the system restoration is always an option. And finally, transition system must be designed to allow the system to be restored within a reasonable period after a catastrophic event. So that's what was done in the years following the event. But then in 2022, Hydro-Quebec appointed a team of experts to perform a risk analysis for extreme ice storm event. So, and I forgot to mention it, but you see, this is the Montreal Island, where most of the population live, and we have a loop now which goes around the island. The loop was not complete prior to the ice storm, but now if, let's say that this transition line collapse, we can still feed this line by the other side. And yes, so the purpose was to identify and assess any remaining vulnerabilities and propose potential mitigation measures for the grid. So what was done is to define credible ice storm scenarios. So nice scenarios were defined. One severe with 75 millimeter of inch based on the 1998 ice storm, and it was located in this area, let's say. And they defined 8 localized scenarios of lesser severity located at different locations in the Montreal area. And then they simulated what would be the impact of those scenarios if it happened on the whole system. And they also, and to validate the calculation, what they did during the 1998 ice storm, they knew what was the amount of ice at each location in the territory, and they knew which line had collapsed every day. Let's say when we had 45 millimeter, 50 millimeter, 65 millimeter, or maybe 25 millimeters. So what they did, they studied the line that they had at the time, and they said they checked. Okay, this is the kind of ice accretion we had. If it collapsed as the collapse prediction corresponded to what really happened. So that's how they validated the model to reproduce for the previous for those scenarios to see what would be the impact. And so they looked, they identified key elements that must be they must provide electricity. There's no way we cannot. So like a hospital. And then the people, they work together. In this case, previously what was done, distribution engineer, they would work and look at the distribution grid. Transmission engineer would look at the transmission grid, and the substation engineer would look at the substations. In this case, what was done, they all worked together. They said from generation to the customer, this is the ice, we have this ice storm. So we have to make sure that all along where the electricity flows, we must provide electricity. We must see what is the impact. So that was the big difference from what was done before. And based following those studies, they recommended projects to make sure that the robustness of the network would be adequate. And some projects are going on to or have been done to make sure that the network is adequate. I will now talk about design optimization of a line which was built in a very challenging environment. 138 kilovolt, and optical phase conductor was used. So an optical phase conductor is very similar to an OPGW. The fiber is in one of the wires. It's in a tube, and it's 40 aluminum-clad steel wires. This conductor was used because it's much more rugged and it can sustain more severe vibration and more severe stress. And this line was built in British Columbia. In fact, it was the idea was to replace an existing line. This is Stewart where they need electricity. And this is a power generation plant. And the line goes like this on top of the mountain, 1,500 meters, and then it goes down to the substation. So you can see the line on the mountain. And what happened is that they built a line from the generating station up to the city. The utility, they don't want to give too much details, but what we understand is that they had the first year they had the tower collapsed, and then they had a lot of galloping issues, flashovers between the phases, and and every year they had issues, so they decided to rebuild a new line because it didn't work. We had helicopter access only. So the snow depth can be up to 10 meters, rime height. So wet snow condition, 50 millimeter of radial wet snow. Much below that you can have galloping. Rime ice, wind speed was very high. Snow avalanches, snow creep, galloping events. So they used the previous line was built like that. So they used pole towers instead of lattice tower, because in lattice tower the flow of the snow the pressure would be too high. And for galloping, I guess you have galloping in the north of India, but not in this area. But galloping, what happens is that when you have an ice accretion on the conductor, it will change the shape of the conductor, and you, instead of having only drag because of the wind, you also have lift, and the conductor can move up and down up to 12 meters. So the main issues are the flashovers, each phases coming close together. They don't even have to touch you, and you can have flashovers, but sometimes they touch also. And also it causes a lot of dynamic loads on the tower, so sometimes the tower arms fail, or the tower will collapse. But the main issues usually are the flashovers. So what I did the calculation about what this is the conductor, and this is the insulator conductor, location of the conductor in the middle of the span. So what would be the maximum galloping amplitude for each conductor? And you see that they will interact one with each other, so that's why they had so many galloping issues. For the new line, the first idea was to use conductors and OPGW. Since there's not much thunderstorm issues, the OPGW, the idea was to put it here and the conductor here. So, but that's what it gives. But finally, they went for an optical OPPC conductor. So this way, the towers can be lower, and we can still keep the vertical clearance. They also use prefabricated steel foundations. So that, because of the helicopter, the fact that everything was transported by helicopter. And one issue, so when you have ice shedding, you know, the conductors, the ice is on the conductor, then the ice sheds suddenly. We'll have a traveling wave going along the conductor, which may be very steep, and the damper, they will fail in fatigue, or they will droop. So you may have a lot of issues with that kind of with the stoppage dampers in those conditions. So I recommended using the Quebec damper, which I designed many years ago. This damper has an elastomeric element in the articulation and stoppers. So this is a test where we put one stoppage dampers at one end of the span and Quebec damper at the other end of the span, and we pulled the conductor and released it to simulate ice shedding. And you see that in this case the mass hit the conductor, it goes up, goes down, and then goes up again, hit on the other side. And we did this test 2 to 3 times, and then the masses were drooping. So the stoppage damper was no longer efficient. On the Quebec damper, we did it one other time, and there was no damage. So it works, it can sustain that kind of load. And the last thing, we also recommended to use elastomeric suspension clamp. Again, the idea is that you have a metal-to-metal contact here, so that if you have an ice on one side and an unbalanced load, ice on one side, no ice on the other side, it will prevent the conductor from sliding, and elastomeric at the end, so that when you have galloping subsonation or airline vibration, the bending of the conductor will be less severe than for metal-to-metal conductor, metal-to-metal suspension clamp, and so this is the result of fatigue test that we performed. You see the red dots with the metal-to-metal clamp. So what we did, we installed the conductor, installed and use a shaker to excite it. And for example, if we use, let's say that we excite it at this amplitude, with a metal-to-metal clamp, we can sustain 2 million cycles without failure. But with the elastomeric clamp, we can sustain 30 million cycles without failure. So this is the kind of thing that I recommended to make sure that everything would work. So you can see that in this case, the OPPC was a cost-effective solution. Severity of airline vibration galloping was taken into account. The line was energized in 2018. I've heard nothing since then, so I guess everything went well. When it doesn't work, we hear about it. When it works, we don't. So that's it. So that's the end of my presentation. Maybe I had many slides, so I think I talked very fast because it didn't take me as much time as I expected. So do you have any question?
Thank you so much, Mr. Pierre Van Dyke, for that enriching and thought-provoking session. The insights shared today will go a long way in shaping the way we design power transmission infrastructure that stands the test of time and nature. We now open the floor for Q&A session. If you have a question, please raise your hand, and our volunteers will bring the microphone to you. To ensure we hear from as many of you as possible, we request one question per person at a time. Do we have questions? Yes, we do have. Can we just pass the microphone, please?
Hello. Sir, thank you very much. Just one question. Using OPPC, where is the earthing shield provided to the entire transmission line? So we normally...
Can you put the mic closer?
Yeah. Normally we have a ground wire or OPGW wire above the phase conductors. Actually I don't see it here. So how the shielding is achieved in this line?
Yes, in this...
Against lightning strokes.
Yes, in this case, the almost no thunderstorm in this area, so that was not an issue. So that's why, you know, even when they talk about installing an OPGW, they put it below so that the load on the towers would be less. So
that is fine, sir. Yeah. Okay. Thank you.
Thank you.
Hello. Hello. I'm here. I want to ask one question. Basically, I wanted to ask two. It was already he has asked one, so I can ask one right now. From your presentation, I could see that during the emergency restoration system, you used concrete blocks. Why is it necessary? We can just dig the earth and put some thick trees stems also to stop the guy wires. So there in Hydro-Quebec or in Canada, you always use a concrete block for guying the ERS towers.
No, in Canada, that was in Australia, that they used a concrete block as a temporary anchor. In Canada, we don't do that. We would use, drill the rock and put anchor rods, and that's what we would do. But in that case, it was only a temporary solution. After that, they put anchor rods to hold the towers.
Yeah, thank you.
Do we have more questions? Yes, we do have right there.
I have two questions. One is related to the hardware, particularly what are the metallurgical challenges in this case because of extreme low temperature. There is failure of jumper cones Number one, and number two, what is your experience?
Excuse me, can you, yes, thank you.
Yeah, one is the failure of the hardwares because of extreme low temperature and particularly this jumper cones. So is there any specification to take care of that? Number one. Number two, regarding the insulator failures, do you have experience on polymer insulator failures, and what are the improvements that Quebec has learned from its own experience?
I'm not sure I understood, but for the let's say special damper and air and vibration damper, what we do, we test it at down to minus 50 degrees Celsius, because that's the kind of temperature that we will experience. So the elastomer must not reach its glass transition. The glass transition must be below 50 degrees, minus 50 degrees Celsius. So that's how we take care of it. And I'm sorry, the second, I hope it answers the first question. The second question was?
Regarding the polymer insulators.
Okay. We don't use polymer insulators at Quebec. We use it only for interface spacers. We use the polymer insulators, I think it was maybe 30 years ago. We had a bad experience, so we removed all of them, and we don't use them anymore on our system.
Okay, thank you.
Good morning, Anish Anand. Very nice presentation here, and of course I missed the initial part of it. I would like you to also share some experience with respect to ice accretion. You talked about on impact on ice accretion causing galloping and other impacts on hardwares and spacer dampers. What would happen in case we have multiple bundle conductors instead of single bundle?
Can you put it? Okay.
Yeah, so ice accretion, accumulation impact on multiple bundle conductors instead of like single conductor you talked about in your presentation. So would there be some difference in galloping phenomena in terms of, in case we have, let's say, a bundle of 4, the transmission lines which we are going to build right now from the Leh and Ladakh area down to Haryana and here, that would have multiple bundle conductors. So if you would kindly share some experience on that aspect, like what we should be aware of, once we have multiple bundle conductors, and then of course, ice accretion on multiple bundles.
Thank you.
Yeah, thank you.
Yes, there are different aspects. The first one I will cover is if you have a bundle conductor, what we have seen is that sometimes the bundle can collapse. What I mean is that you have the ice accretion, which happens on one side of the conductor, and then the bundle rotates, and it still rotates, and up to one point where it will collapse, usually at the end of the span. So to prevent that, what we do now, we add another spacer damper instead of our. In PGCATL, your suspan length is shorter at the end, which is a good thing. In our case, it was a little bit longer. So now we add another one in the first suspan at each end of the span in location where we have experienced that kind of issues. So that's one point. And regarding galloping, we don't know for ice rain if it will be more severe on we don't know because we don't have enough data, but I suspect that it will be more severe on a bundle than on a single conductor, because on top of having what they call the Den Hartog galloping, you can also have a floating phenomenon. So I suspect it will be more propitious to galloping than the single conductors. We know in Europe, especially in England, they observe that they have more galloping on bundles, but they have wet snow. In Quebec, we have 2/3 of our galloping events are because of ice rain, 1/3 are because of wet snow. But in England, when they have a twin bundle, they will even uncouple the bundle And instead of having a spacer damper, they will put a ring to prevent the conductor from coming close together, so that it will behave as a single conductor instead of behaving as a bundle. So.
Because you were telling about specific design which was developed by you yourself for the vibration stock bridge dampers, which were not working in case of galloping. So, like for multiple bundle lines, we don't use those dampers. We use only spacer dampers. So, whether those available designs with articulated arms, those would remain sufficient, or some improvements. I think in some countries there is also a practice of not having a, like for example, quadruple bundle, like complete spacer damper of quad bundle, but then having twin spacer dampers spaced apart. So any experiences would you like to share on that? Or the existing designs of spacer dampers would still work with articulation arrangements, which we have in our designs here.
Okay, so the question is, in your case, sometimes you use twin spacer damper.
Bundle of 3 or bundle of 4 in the new lines which we are going to construct here.
So you will use twin in combination so that all the conductor will be, the geometry will be respected, okay? We don't do that. In our case, we use only spacer dampers along the span, and it works well. The only issues we may have, which is a good thing, is that the arm may break if the ice load, you have displacement of the conductor longitudinal, because the ice load is much higher on one conductor than the other. So it happens, but not often. It happened few times that the arm would break, which is better than having the conductor damage. Those are extreme cases. Normally, it works well, and we prefer to use spacer damper than rigid spacers and having stock bridge dampers at the end, because the spacer damper, they are more, they resist much better to galloping or to any kind of event than stock bridge dampers. Of course, in India, since it's a warm country, except in the north or in the mountains, you don't have those issues. So the way you do things, it's fine. But if you have ice accretion, then I would resort to spacer dampers, because it's more rugged against that kind of ice accretion with snow. It would be better.
Thank you. In fact, we also would be using spacer dampers only. I just want to check whether that would be okay, because in some countries they use that alternative, bundle spacers arrangements. So if that works fine, as you said, so we'll be going ahead with that, and I think we should be happy with that.
Perfect.
Thank you. Thank you so much.
Any other question?
Do we have any other question? I think we don't have, sir.
Thank you very much. Thank you, everybody.
That was an engaging session. Thank you all for your participation, for their thoughtful questions. To honor our esteemed speaker, may I now invite Shri Pankaj Pandey, Executive Director, TBCB Power Grid, to present a memento to Dr. Van Dyke as a token of appreciation.
Oh, okay, sorry.
Ladies and gentlemen, once again, can we have a huge round of applause, please?
Thank you. Thank you for my team. Thank you. Thank you.
Once again, thank you, Dr. Van Dyke, for sharing your invaluable experience,
thank you very much,
expertise, and Shri Pankaj Pandey ji for joining us in this honor. Next, we transition to a plenary session on battery energy storage system, a crucial technology that is transforming the future of energy. Ladies and gentlemen, as the world transitions towards renewable energy, one of the most significant challenges is ensuring a stable and reliable power supply. This is where battery energy storage systems come into play. These systems play a vital role in grid stabilization, renewable energy integration, and peak load management, making them a cornerstone of the modern power sector. To shed light on this transformative technology, we are honored to have with us Mr. Mikhail Timofeev, a leading expert, founder and CEO of Storen UAE. Please join me in welcoming Mr. Mikhail Timofeev to the stage. Before we begin, let me introduce our esteemed speaker. Mr. Mikhail Timofeev, a visionary leader in energy storage, is the founder and CEO of Storen UAE since 2021. Storen is a pioneering company driving the adoption of advanced energy storage solutions built on CATL battery systems, a world leader in the production of lithium energy sources for electric transport and energy. Beyond Storen, Mr. Timofeev also serves as the Chief Investment Officer at Zentech, where he leads international investments and the implementation of the battery as a service model. With a deep expertise in battery technologies, electric mobility, and sustainable infrastructure, he has been instrumental in shaping the future of energy storage. His diverse experience spans leadership roles in electric shipbuilding, modular housing, and SME financing, reflecting his broad impact on innovation and investment. Today, he will share his insights on battery energy storage system, a game-changing technology for modern power grids. Please join me in welcoming Mr. Mikhail Timofeev to share his insights.
Good morning, ladies and gentlemen. I really appreciate invitation from Power Grid and I want to show our presentations and share some thoughts and challenges and opportunities about energy storage. Our company Storen was started in Dubai like a holding company for Chinese system integrator, which was first officially approved by CATL as system integrator in 2018, and later on we added to our capabilities production of battery storage products in China, nearby Shanghai, in city Suzhou. I would like to show some short video about our production facilities in Suzhou, and then I will show our presentation. Could you please start video? In this video, I will show how it is now implemented and doing the battery storage production. It's commonly widespread inside China. It was a short video about our production facilities and facilities which are we're going to implement in other territories either. So let me start, please. As I told, Storen is a group member of International Energy System Integrators. We offer one-stop services, including product research and development, system integration, smart manufacturing, and international sales. Our production lines has a 6 gigawatt hour capacity per year. We have expertise of 10 years and we have 2 production bases. Here is our product map. We provide design and production of module and packs, and 2 utility utility energy storage products like containers and for commercial and industrial all-in-one solutions. As I told, we started in 2018. We got approval and certification by CATL as official system integrator and service provider for this company. Then in 2022, we installed our first utility scale project in Brazil, in São Paulo. It was the biggest project in Brazil. By now it is also 67 megawatt hours. It was installed for substation, city grid substation, the use purpose for peak shaving and voltage stabilization. 2024, we started first African project in Gambia for 9 megawatt hours. Then we supplied turnkey energy storage system for Dutch project, commercial and industrial, 52 megawatt hours. Also, we last year designed the project for Taiwan, which is 100 megawatt plus energy storage single project. As I told, we have R&D sales, operation center, production base, and new production base, and then our international holding center inside UAE. This is our map presence. We supplied these years more than 100 global customers, and we have more than 500 partners. Major projects we done for our last years. This is the range of battery products we have designed by ourselves, and we also provide battery products from CATL. You see here utility scale battery containers, NRC, NRC Plus, and others. Also, we provide to our customer a module and pack production. We can supply just modules and packs. From the beginning, we had the line of household ESS products. This is a short introduction about our automated production facilities, and I want to highlight that our intentions, like international partner, to implement such systems in any territories which has the demand, the proper demand. Now I would like to introduce our global partner and this giant named CATL. Main business and starting its batteries for EV cars and energy storage. It was established in 2011. Now it's public listed, and secondary listing is going to be in Hong Kong this year. Company culture based on 3 milestones, and most important is innovations for our customers, and core value is to refine, enable, strive, and innovate. Here the short history how CATL was started. Initially in 1999, it was a company named ATL. This company was established by Mr. Robert Zhang, the founder of CATL, and Japanese partners. Main target was consumer electronic products. All, I think, third our cell phone has battery from ATL. All third. But in 2011, Chinese government incentives program was started for lithium-ion batteries producers, and to get this that subsidies and government support, the company should be fully owned by Chinese shareholder. That's why it was started CATL, contemporary Amperex technology. In 2023, latest products were announced, like semi-solid battery cells with density capacity 500 watt-hours per kilogram, which is going to be used in aircrafts. So this is now one of the highest density serial production battery cell. Last year, CATL also launched chocolate battery swapping stations, chocolate batteries. Like automotive company NIO, car manufacturer, CATL now also launched its swapping stations. Swapping stations will be highly utilized in China, and later they will go globally. I should highlight that each third car, EV car, has CATL battery. Here we see global presence of CATL. It has 6 R&D centers, 13 production bases, 2 of them internationally based in Hungary and Germany. Now, I think the most important slide about CATL ranking and CATL presence on global market. Last 8 consecutive years, CATL is #1, and in 2024, CATL share on global market for lithium batteries was increased more than 1%. Output of CATL last year was 339 gigawatt hours of batteries. Out of this, 100 and 10 gigawatt hours were supplied for energy storage, just energy storage projects. I would like to stop on this a bit because we see how fast energy storage demand is growing. It almost doubled each year, and CATL is confirming that with 110 gigawatt hours supplied last year. This is all ranking by global consultancy and mass media. Three most major directions of CATL is replacing stationary fossil energy. We are adding energy storage product systems for renewable generators. We will provide, using the energy storage itself, we can provide shifting of intermittency of renewable generation into smooth loads. We can split peak production of sun into mornings and evenings. That's why we can reach equilibrium between production and useful utilization of energy. Then we using energy storage products and batteries, we will replace fossil energy in mobile transportation. So it is EV batteries. Then we using electrical drives and batteries, we can add electrification for special purposes like mining and unmanned operation from control rooms. So all these special vehicles and trucks are electric. Now about energy storage, development opportunities and challenges. Bloomberg NEF, Wood Mackenzie, and other respectful agencies, they are confirming huge booming in energy storage. And by 2030, installations of energy storage will reach more than 350 gigawatt hours per year just for energy storage. But as you see in previous slides, CATL already supplied 110 gigawatt hours. So we almost reached these predictable numbers last year. Once we use energy storage system, we should point attention on several milestones, like and we need to keep improving these challenges during the development of energy storage products. First, we need to think about high level of safety. We need to guarantee self-safety, system safety, and other parts of energy storage system. Easy extension. By now we are thinking about 1 hour storage because it's affordable and inexpensive. But then you need to enlarge your energy, to enlarge durability of this power bank up to, let's say, 4 hours or 8 hours. We need to provide less O&M. We need to make very fast installation, very easy installation for skilled laborers. Then for especially investment scenarios in utility scale battery storage products, we need to provide long service life. More cycles, more return we will get, or faster return we will get. If we can reach 2 or 3 cycles per day, then we can reach payback in 5 or 7 years. But duration will last for 20 or more years. High efficiency. Just a widely spread opinion that we need to discharge the battery for 80–90% to keep life longer. But this is not efficient utilization. That's why we need to aim for 100% charge and discharge. For improvement, we need to add artificial intelligence and data analysis to predict our asset operation and to predict which module or pack from the battery system. When we have 100 containers, we need to predict which one we should replace. We should replace it fast to provide payback for investor. It's already on table. It's challenges, and we keep our target in this when we develop and produce batteries.
What, less O&M is an advantage or it is a challenge? I think high level
less
of safety.
OM, it's an advantage, of course.
Yeah, so you are written, except high level of safety, other are these are advantages of this thing.
It's challenges because we need to think about these key points all the time. And we need to improve our system, consider these 6 milestones. Challenges, and if we have improvement in each of them, then it will, of course, be our advantage. Now I will answer your question about advantages, because it was challenges, but now the answer on advantages. Technology highlights. Sustainable safety. As I told, CATL now is providing battery cells for aircrafts, where the safety reason and parameters are crucial for healthy life. Long service life, we are talking about LFP batteries, lithium iron phosphate batteries, not titanium batteries, not LTOs. Here it is written up to 12,000 cycles, but even more. And we are talking about 100% charge and discharge cycle, full cycle. High energy density. Here we are talking about density of the cell, 350 watt-hours per liter. And also we are talking about lithium iron phosphate batteries. Later on I will determine and highlight why I pay attention about lithium iron phosphate battery. We have to provide temperature control on battery cell and battery pack module level. Intelligent management, data analysis. More battery cells we supplied, more data we got, and we can make further predictions. Now about lithium iron phosphate batteries. Why now the only one chemistry for grid scale and investment projects. Now, I'm talking about nowadays. Because you see this graph, it shows thermal stability of some cathode materials. I did testing of NCM batteries, puncture test, and thermal runaway. So if we will punch our battery in our cell phone, it will be like a bomb. Because once it reaches 100 degrees temperature, then in 2-3 seconds the temperature is more than 1200 degrees Celsius. But once we do puncture test for LFP, usual LFP, then when it reach after punching, it reach 80 degrees. Then 80 degrees is stable. No thermal runaway. Depends on the, of course, chemistry of cathode. That's why for stationary energy storage products, by now the most mature technology and chemistry is LFP. Later I will point attention, I will share some ideas and targets in sodium batteries, sodium-ion batteries. CATL provides extreme manufacturing to guarantee safety. I would stop here. Extremely high quality requirements. Once we are talking about defection rate through battery cells producers, they count ppm, piece per million. CATL counts ppb, piece per billion. So defection rate 1 on 1 billion. To reach such parameters, CATL is providing rigorous testing. 273 tests in total: safety, reliability, performance, and each month CATL is testing more than these numbers you see. Then we are talking about system safety. To reach system safety, we collect all data and provide full range data analysis. For fire safety and fire protection, we also should provide multiple detections and multiple fighting with fire system to protect the fire. These coming years to reach better cash flows for investors, LFP technology by CATL was improving, and now we have more than 1,000 cycles, zero degradation. It means then 3 years you do not need to count in your cash flow models degradation rate. So return is faster. Then again, it's already existing parameters of 12,000 cycles. It means that 2,000 cycles per day, state of health of the battery around 70%, and it will last for 15 to 20 years. Once we are talking new battery containers, and we count 100 megawatt hour scale project, then footprint will be 35% less just for product named NRC. I will show. As I told, CATL, as any other battery storage producers, they use intelligent temperature control and always enhance these parameters and techniques. Intelligent BMS, it is when we should count parameters of each cell inside the battery system. Sodium-ion batteries. Yes, it is interesting technology, very promising technology, but sodium-ion batteries is still under development. And because lithium prices 2 years back fell down, then competitiveness of sodium-ion batteries is on doubt, at least for close 5 to 6 years. Usage for sodium-ion batteries can be approved by low temperature and high power discharge rate. As you see here, it can be discharged with 4C, 4 times faster than its density energy. And compared to lithium iron phosphate batteries, when we are discharging this battery in -20, then capacity still reach 90% of the battery. What for and why we need to use energy storage? As I mentioned before, for PV wind power integration into our grid systems, smooth integration, and keeping the whole power generated to be transmitted and to be useful consumed. Peak load and frequency regulation in grid for grid stability and to provide better utilization of transforming assets. Third solution is for consumer side, more consumer side, once we are installing energy storage on customer side, on factories, warehouses, or hypermarkets, or residential facilities. Here it is most common battery cells which are used for energy storage systems. It is for everyone known cell 280 ampere hour. Last 2 years it was replaced for 306 and 314 ampere hours. As you see here, it reached that cell 280 ampere hour capacity. It was already reached 8,000 cycles, charge and discharge. For both case scenarios, 0.5 and 1C discharge rate. 100 ampere hour cell for household and residential storage solutions. Cells for UPS. Once we are talking about data centers, once we are talking about telecom base stations, we need high power energy storage UPS. We need to discharge it, we need to reserve power for 10 minutes. Then we are talking about 5 or 4C discharge rate. To save our money to buy this and install these assets. This is indoor liquid cooling container, 372 kilowatt hour. Next generation for outdoor usage, 372 kilowatt hours again. This is NRC container, which footprint and design allows to reach 35% saving the area and making installation much faster. UPS lithium iron rack, iron battery rack. Such racks can reach up to 4 to 6 C discharge rate. Battery modules for telecom base stations. Now I want to tell more about utility scale battery solutions by CATL. This is roadmap. Here we see two parts: utility and grid, and C&I. So as you see, in 2022 it was NRC with 280 ampere hour cell, which reached 0.5 PC discharge rate. Then it was upgraded to 1 P discharge rate. Nowadays, commonly used these two containers, NRC Plus and NRX. On NRX and NRS or tenor, I will explain and tell you a little bit later. Here, NRC was 3072 megawatt hour energy in one container. And I will show slides about NRC Plus now. It is standard 20 feet container, liquid cooled, high integrated, high safety, provide good reliability, long life, and high cost performance. It has a new cell inside, 304 ampere hour. Energy capacity is 4 megawatt hours. Operating temperatures from minus 25 to plus 55. Pardon. Product weight 36.5 tons. These cells provide us around more than 10,000 cycles, and state of health of the battery will be around 70%. So it is very good for 2 cycles charge and discharge per day. Then new designed battery pack. These packs we are producing on our facilities from that video I showed in the beginning. This pack already has more than 100 kilowatt hours capacity. It has IP66. Safety, pack technology no fire, no propagation, no explosion. It is confirmed and guaranteed by CATL. This is degradation curve of 200 ampere hour energy cell and 306 ampere hour cell. You see, EPC area for 200 megawatt hour project, even in this upgrade NRC plus, is saving 13% of land and 30% of containers. You need just 57 containers to reach 200 megawatt hour base. This is just usual layout, how it should be placed on the plot. This container solution is even more interesting because it will have better LCOS parameters. Energy and this container is already on market. It's already on market. Energy 640 kilowatt hours. Operating temperatures is already good for close to north regions and let's say for Himachal Pradesh regions in the north of India, because it's running from -30, and we can operate it on a high altitude without derating. It was one of the questions from Power Grid, some challenges for installation on high altitude areas for battery storages. This container is heavy for transportation, 45 tons. But using this container, we reach 385 kilowatt hour energy density per each square meter. We provide long life performance, 2 cycles per day, and state of health will still be 70%. We'll still keep these numbers. In this battery container, CATL replaced battery cell into higher energy capacity of 530 ampere hour cell. This is the layout. This container you can place back-to-back and hand-in-hand arrangement, which provides 20% less area needed for 4 containers. Here is a comparison of LCOS parameters. If we use NRC container, then we need 108 containers. For NRX, it will be enough 71. Number of PCS for NRC, 27, for NRX, 18. And land area is 40% less. Once we compare number of containers with NRC Plus and NRX, then LCOS parameters will be better on 21%. As I told before, NRX container was started last year. And now this year product, TENRS or NRS, which will make a new generation of energy storage products for utility scale projects. It will have 6 megawatt hours, a new cell with high performance, again 2000 cycles per day and 20 years lifespan, and SOH more than around 70%. It can be used in low temperatures. It has 0 degradation up to first 5 years exploitation. First 5 years you have 0 degradation. High performance liquid cool system allows to reduce auxiliary power consumption up to 20%. Also important point to be mentioned. This container can be operated in even lower temperatures, from -35. Product weight is almost 50 tons. Once we are talking about 50 tons weight of container, it will be very difficult for transportation and installation. That's why CATL is providing disassembly and assembly solutions. It can be portion loaded with packs and then just installed on site, assembled on site. So each compartment has 10 packs, battery boxes. That's why you can use portion loaded, just half loaded, to reduce weight for transportation. As we see before, CATL works with different PCS producers, and they also provide modern solutions in containerized PCS plus transformer assets. So here it is a 20 feet container with 20 feet container size solution with PCS and transformer together, mid MV transformer. Just shortly summarize the battery products by CATL. It has 1 hour duration, 2 hour duration, and up to 8 hour duration. System power goes from 3.8 megawatt to 6.2 megawatt hours energy capacity for NRS. He's mentioned typical cases for power generation side usage of energy storage systems from CATL. First project was implemented and now operating in 2011, so more than 14 years ago. I hope this is introduction was enough, and if you have any questions, I would like to answer on them, and thank you. Thank you.
Thank you, Mr. Timothy, for that insightful and forward-thinking session. Your expertise in battery energy storage is truly invaluable. We now open the floor for Q&A session. If you have a question, please raise your hand and our volunteers will bring the microphone to you. We request 1 question per person at a time. So looking forward for the questions.
Yes.
Yes, we do have questions.
Yes, you have given very nice presentation.
Could you please close?
Nice presentation. Just can you tell me the energy storage system for your grid and peak load and the frequency? What's the response time of this energy storage system when I need it very badly?
Yes, it can be used because variety of usage for energy storage system mostly goes from PCS. Usage goes from PCS and EMS system, energy management system. But then you collect it with proper battery. For frequency regulation and fast response, we mostly use 1 hour battery with 1 P discharge.
No, my question, if there is a generation outage, suddenly I need some power.
Yes.
If I don't have spinning reserve, in case I am using battery storage,
yes.
So how fast it can support me?
Yes, it can support it because...
how much that time?
Depends on energy you have. Depends on energy capacity you have. How many containers you put, then so many hours you can reach. Depends on containers.
No, is it not fast response? That means if there is a load rejection suddenly, or generation
10 minutes, fast response, 10 minutes, 30 minutes, 1 hour.
Okay. Okay, and how much is the conversion loss? That means you are putting it in, and that means, let's say, solar, renewable, you'll be charging it, and then after discharge, that means what is the output I am getting? Conversion energy.
Up to 96%.
Okay.
Hello. There is a lot of potential in India for this storage system, either EV or ESS. We are having a lot of generation during daytime. Our total capacity is more than 400 gigawatt. But we have to construct transmission system for RE for some hours. RE system, RE power is available for some of the hours, and we have to construct. Then there is a cost comparison between the battery storage system or transmission system we have to construct. So how we can do like that? Because in India we want that somebody should set up plant also. We cannot depend upon import of this battery system, or our government wants that whenever we go for any type of technology, there must be a manufacturing facility also in India.
That's why our goal is to start service facilities in the territory of usage, in the territory of demand. Because if we have on site here close to customer or service provider for transmission system, and we need emergency units for replacement, better to produce here and to have skilled labor from service provider together.
Yeah, there are two aspects only. One is the cost and other is the availability.
You have custom duties on battery cells 6% and custom duties on battery racks 21%. That's why on the question of cost, better to assemble it here. On the question about fast response, once you have battery pack in Delhi, really in Delhi, then it can be replaced in couple of hours.
So CATL has any plan, but because it is a, I think, land border issue and all that is in. Suppose in India there is a lot of markets, so do you have any plan or we can go with
We like Storen, an international holding company for Zentech and our Chinese entities. We do have intentions to place our production facilities in India either. And service facilities, because once we designed factories for Romania and for Brazil, the request was to supply skilled labor from China for at least 6 months. They have to provide teaching local engineers and scale it up.
All right, do we
Hello.
have any other question? Yes, we do have, please.
Myself, Thargavat Thapa, and from Nepal Electricity Authority. Actually, Nepal Electricity Authority is facing challenge during the peak time. So we are also in process of installing this battery storage system. So I'd like to know that regarding your 4 megawatt-hour battery storage system, what will be the cost around? That is one question. And then what is your plan for recycling or recycling, and then the or you can dispose. Okay, this was a plan. This is the main important aspect that I'd like to know. Thank you.
If I got you correctly, 4 megawatt hour storage, it's possible to be installed in high altitude territories. About recycling, globally, I don't know why, but it has some concerns that it has some hazardous issues and some pollution. But once we are talking about chemistry of the battery cell itself, then it is lithium, iron, phosphate, for fertilizers. So it's not raw materials, it's not hard metals. Once CATL is making the recycling by themselves, and several others in China, they are making the recycling by themselves. Their ratio of secondary raw materials is up to 95%. China is buying secondary raw materials from battery recycling plants.
Thank you. Actually, that cost part or price part, that
Pardon me.
around.
Pardon me.
Thank you.
All right, we would be taking the last question from you, sir.
Sir, myself from NLC India Limited. In India, we have 10 megawatt first battery storage system commissioned in 2020. But you have already told your storage loss is energy is 96%. But we are having 20% loss. Any possibility is there to improvement for existing system, sir?
Existing one, you mean?
Yeah, whatever existing we are having 80% efficiency only. So in that, any possibility is there if we can increase up to 96%?
You need to replace battery cells and battery packs. Then you will reach. One main attention, please. Once we are talking about BMS, battery management system, there are 2 types, and I'm sure you have your battery system from China. This one, yes?
LG came.
LG, okay, LG also. LG also. To reduce pricing, they were using passive BMS. So now your system is charging and discharging by the lowest battery cell inside the system. So the battery cell degradation is different. Speed of degradation is different. That's why in your 10 megawatt hour battery system, you have, let's say, 10 battery cells with capacity less than 80%. Then your charging and discharging goes just on this level.
Okay, sir. Thank you. One question from me. My question is regarding household use of your battery energy storage system.
Household?
Household
yeah.
use. Okay. Now, have you done any studies on cost comparison? Like suppose you have a solar rooftop and you have a battery system. And what is the per unit cost comparison if you consume that solar energy through battery system and the energy drawn from the grid itself? What is the cost comparison? Have you done any studies on that?
Dear friends, can we discuss cost-wise questions just personally, please?
Okay.
Okay, because it's very sensitive for public.
Okay.
Then I won't be able to answer to others why I told these numbers. It depends on the scale. It depends on individual situation. Let's discuss just on networking, please.
Okay. Another question is about a lifespan. Lifespan for household batteries and others industrial commercial batteries, are they same or different?
The same. It the second our partner is company named Ampace.
Okay.
Ampace was established by CATL, I think, in 2022.
Okay.
Now they have lithium iron phosphate cells with lifespan 15 and 20,000 cycles. Okay. For particularly residential storage battery modules and packs, it is pouch cells. So it can be even longer.
Okay. Okay.
Well, thank you so much, everyone. Due to time constraint, we won't be taking any further questions. That was a highly engaging discussion. Thanks to our audience for your thoughtful questions. To honor our esteemed speaker, may I now invite Shri Anup Singh, CEO, Power Grid Energy Services Limited, to present a memento to Mr. Mikhail Timofeev as a token of appreciation.
Thank you for invitation. Thank you.
Once again, thank you, Mr. Timofeev, for your invaluable insights, and Shri Anup Singh ji for joining us in this honor.
Thank you. Thank you.
Thank you so much, sir. We now take a short tea break, take this opportunity to connect with fellow delegates, exchange ideas, and reflect on the insightful sessions we've had this morning. We request you to return promptly as we will begin our next session, panel discussion on green finance and investment, sustainability in power transmission at 11:45 a.m. sharp. Enjoy your break and see you all shortly.
The future is closer than we think. Using digital technologies, we're implementing futuristic solutions to make quantum improvements across all our businesses, resulting in smart engineering, smart manufacturing, smart project management, smart infrastructure. The future is closer than we think. Using digital technologies, we're implementing futuristic solutions to make quantum improvements across all our businesses, resulting in smart engineering, smart manufacturing, smart project management, smart infrastructure. is closer than we think. Using digital technologies, we are implementing futuristic solutions to make quantum improvements across all our businesses, resulting in smart engineering, smart manufacturing, smart project management, smart infrastructure. The future is closer than we think. Using digital technologies, we are implementing futuristic solutions to make quantum improvements across all our businesses, resulting in smart engineering, smart manufacturing,
Mic check, mic check, mic check.
smart infrastructure.
Mic check. Mic check, mic check, mic check.
is closer than we think. Using digital technologies, we are implementing futuristic solutions to make quantum improvements across all our businesses, resulting in smart engineering, smart manufacturing, smart project management, smart infrastructure.
Well, ladies and gentlemen, we'll be restarting our session soon. It's a very humble request from all of you to please kindly be seated as we're about to restart our session. Ladies and gentlemen, as we reconvene, we shift our focus to an area that is pivotal for the future of energy: green finance and investment sustainability in power transmission. With increasing global commitments to carbon neutrality and ESG frameworks, financing green energy projects has become a critical enabler for achieving sustainability goals. To guide this discussion, we are privileged to have an esteemed panel of experts who will share their insights on the opportunities, challenges, and investment frameworks shaping sustainable finance in the power sector. To moderate this session, we are honored to welcome Mr. Manpreet Singh, Partner Climate and Sustainability Advisory, PwC. And now, let us welcome our distinguished panelist, Mr. G. Ravishankar, Director Finance, Power Grid. Mr. Sanjeev De Silva, Councillor, Energy and Resources, Australian High Commission, New Delhi. Mr. Wolf Muth, Country Director, KFW. Mr. Tarun Shankar, Senior Investment Professional, International Finance Corporation. Mr. Arpan Garg, Executive Director, Corporate Banking, SMBC. Mr. Singh, the stage is now yours. Over to you.
Hi, good morning, everyone. Thank you for this morning session to be present here and be listening. I have with me a lot of esteemed panelists today, and I think it will be a difficult task for me to be managing so many distinguished delegates who have their own perspectives on green financing. I mean, in general, like when we were chatting in the room before this panel, and Tarun said, how do you classify transmission projects as green? I think probably that's the first question we need to answer today on, what is really green? And, in our experience and since the last 2 decades of me figuring out what's green, being in this sector on climate sustainability, when we've been, challenged many a times on saying, what do you consider green and what do you don't consider green, and then the whole concept of greenwashing, which has in the recent past have hit many of those corporations who were making a lot of statements on green, being looked at more and more seriously, more and more comprehensively now. And so it is important to define what really is green financing. And to our benefit, there are many organizations who've tried to do that. Now we have taxonomies, which have now come up, which clearly define what's climate friendly, environment positive, or green. So we have one example from the Climate Bond Initiative, which describes the climate bond taxonomy. We also have now the European Union Sustainable Finance Taxonomy, which also clearly outlines what should be considered as sustainable or green when it comes to financing. And in India in particular, we have now guidances from the market regulator like SEBI, who've also referenced themselves to some of these international standards. But I think there is no longer a lot of debate on what's green and what's not. If you look at EU Sustainable Finance Taxonomy, it clearly outlines that dedicated infrastructure being developed for transmission of clean energy, be it from wind, solar, or other renewable energy sources, can be potentially categorized as green if the overall grid emission factor remains lesser than 100 grams of CO2 per unit of energy, right? So there is a threshold, there is a benchmark now at least defined by the EU. We also heard from our Honorable Finance Minister in the budget speech that India is on the verge of defining its green and climate finance taxonomy as well, which means that we will also have a clear outline of how the power transmission infrastructure projects could be classified as green. Now, moving away from the definition of green itself and the debate around it, in India, we definitely do need, a large infrastructure requirement for the more ambitious target that we've set in the last many years. So we now have a 500 gigawatt hour of renewable capacity addition, which is also going to be plus. So we are going to increase our ambition under the Paris Agreement, as we have, stated therein. We are seeing, at least in the last few years, we've seen the prices of solar come down. We have now, looked at a lot much capacity addition than we had ever imagined we would have of, solar in particular. So with these developments, the increased need for power transmission infrastructure is only growing. I think the studies that, at least I could access say that between 2022 to 27, we need close to 4 trillion rupees, of infrastructure requirement that has been projected. In the next 5 years thereon, we need another 4 to 5 trillion rupees. And post 2032, we would need even more. So I think we're looking at a figure of over 10 lakh crores, that is going to be the finance requirement. So with that context, let me, go to my panelists and first invite, to you, Mr. Ravi Shankar from Power Grid to, maybe continue in the line that I've, tried to set the context of and talk about how you are seeing, that requirement only growing. What are the plans that Power Grid has in place, and how increasingly so you're looking at accessing the green finance alongside the commercial lending or commercial finance that you have access to. So we'll start with you, sir.
Yeah, thank you, Manpreet. I think you have already set the tone for the session that how do you classify a project as a green? When you say the electricity is fungible goods, then once it's generated, it loses the color as to whether it is generated from green or from coal or from thermal. So, the projects which if you see today, almost all the projects today, Power Grid has got almost 1.6 trillion of projects in hand which need to be executed in another maybe 5 to 6 years of timeline, and almost all the projects, if you see 99% of the projects are for the evacuation of the green energy, be it solar or wind or even it's offshore. And there is a wind, there is a solar and wind coming up in Pang area, which is of course a unique project where then this, the question comes that financing a project, again now we are telling about the green financing, again another word is added, that sustainable green financing. So how do you how do you ultimately the we are actually, there are only the vendors and lenders. So initially, how do you give confidence to the vendors when they supply, and how do you give confidence to the lenders post commissioning? So the transmission is not about simply wires and towers. Now, since so many renewable energy integration is coming up, then how do you integrate with the grid? How do you have the security of 24/7? How do you mix the power and to ensure that the power is continuously available, and how do you do it on an efficient method? So the sustainability comes that I cannot have much redundancy, so that ultimately the end payers is the consumers. So how do you make efficiency in the grid? So this is how the planning will be effective, so that you make the minimum investment to have energy available 24/7, and at the same time the clean energy is maximum you are able to tap. Today when you have that out of 460 gigawatt of the installed capacity, we are already crossed 200 gigawatt of the installed capacity in the non-fossil, and the target of government, as you have already indicated, like 500 gigawatt by 2030. And the other day also, Honorable Minister has told that the plans of the government, of course, at a very premature stage is like 2040 and 2050, like it will go to like 1200 and 2000 gigawatt of RE generation. So huge potential of transmissions is going to come up, because without transmission, you won't be able to, the load centers at one point and the generation is at one point. So even in the generation also, if you see, you have a concentrated energy resources and there are distributed energy resources. When you say distributed energy resources, mostly these are all of the rooftop, which normally is consumed almost in the same area, whereas you have a concentrated energy resources in the sense fossil fuel, you have a coal. At the same time, if you see in Rajasthan and Gujarat, there are huge potential of renewable energy sources which need to be transmitted to the other parts of the country, so that the load centers at other points. And you are coming up with not only AC lines, now we are coming up with the DC lines also, because there is a optimum maybe like 500, more than 600 kilometers. If you have the load centers, it is wise to put a HVDC instead of AC lines, because the other thing is AC lines behave in such a way that it finds the least path, whereas in HVDC you have a control to regulate the power from one end to another, and then you have a facility of the HVDC where you have a reverse power flow. So in India, if you see, there is a eastern side is non-fossil, fossil, as well as the western side is non-fossil. Incidentally, it happens like that. And how you will have the energy security, how the energy will flow from today. When I say the 200 gigawatt as the installed capacity of renewable, since still you have around 13% as the mix of RE today, but the target is it may have to go up to like 30%, 35%. So the RE generation will go up, and how the sustainable investments will happen. So I think I would pause here and then we can continue later. And thank you.
No, thank you very much, Ravi Shankarji, for setting that context. And I think it's very clear that there is a huge demand, there is a huge planning that needs to happen. If we were to integrate the demands coming in, not just from a power demand perspective, but also now we are looking at electric vehicles integration, and which is again going to lead to more and more demand generation. So let me come to Mr. Wolfmuth, you from KfW, and being a global development bank, and KfW was, I think, instrumental in financing the green energy corridors, in which is where you kind of started with, I think, with Power Grid as well. So what has been your experience in terms of not just in India, but in other emerging economies? How do you see power transmission, projects being funded? And are there certain criteria that you look at in particular when deciding on, whether or not you would want to go for such kind of financing? So if you could throw some light there.
Yes, good morning, everybody. First of all, let me congratulate to the Indian nation to win the championship in cricket yesterday. I have to admit I'm not an expert in this cricket, but nevertheless, it's fascinating always to see. Okay, getting back to the serious topics here, talking about green energy. I mean, KfW is among the biggest climate financiers in the world. So it's not only where we do business in India, we do business all over the world. That is our mission. We are a state-owned bank and we are impact-driven. So we are a promotional bank. We are not a commercial bank. We don't want to optimize our margin. So our target is to come up with impact, and especially to finance the green energy transition. And a lot of the discussions we have here in India also reminds me to the discussions we have now in Germany. Transmission is key for each development of the energy transition. And what we are facing in Germany is right now also the fact that we do have a lot of renewable energy production in the northern part of Germany, but due to a lot of discussions, hiccups, delays, and so on, our transmission line is not able to evacuate this power to the areas of consumption in the southern part of Germany. And therefore, and also you always should keep in mind that renewable energy projects probably just take a half of the time you need for a transmission project. So you always have to factor in, if you move ahead with a renewable energy production, you always have to look very closely to the transmission line. And therefore, we are very glad that we are involved here in the financing of the green energy corridors right from the beginning. So in 2014, we did extend not only a loan to Power Grid, our esteemed partner, Also, we are involved in 9 states here in India. In 7 states, we did finalize the project, I think 5 or 6, in 2026. We did start in 2014. They are finalized already, fully dispersed. We are now engaged in 4 more states, and we hope to finalize the project by 26, 27, something like that. So as I said, transmission is absolutely key. And from our perspective, so what is our role? I mean, we have seen already the big numbers which is required. And despite that, the fact India has achieved a remarkable step forward in the last decade. I mean, you remember, you did start from 20 installed gigawatt of renewable energy, and now you are more than 200 gigawatt installed capacity. It's 45% of the whole capacity, gigawatt capacity here in India. So it's fantastic. And this speed will probably, will have to move ahead, but this means with each gigawatt you do install, you also have to close look on the transmission line. So this is always, one has to repeat this, and then one has to figure out this, one has to stress this. And as I said, not KfW alone cannot simply finance this, and I'm always amazed by these huge numbers you're talking about. I always get, it drives me a bit crazy to see these big numbers. So what we have to do is to step by step to look on the targets, and what can we do next year, the year after, and so on and so forth. And there is an overall target in the near future when we want to be carbon neutral. We are talking about 2017. It's a very long time ago, but we have to make sure that the next steps are well planned, that we can cope with the required speed, because the renewable energy, there is a big development, the private sector is jumping in, we see a big appetite from the private sector coming in, and also KfW, since we're just here to trigger the development. We are not a private bank, we are not a private investor, so we only can actually, as I said, we can trigger the development. We are glad to co-finance projects with other esteemed partners, but the majority of the financing has to be done by the private sector at the end of the day. Let me stop here. We will continue here with a fruitful discussion. There's a lot of things to add, but I think I will stop here.
Thanks so much, Wolf. And I think that takes me to Tarun. IFC has been in the forefront of development finance since several years, and I think looking at my interactions with many of your senior investment officers on the bonds that IFC has released world over, also in India, the kind of private sector partnerships that you've had in India and abroad. So would you want to share some experiences, especially pertaining to the power transmission sector, where you've engaged maybe also with the private sector, but largely what do you see the models emerging globally, and how could those be adapted in India, if you could throw some light on that?
Hello. So firstly, thanks for the opportunity to come and share a few of our observations. International Finance Corporation is the largest private DFI globally. Our intent is to get private capital to infrastructure, and I'm very happy to share with you that transmission was rightfully identified as one of the sectors that we wanted to support much early on. I would say almost 20 years back, we started looking at transmission, including transmission in India, and I think we would be probably the only institution in the only financing institution in the country with the largest, who has the largest sectoral exposure to transmission as part of the portfolio. Because otherwise, a lot of financing institutions do have exposure to generation and other parts of the infrastructure value chain, but we seized that opportunity. And as one of my senior colleagues who's also sitting in the front row today rightfully mentioned, that there is no transition without transmission. So I think we did recognize that specific aspect much early on, and have been working on various aspects in terms of products to help the transmission sector. For instance, even in 2012, when we did partner with Power Grid to take them to international commercial syndication for the first time, we did evolve a structure where we brought in Japanese banks to come alongside us as part of the consortium package for what is typically a long asset of 20, 25, 30 years. Financing in this country was not available at that time for more than 10 to 12 years, but we did design those structures wherein long-term capital could be clubbed along with hardcore commercial short tenor capital, and the financing package could be provided to transmission clients. We have done even selling down of exposures to insurance companies way back in 2007. We did green bonds for transmission in the last couple of years. So, I mean, we have been testing the market with new products on the transmission side, and we will continue doing so with the intent that more investment is required. And I'm of the firm belief that what brought us here as transmission in this country, whatever financing tools were used, we have to now think through and design new tools. The same tools cannot take us to the next level that we have envisaged in terms of the investments in this sector, which are expected to be 3x, 5x going forward. The same traditional tools will have to be redesigned. We have to get back on the drawing boards to help clients essentially test the waters both in domestic markets as well as international markets.
Thanks, Tarun. And I think some of the terms that Tarun used are pretty important. So, which means long-term financing, which is what we need for transmission infrastructure development. We also need new financial instruments, and Tarun alluded to the use of green bonds for transmission financing. We need concessional finance. We need lower interest rates, but we also need policy support. And with that, Mr. De Silva, let me come on to you on policy perspectives in particular, and your experience in Australia and and now in India. When you kind of compare the regulatory framework, do you see there are requirements for new policy development or something innovative that you would want to illustrate, which is going to help in financing the new infrastructure that is required for the country? So some light on what your sort of perspectives are.
I guess for me, there are two issues here. The first is green finance and climate-specific finance. And in Australia, we have launched a huge package of measures called Rewiring the Nation, and invested billions of dollars in concessional finance specifically to upgrade our transmission infrastructure. Also, our Clean Energy Finance Corporation has specialized expertise in deploying that kind of finance. We have other green bonds programs as well, and I know India is beginning many of the same issues. However, I think one of the aspects that to get the best bang for our buck for those green finance specific measures, we also have to make sure that the fundamentals of the investment environment are sound and improving. Because otherwise what you find is that simply because a sector is new or it's related to energy transition, we are deploying concessional finance in areas which really should be bankable anyway. And so there are three issues that I would pick up there. The first is around, of course, investor confidence. And even this morning, I was talking to one of the largest mining companies in the world and one of Australia's largest miners. And while that's in a different sector, I mean, it's related to the critical minerals involved in the energy transition and things. The critical factor is not, in my mind, this might be controversial, merely the cost of capital. The critical factor is that it does not matter how volatile or how complicated an investment environment is, provided that the investor can upfront be aware of those challenges and be able to put in place safeguards and manage them. So I think clear communication and building investor confidence by flow of information is critical. In Australia, we have over the last 6 years implemented what's called the Integrated Systems Plan for our country. There is a widespread consultation. My mentor, a person named Alan Finkel, sort of established that program whereby the energy market operator in Australia consults very broadly, and then every 2 years publishes an integrated systems plan which very clearly sets out what the planning is towards net zero. So information flow is one. The second is, I think, upskilling and making sure that our finance professionals are across these new areas, and specifically areas like grid, which is so full, as you know. I mean, this room is probably crowded with engineers, very detailed and very specific areas of expertise. I find that finance professionals usually take some time to be confident that they know enough to enter that area. And that's where, you might have specialized agencies like the green finance agencies in Australia. The final component is, of course, the regulatory environment. And this is one probably where even, Australia can certainly improve, and perhaps we can work together with India. As we try to balance the need for protecting natural ecosystems, biodiversity, and all of those things, we need to ensure also that we're not undermining or unduly elongating regulatory approval processes. Of course, if a country or a jurisdiction starts to develop a reputation for being too hard to enter, then especially when you're looking at transmission projects which cover many kilometers of area, then finance, investors will be put off. So those two things are critical for me.
No, thanks, Mr. De Silva. And I think what you've alluded towards is the need for the regulatory environment to attract financing in the sector. And with that, let me move on to you, Arpan. And I've been hearing since morning you are the latest financing organization for Power Grid, and I think I think everyone here will be keen to understand what sort of criteria that you had in mind when you were looking at the portfolio of Power Grid, and were there some specific criteria that SMBC looked at? What were those, and were there any risks that you identified to that financing, and how were those managed through the process? I think I'll be very great for everyone here to look at what those criteria were. So over to you.
Thank you. At SMBC, we are very keen to facilitate the adoption of the green energy, and obviously if you look at be it the transmission, distribution, we would say it is a very integral part of the entire renewable energy penetration in the country. So from that context, SMBC have always been very keen not only to fund renewable projects, but also the transmission, and not only transmission, I would say even the associated infrastructure, be it your smart meters or the advanced sensors, or even the technologies which help, say, in forecasting, or basically in the adoption of the clean technology. So on the same context, given obviously the opportunity which we have in country when it comes to funding the transmission projects, and as you mentioned in the initial discussion that there is a 10 lakh crore which is going to be spent over the next 8-9 years. So there is a huge opportunity which SMBC also wants to tap. In terms of the framework, so we have our internal taxonomy, which is again, I would say, is aligned to the global standards, but what we also try to incorporate is the local nuances so that we remain relevant wherever we are funding. But at the same time, we want to be globally credible when it comes to the financing parameter. So based on that, we select the projects which we can probably have be able to tag as the green financing, and we can support the various developers in terms of the financing requirements. And obviously, if you look at any infrastructure, I think the key is the capital, and the cheap capital, because that drives the penetration of the infrastructure in the country. and the green finance, if you look in terms of, even if I look at the green bonds, which we talked about, so already I think the annual issuance has crossed now $1 trillion. So it's a huge market which can be mobilized to fund the infrastructure for facilitating the green energy adoption in the country. Thank you.
Oh, thanks very much. And you spoke of technology, which brings me back to Mr. Ravi Shankar on what's the role of technology, you see when you look at creation of more and more sustainable transmission infrastructure in the country. I know you spoke of SF6 transformers in the morning. I think there is a long way to go when we will be able to actually displace those. But having said that, what do you see is the role of technology in institutionalizing smart grid infrastructure and the efficiencies that come in alongside that, if you want to throw some light on how you are looking at that growth in the future?
Yeah. You see, this ESG compliant is, now it is becoming an integral part of the business. So whether we are very keen, we are not confined to only this scope 1 and scope 2, although we started evaluating that how we can go forward to address the scope 3 issues also. As far as scope 1, scope 2, yes, we are actually transmission, we are not a pollutant company. As such, only the breakers and transformer oil, we have some SF6 gas leakage which causes the pollution. Otherwise, whether we use the auxiliary power or we are going ahead with the green tariffs for all the substation auxiliary power, thereby actually we can make it green, and we are replacing the vehicles with electric vehicles. And then the SF6, yes, we are talking to have the alternative which is environmental friendly. This is about the one. And when you say the other point which came up, the smart grids, yes, how the predictability should be there. Now that when you say the green energy, it comes with 3 characteristics: that it is unpredictable, this is seasonal, that is intermittent. So how would you tackle when you say the energy security of 24/7 I should ensure through the green energy? It is, we have the equipments like renewable energy management centers are there which can predict the energy generation for the next few days with a 15-minute interval. So India started adopting the 15-minute interval right from the beginning, unlike other countries which started with half an hour or 1 hour intermittent. Now that they are planning to 5 minutes to move to 5 minutes interval, which the other day CEA chairman also has pointed out that India is also will be planning to move to from the 15-minute interval to 5-minute interval, which will give more accurate predictability, so that how can we have the mix of the fossil fuel also wherever we find the shortage. So this type of technological advancement is going to happen, and then even not only in the construction, it is also in terms of maintenance also. So today we don't call it as maintenance, we call it as asset management. So everywhere now it is about the management of the assets, which ensures the availability, because again to have a 24/7 you have to keep your assets also. Now Power Grid has already demonstrated of 99.86 as the availability. It is even beyond the threshold limit of 99.75, up to which we get the maximum incentive. So the maximum availability maintenance, and how do you predict the maintenance? How do you utilize the AI technologies, the vegetation growth, or the fault locators of the transmission lines? How do you make it through the digital transformation, so that you make the line availability almost? Because you see, the tariff structure supports the investors as far as transmission is concerned, because the transmission charges are paid for the availability and not on the quantum of energy transmitted. So that actually gives a comfort to the lenders that at least the regulation supports for the recovery of the transmission charges for the investments they have made for a significant period. Like if the asset is for 35 years, the regulation says whether it is, we have 2 routes, whether it is a regulated tariff mechanism or the projects which are awarded through the tariff-based projects, where the regulator supports the, traditionally also they have demonstrated that last 15 to 20 years, the return on equity was given a decent 15.5%, and then recently it's just stepped down to 15, but still they have given the return on equity to the hydel projects. It depends on the time at which your equity remains idle, so that's why they have kept it as a 15%. So this actually gives the confidence to the lenders that how, and the other the regulation supports is the interstate billing as a POC mechanism. So today, if a company wins a project, and then if it's as an individual SPV, if it execute the projects, let's say for a state X, and if the, even if the state X is not paying, all other 28 states, if they pay, they get a share of the revenue. So thereby, the regulation supports, at least they get a revenue irrespective of the where they supply the power. So this type of regulatory changes in India has helped the lenders to give a competitive rate. So I think this is every 5 years these regulations are reviewed, and then we see that it always encourages the investment in the renewable energy sector, because renewable energy is the one which has got a zero raw material cost. I think we should make it full utilize of that. Thank you.
No, thank you so much, sir. I think that was quite a pitch to all the financials sitting here, so I'm sure they're pretty much convinced. But that brings me back to you, Mr. Wolfman. I mean, what does the KFW financing come with? Like, I mean, of course, you look at creditworthiness of the developer, you look at bankability of the project itself, but what other elements? And I'm pointing towards your ESMS requirements and ESG requirements. So would you want to throw some light on, you know, how important those requirements are for you, given that the project is already bankable, the balance sheet is pretty strong, but then, you know, KFW being a development bank and impact thereof becomes, you know, quite an important criteria. So would you want to share, you know, what those criteria are and how important those are to your lending, and how do you track it across the investment cycle?
Yes, thank you. Well, good questions actually. And I mean, just to add what my colleagues here mentioned already, I think time is really of essence. When you look to what we are, in which phase we are now, I mean, we have really ambitious goals, and what we see when we are in our project implementation, we are always facing some delays. And I don't want to blame anybody, but it's so multiple elements you have to look at it. It could be delays in the tendering process. It could be delays in project implementation. You're facing issues with the right of ways. So in all these kind of things. And then also you have to address E&S elements. For example, when we come up with the big transmission lines, you also have to look, for example, to bird migrations. So we also installed the relevant the diverters for migrating birds to protect bird migration and something like that. So these elements has to be addressed, because in the end of the way, you always have to communicate these projects to the population. And this is also one important aspect I want to address. You have to sell this. You do need the acceptance from the population, because when you come along with a transmission line or with the RE project in a specific area, you do need the support from the population. You know, it's not only to give them some compensation for the right of ways, you also have to convince them about the benefit, what they see, the outcome. You know, there is a reliable power supply. It's environmental friendly. There's a CO2 reduction and so on. So it all pays into a greener future. And the more you get the support from the population, the better it is. The less delays you have. And that's also what we also similar, as I mentioned. You know, we do have different discussions in Germany. For example, everybody was saying, yes, we want to move ahead with green energy because it's sustainable. The energy is much cheaper. It's absolutely, the prices are coming down. Also with this battery storage, also a key element which should also be integrated more and more into the transmission network. The prices come down. The private sector, for example, in Germany, they are also submit a lot of projects they want to install over the next year. So there's a big demand. So we did trigger the development, and now the private sector is taking over. But the private sector wants to have reliability, a clear decision-making process. It was already addressed, the regulatory environment and all these kind of things. But the more delays you're facing, even in our project, on one side we make remarkable progress, but sometimes you're also facing delays, which is causing additional costs. Then you're losing the support from the population, and then you're facing some issues and so on and so forth. So it all factors in, and I think the better everything is prepared, you have a strong team together. I mean, if you are dealing here with Power Grid and other partners, I mean, there's remarkable expertise, but you have to form a strong team, you have a good timeline, and then you can really achieve everything on time. And that is actually, we are looking forward. But in the end, of course, you have to make the whole business attractive for the private sector. And then we can achieve these nice goals.
No, thanks very much, Mr. Wolf. And I think you kind of dodged my ESG question. But I think, to everyone, like, of course, KfW has a very strong ESMS requirements that come in alongside the financing, which actually ensures that any environment or social impact associated with the projects are taken care of. And there are systems put in place to monitor those, throughout the process. And we've been a part of, some of those lines of credit where they've been put in place, which brings me to you, Tarun, on collaboration and partnerships, and IFC has been at the forefront of those as well. And given the challenges and the risks, and increasingly so, the requirements from investors on, for example, making sure that the assets are climate secure. So there are the climate risks, if there are those, along the linear infrastructure, they've been taken care of during, the investment stage itself. How do you look at nature and biodiversity issues when you are, constructing the infrastructure? And IFC has its own performance standards alongside these new requirements, which we keep on hearing from the developers that, okay, we have an IFC loan and, we need X, Y, and Z. And so looking to your, views on one, collaboration partnerships, and how do you see that evolve internationally? And second aspects on, how you are easing the way financing could happen, I mean, ease of doing business, if I can call that, and how you're ensuring this through the various things that come alongside your financing as well.
I don't think he dodged the ENS question. He did answer it, but you wanted to ask me also and put me in a spot by asking ENS. See, I know, I mean, the DFI community by and large is accused of having ENS standards and then sticking on to implementation of those standards. But let me reiterate, I mean, they are not a deal breaker, right? I mean, as I mentioned earlier as well, we have been working in this space for more than 20 years in India. And Power Grid is a classic example of how ENS has been put scientifically in the way they do business. I think what needs to be done is to do capacity building for state transmission companies to start appreciating those same practices which is being adopted by Power Grid. I mean, I can tell you, it's not that difficult. I think some of the points were alluded to by Wolf as well. Yes, it could take time, but once it becomes part of your DNA, it's much easier to go and access finance. And I'll again revisit my earlier point that we have to think about new ways of providing capital to this sector. If we are going to look at a specific asset and start appraising individual asset as the way it's done, given the huge, humongous investment requirements we have, it would be a challenge to get that kind of capital on an individual asset basis. So we have to look at new ways of funding. But I mean, on ENS, and you mentioned IFC performance standards, yes, IFC's performance standards are in a way looked at by the international community as well in terms of being a barometer for, in a way, endorsement for international capital. But I think we have worked with several clients in this country who appreciate these standards and who are not afraid of going the next step. So, while Indian regulations and laws would require something, but I think in the larger interest of looking at community stakeholder consultation and basically benefiting communities, we have lots and lots of good examples and best practices in India as well. So all that we need to do is to, I think, show them, share with the practitioners and the stakeholders in transmission, and I think the money will flow.
I think I'm for all the ENS standards. I'm a consultant myself, and that's my bread and butter. So for sure, there are benefits in terms of integrating ENS into the investment, and we've seen clear examples of how many projects have actually averted what could have been a significant risk if those issues were not one recognized initially itself and addressed before the actual investment in the project took place. So I'm all for that, and Mr. De Silva, I'll come to that. With that, how do you think? And we've not heard so much from Australia on this ENS integration and financing. So, do you want to throw some light on what's going on around in that part of the world? And while there are obviously developments on Australia taking a lead, we've seen carbon pricing coming up, then going down, markets coming up and going down. So there have been fluctuations in at least the regulatory regime in Australia when it comes to climate change. So how do you see that impacting the way you look at partnerships and thereof also financing international power transmission projects?
No, it's a good question, and I think, to be very honest, that has been, I talked about investor confidence. It shakes investor confidence when at a political level, things shift a bit. I mean, behind that high-level focus shifting between different sides of politics in Australia, the underlying energy system, both sides are investing and doing the, successive governments have invested in that infrastructure and tried to make it strong. I talked about the integrated systems planning that has gone a long way. Australia is the largest per capita deployer of rooftop solar technology, and the partnership that the Australian government and the Indian government launched by Prime Ministers in November, that renewable energy partnership, a focus area is on rooftop solar. So we actually just at the in a couple of weeks' time, we are bringing, for example, a delegation of Australian expertise in rooftop solar integration. So these are companies that do grid simulation, like Energy Exemplar. There are companies that are deploying smart meters and other digital enabling infrastructure to integrate rooftop solar into the grid better. So that kind of technology transfer and technology partnership with India is of great interest to us. But I think you raise a very good point. I mean, the political environment in a number of our countries shifts a lot. I think that is one of the things that has been a great benefit of the Indian system. Since 2014, I think the commitment around the renewable energy drive has been consistent. A very, very senior Australian official called and asked me just the other day, now with the change of administration in the US, do you see, because in my system, I'm very bullish on the opportunity of India, the renewable energy drive of India. This official was asking me, do you think that will impact how India approaches it? And I said, categorically no. India, I see that from the senior leadership in India, a commitment to the drive to push renewables as being pretty consistent. And, that probably applies to all energy sources in India, but that is one very strong aspect of the Indian system. I think where we can work together more deeply is in the really structural aspects of what, as this renewable energy penetration increases, as Australia has been experiencing for a number of years, there are challenges to the grid, and that's why actually my team is seeking a meeting with Power Grid for this delegation that will be here in India just next week. So you know, I think there's a lot of fruitful things that can happen that way.
No, thanks so much, Mr. Silva. I think that's really encouraging to see that. I mean, we all need new financing. We all need you know, more and more new models to come up, but also access to technology has been, you know, one of the important aspects that India has been putting in the forefront, even when it comes to the Paris Agreement and, you know, the kind of technologies that India has identified under the bilateral cooperation in Article 6.2 of Paris Agreement. So we have listed down, you know, the technologies that we are interested to cooperate and collaborate with the world on. And, you know, of course, it remains to be seen what kinds of advanced technologies that we get access through that bilateral cooperation. But I think that's on the cards. And coming back to you, Arpan, again, so you've been on the spotlight, like I said, you know, very fresh round of financing done. I mean, very interested to know about how did you integrate ESG aspects into this financing. I also hear that its financing is linked to certain amount of environmental performance. I mean, I may be wrong, but then of course, environmental performance has become a criteria when SMBC has been looking at green financing and, you know, especially sustainability linked loans or environmentally linked loans, which are linked towards the ultimate performance. You know, from an environmental positive value creation or a societal value creation. So any thoughts or anything you want to share on broader methodology that you have, and also was it applicable to your recent financing?
So for the loan which you are talking about, the power grid, I think it is more from the green financing framework and not the sustainability link, because sustainability link something which we try to do in sectors where we cannot apply the green principle, be it cement or something where, or like what IFC has recently done for, say, the road sector for the cube in width. So for the PGCL, it was more in terms of the green financing framework. So obviously there are multiple projects which are catering specific for the evacuation of the renewable energy, and which classifies into the definition of the green project, and that's how we have looked at that financing in particular.
No, thanks for that. And I think that opens you know, it up for the audience. So please identify yourself, tell us who you want to ask the question to, and we'll go ahead from there. Yes, sir, you have a question. Can we have the mic here, please?
Yes, we do have the microphones. Let's just pass the microphones.
Sir, my question is to Tarun Shankar, sir. Sir, how do you evaluate the non-financial issues, social issues, ESG issues, while making investment sustainability and financing in sustainable way? That is my question, is to non-finance issues. How you evaluate and what is your take on that?
Tarun, is for you.
So I'm sorry if I understand your question. You're asking how do we evaluate ESG as part of our
ESG and non-financial issues, sir. Social issues and the ESG issues. ESG issues is mostly non-financial, sir.
Right. So when we look at any financing, we look at essentially what is the environment and social impact of what we are doing. And I think as part of that, we do extensive assessments, we do stakeholder consultations, we try and understand for ourselves as to what is the impact that that specific intervention would do. Is there a large environment and social footprint, or is it and even if it's a large footprint, is it manageable or not? And what we essentially do is we capture all that assessment that is undertaken and we disclose it to the public at large. So every investment of IFC is disclosed on IFC's website before it is posted to IFC's board. So before we even take it to the board for approval, we inform the entire world, basically this is what we are doing, this is our assessment, of environment and social impacts, this is the way we plan to manage it. And if any stakeholder feels otherwise or feels that certain aspects have not been looked at, there is a way for them to respond to us so that that can be corrected. And this disclosure is normally kept open for a month or 2 months depending on the categorization of that environment and social impact. So that allows us to do any mid-course corrections even before we have committed or signed the loan agreement. I think that's a big thing in terms, I think, and by and large, if I can stick my neck out, it's followed by the DFI community to a large extent in terms of incorporating any suggestions, feedback on environment and social aspects.
If I may add here something, because I think it's also quite important, I mean, also from our perspective, as you're completely right, I mean, in the beginning, we make a fully fledged analysis of the project with a feasibility study and addressing all the ENS aspects and so on and so forth, but also quite important from our perspective, from KfW's perspective, with the financing or with the signing of the loan agreement, it's not over. So we are still accompany the project through the whole implementation, and we do make midterm reviews. We make a final assessment of the project. So after the last disbursement and after 2-3 years, we also make a final assessment and see if we were able to achieve our goals also from an ENS aspect, also from or other aspects we want to achieve, not only from the performance of the project and so on, so also with the impact on the population and so on. So we are really from the beginning until the end, so the whole life cycle. I think it's also quite important, which differentiates a development partner like KfW maybe from a purely commercial bank.
Good morning. My question is for Shri Revolt Moth. Sir, KfW is involved in financing green power projects or green projects. Sir, I have noted it down as a climate risk increase globally. How is KfW adapting its financing model to account for climate resilience in power transmission infrastructure?
Yes. Well, I get a question. I mean, it probably would also like pass on to my colleagues. Of course, I mean, climate change doesn't stop. And if we look around what's going on here now politically in the world, I mean, yes, this is a challenge, and there's a lot of things. Yeah, I mean, yeah. Beside of this, climate change doesn't stop. What does it mean? It means, in the end of the day, it will add up the costs to the project, definitely. I mean, if you look, I mean, we are involved in some kind of, how is it called, stormwater management. You know, in the past you had a drainage system in an urban town, in an urban area, but all of a sudden the standard drainage system doesn't work at all because you have these huge floodings and so on, the forth, and the drainage system is not able to cope with it. The same, you know, all of a sudden you are facing with storms and specific weather conditions that all of a sudden a standard construction for a transmission line simply doesn't work. So you have to, whatever, you have to enforce the foundation and so on and so forth. So it's causing additional costs. This has to be factored in, because if you don't make these kind of calculations right from the beginning, then the cost in the end will be much higher when you actually have to reinforce after the construction and so on and so forth. So definitely these kind of things has to be factored in. We have to look more to extreme weather conditions. For example, you have to now factor in landslides, floodings, and all these kind of things. So definitely that is a point. I mean, we have to address this with a good, well, to avoid additional costs. That is definitely something we have to cope with. So a lot of costs will be absorbed to climate change. That is, and this is an additional burden one also have to think about. It's not a new technology, also to make the existing infrastructure more resilient. That is also something we have to take into consideration.
Manpreet, I would add one thing on the remarks of Tarun on the intrastate. Yes, we have already formed a JV with Rajasthan for development of intrastate, where we'll be putting 74% equity and they'll be putting 26% equity. That you are talking about the capacity building. So I think this model will help the states to build the capacity that how we can guide the best practices which we adopt in the interstate transmission system developments, which we can adopt in the intrastate also. And we are already talking to other states like Assam, Odisha and Tamil Nadu, how we can form a JV and then we can take up the intrastate projects, which will help in the same practices as we are following in the interstate. And with the closing remark, I would like to only tell that the mantra of Power Grid is wealth to investors and value to Power Grid. So we don't want wealth, we want only value, but wealth to investors. Thank you.
No, absolutely. Do we have time for one more question? Or
Yeah, we can take one more question, sir.
Yeah, yes, please.
Yeah, good afternoon all.
Yeah, please go ahead.
Yeah, my question is to Mr. Shankar. Mr. Tarun, given the IFC's experience in funding the infrastructure projects globally, what is your take on blended financing structures? And do you think that these in any which manner can be used to mitigate some of the risks of green transmission projects, especially in emerging markets like India?
Absolutely. I think it's a fantastic question also given the audience that we have in this hall. We have many more engineers. So my only request is please go and adopt and embrace new technologies. Whether it is LVDCs, MVDCs, replacement of SF6 or maybe high or new kinds of conductors, please embrace new technologies because blended finance can then be availed and tapped. And blended finance is not only for a lower interest rate on debt. There are several blended finance structures which could be brought in even to absorb and protect equity returns of listed companies. So Power Grid is a listed company, but there are other entities also who may have to ensure that their downside is protected. There are enough financing structures available through use of concessional capital, which could be deployed on untested technologies and new areas within transmission. So I think that is something which is very much par for the course. Just two things on climate change. Transmission has been a harbinger of change. And I think the financing that is going on transmission should be classified as climate mitigation and climate adaptation and not necessarily climate mitigation. The problem is everybody talks about climate change and says you target climate. But within climate, it should be climate adaptation, which is, I think, a fantastic thing which transmission has done. And I think we should encourage and push for that. And final one area is also security. So grid security, whether it is national or domestic within the state, is something which needs investments. Whether it's smart technologies or artificial intelligence being used, that's another area where capital is not scarce. There is enough capital available, but those technologies and tools needs to be adopted.
All right. That was a highly engaging discussion. Thanks to our moderator, Mr. Singh, all our panelists and audience members for their participation. Well, I request you all to please kindly stand for a group photograph, please. To honor our distinguished panelists, may I now invite Shri Rajesh Srivastava, Executive Director, QA&I and FQA Power Grid, to present a memento to each of our esteemed panelists and moderator as a token of appreciation. Well, I request to kindly present the memento to Mr. G. Ravishankar, Director, Finance, Power Grid. But we are presenting it to our moderator. Well, now I would request to kindly present to Mr. G. Ravishankar, Director, Finance, Power Grid. Now I would request to kindly present the memento to Mr. Sanjeev De Silva, Councillor Energy and Resources, Australian High Commission, New Delhi. And now I request to present to Mr. Wolfmuth, Country Director, KFW. And now I would request to kindly present the memento to Mr. Tarun Shankar, Senior Investment Professional, International Finance Corporation. And now to Mr. Arpan Garg, Executive Director, Corporate Banking, SMBC. Well, thank you so much, everyone. Once again, thank you to our panelists and the moderator for such an insightful discussion. Thank you so much. Ladies and gentlemen, we now turn our attention to an increasingly critical aspect of the power sector, digital transformation and skill development in power transmission, the power grid of the future. Well, ladies and gentlemen, we'll be starting with our next panel discussion in next 5 minutes. So it's a very humble request from each one of you to please kindly be settled. We'll be starting our next panel discussion in next 5 minutes. It's a very humble request to kindly please be settled so that we can start with the session. Thank you so much, everyone. Well, it's a very humble request from each one of you to kindly please be settled as we are restarting our session. Thank you so much, everyone, for being so cooperative and being here with us. We are restarting our session. It's a very humble request from all of you to kindly please be seated. Ladies and gentlemen, we are starting with our session. It's a very humble request from all of you to please kindly be seated so that we can start with our session. Ladies and gentlemen, we now turn our attention to an increasingly critical aspect of the power sector, digital transformation and skill development in power transmission. The power grid of the future will be intelligent, automated, and driven by data, integrating technologies such as AI, IoT, and digital twin solutions. However, with this transformation comes the need for workforce, upskilling, cybersecurity measures, and capacity building initiatives. To guide this discussion, we are honored to have Ms. Amanjeet Mukesh, Partner, Digital Transformation and Cybersecurity, Energy, Infrastructure and Manufacturing, PwC, as our esteemed moderator. Can we have a huge round of applause, please? And now, let us welcome our distinguished panelists who bring expertise in technology, workforce development, and power sector transformation. Dr. Yatindra Dwivedi, Director, Personal Power Grid. Mr. R.P. Singh, Chairperson, Board of Governors, IIT Kharagpur and IIT Bhubaneswar. Dr. Tripta Thakur, Chairperson, NPTI. Professor Sukumar Mishra, Director, IIT Dhanbad. Mr. Anish Dey, Global Head for Energy, Natural Resources and Chemicals, KPMG. Dr. V.K. Singh, CEO, Power Sector Skill Council. Ms. Mukesh, the stage is now yours. Please proceed.
Yes. So thank you, panel members, for joining us. Again, as we're talking about power transmission sector overall at a juncture where a lot of digital technology innovation is happening. At the same time, how do educational institutions like NPTI and IITs are coming together to bridge the skill gap? So we have esteemed panel members here. We will discuss about digital transformation journeys and how do the academia organizations fill the skill gap. So with that, if I can start with Dr. Yatindra Dwivedi. Sir, as a director personnel for Power Grid, how do you envision the future of power transmission, and what are the skills that you are building in your organization to bridge the gap which should map back with this future of transmission sector, sir?
Good afternoon. Thank you very much for inviting me here. Before I start the discussion, I would like to throw some points related to power transmission sector and how the load centers are shifting. As we all know that in 1947, the installed capacity was hardly 1.4 gigawatt, and now it is 466 gigawatt, and by 2030 it is expected to be 800 plus gigawatt. So this is the installed capacity requirement, and per capita electricity consumption was also very meager, 16 units per capita consumption was there in 1947. As of now, it is hovering around 1400 kilowatt hour per person. And by 2030, it is expected to be around 2000. But it is well below the world average also. And the developed countries are above 10,000 units. And even the German, France, they are all hovering around 7,000, 8,000 units per person. So a target of 4,000 units per person consumption is also a very good target for India. But I want to discuss about the load centers. What is happening in India, that lot of data centers are coming. The use of artificial intelligence and machine learning is happening. And you know, the data centers are very energy intensive. A lot of power consumption takes place in data centers. If you take about take the large scale data center, around 200, 300 megawatt, so it consumes the energy of total population of Jaipur city, the domestic population of Jaipur city. You can imagine. So, and if you take medium-sized data center, it will consume the electricity of Bareilly, Shahjahanpur, any city of normal medium-sized city of the UP. So, whole domestic consumption of Jaipur city or Bareilly city or Shahjahanpur, any other city you talk, domestic consumption of sum total of all consumption takes place in one data center. And the urbanization of these cities usually come up in 8 to 10 years, 10 to 15 years. But data centers are coming up in 1.5 years, 2 years. So the load centers are shifting a lot because data centers are coming. So earlier we used to have load centers related to domestic consumption, agricultural consumption, and industrial consumptions. But now the requirement is for data center. The data centers consumptions are huge. So these are the shifting in the load. Similarly, if I talk about the artificial intelligence and machine learning, if you run the artificial intelligence models on the desktop, I'm not talking about the mobile, they usually consume 7 times, 8 times more electricity. And this is happening all around the world. So the consumption of power in artificial intelligence modeling models and analysis, it's almost 7 to 8 times. So earlier we used to predict that the load will be increasing due to domestic, agriculture, and industrial load. But now the loads are shifting towards the data center and artificial intelligence. So requirement is huge. So similarly, the transmission sector also taking care of a lot of transmission networks we are building, and skill set requirement. So what we have been doing in maintenance of these transmission systems is not going to be the same way which will happen in the next 10 to 12 years. So a lot of digital transformation also is happening in asset management, like predictive maintenance of transmission assets we are doing for circuit breakers, transformers, and insulators. Then machine language models are being used for vibration and temperature and current patterns, analyzing the current patterns. Self-healing grids have come up, and then vegetation management for satellite imagery and drone data. Similarly, for transmission projects, route optimization, we are using artificial intelligence and LiDAR drones. Then best tower placement, artificial intelligence, we are using digitization, we are using. Then supply chain optimization, the tracking of materials, logistics and procurement things. This is all happening through artificial intelligence and analysis of machine learning. And then grid operation, real-time grid monitoring, then real-time forecasting, even the 15 minutes forecasting is happening in India. So lot of churning take place. Yesterday I was going through the stalls put up by the startups and students. So out of total 25 stalls, 21 stalls, they are using artificial intelligence and machine learning in their way, in their models or in their physical models also. So this is all happening a big way. Similarly, dynamic line rating is also being taken care for weather forecasting and weather sensors adjustments. And cybersecurity in transmission systems is also happening. Digital twins, like in Germany, they have improve the asset life cycle by 20%. So we are also going for digital twins analysis. The virtual substations and the physical substations, they are combined, and then we do the analysis part. Scenario-based practice, predictive modeling also we are doing in our digital transformation process. And cybersecurity initiatives, we have taken a lot of center of excellence we have also made. So these are the basic aspects of the digital transformation happening in transmission sector, and what is the future requirement.
Thank you, sir. I think as the world is evolving, Power Grid itself is also evolving, aligning with the digital transformation. Very nice to hear that. So with this, sir, Mr. R.P. Singh, ex-chairman Power Grid, chairperson BOG, IIT Kharagpur and Bhubaneswar. Sir, based on your experience, you've seen the power transmission sector, you've seen the power sector evolve. What is your wisdom that you can actually share in terms of how the ecosystem worked in the past? What do we need to change, how the ecosystem to make the power sector successful in the future as well? What are the threats you see as this evolution happens, and how do digital transformation, skill gap come together? So what would be your piece of wisdom to this group, sir?
Good afternoon. After quitting Power Grid, after 17 years, this is the first public address where I am appearing before all of you. So excuse me if I talk something nonsense. If I talk something good, please appreciate it. Friends, madam, electricity, whether it is a boon or a bane, this is a question today which is being addressed at the international level. Boon, everybody talks, bane, nobody talks. Am I right or wrong?
Right.
Am I right or wrong? Tell me. Bolo bhai, Tyagi sahab, you agree? Okay. So, I have seen as a village boy how electricity was essential for education for the children in the village, and especially in 1968 when Bihar suffered from a worse drought. The moment electricity came in 1968, everybody was happy, happy and happiest. But it became a bone of contention for whether power is available in the village or it is only for the city. So far, whatever planning we have done and whatever we have achieved, though we talk that we will serve to the masses, we are basically city-centric electricity. And there was a thumb rule when I joined TISCO in 1971. I was taught that 50% of electricity generation should be at the load center, and 50% can be imported. And then it was that around 60% electricity supply should be from thermal side and 40% should be from the hydro side. Peak, and to meet the peaking and non-peaking requirement, hydro side. We have forgotten the thumb rule of power sector, and it is followed internationally. Somehow we have forgotten it, and reason is because of the rise of NTPC, NHPC, NIPCO, Naveli Nigride, Power Grid, and now private companies and all that. So there are push and pulls. Fundamentals have been forgotten. Now with the advent of solar and wind energy, there is more and more thrust, and it should be. Nuclear is also important, and I appreciate government's decision to establish 1 lakh of nuclear power plants, modular structures as quickly as possible. By 2030, I don't remember exact date, but it is a welcome sign. Then rooftop on buildings, individuals building 1 crore. It is another welcome sign. Now what is needed is, I don't want to waste your time because everybody has talked and all that. What is important today is that we have to go back to the old power system of India before independence. We have to create local generation, transmission, distribution, and participation of the public at large. What I call it radical inclusion. I don't know how many of you have. I see Sen is shaking his head because I have shared with him. I shared with Madam also. Unless the consumers are participant in generation, transmission, distribution, commercialization, and payment, nothing will happen. We talk so much about smart meters. I read the data today in the morning that only 5% of smart meters have been, despite so much of hoopla across India under RDSS scheme that will go for smart meters, smart meters, smart meters. Only 5% has been set up so far. It is not an achievement. So the problem is that we talk too much and execute less. Because there is no radical inclusion. Radical inclusion means a man on the street, he should know the pain and pleasure of reaching electricity to his house. How much problem is there in supply chain, in setting up the power plant, arranging money, arranging equipment, etc., and then he gets electricity. There is no appreciation because we have not taught them. People simply know that we switch on the light and electricity comes. If it doesn't come, it means ये सब सारे बदमाश हैं, सब चोर हैं, इंजीनियर लोग सब बदमाश हैं, and इनकलाब जिंदाबाद. That will not work. We have to radically include. And I was sharing with Madam that radical inclusion is in our blood. We have not exploited it after the independence. You look at the emblem of Udaipur state. If you look at it, in the background is sun, and the king is on the left side, and the wheels who used to manage their supply chain, food, etc., fight for the king, they are on the right side. That is where we have to say that power sector radically includes the people, migrating to and including the villagers, common man on the street, as a generator, transmitter, distributor, and collector of fees. On a different platform, let me share when I visited Argentina and Brazil in 1998. I was so surprised. There, jhuppi jhoparis, shanty houses are very effective, very strong, and absolute gundas live there. What did the government do? They included them in distributing the power. Gave the local fellow the authority that this meter is here, we don't know how you do and how do you do. You supply the money, electricity, and you pay the bill. So friends, the problem today, Madam, is that we have to change our platform of serving the masses and masses serving to us. It has to be a two-way communication. It can't be only one-way communication. Free revenue will not do, number one. Number two, I am a strong advocate of technology. Technology is a mere tool in the hands of the mankind, whether you use it for good purpose or bad purpose. And best example is nuclear technology. It was invented to serve the people. Today it is the worst threat. Today it is the worst threat. Now look at electricity. It is needed for artificial intelligence, IoT, data communication, everything. But what is the problem? Problem is bad use of too much of communication, cyber attack, intrusion in your or your confidentiality in information technology and as well as in operation. More and more digitization, more and more technology, more and more threats are there. So therefore, I am glad that somebody from a power grid set told me कि सर हमने जो अच्छा किया कि optical fiber अपना dedicated लगाया. So naturally we have maintained air gaps between information technology and operation technology. It is working fine. But how long? The moment system grows and grows, there will be more and more problems. So therefore, whatever action is taken by the government, by Power Grid, by NTPC or others, and lot of monitoring is happening from Ministry of Home side, other institutions have come, CRC is there, CA is there. We are doing fine, and we should do fine, and whatever is happening worldwide, you can't isolate yourself. But important is that the radical inclusion is a must, and technology we should use it with a positive hand for positive purposes. And in the last, I like to share with you that a few quotes I like to mention with you, and I especially picked up for you. As you delve into the discussion, I am reminded of Thomas L. Friedman's observation in his seminal work, Hot, Flat and Crowded. Friedman highlights the paradox of modern development, a world that is becoming hotter due to unchecked pollution, flatter due to advances in communication and digitalization and industrialization. So what is hot, flat and crowded? Population growth. Powered largely by electricity and above all, mankind's greed, and more crowded and medical breakthroughs increased population pressures on the already burdened earth. So what has become hot, flat and crowded. So therefore it is pain. Unless we control what we discharge in the sky, I don't know, many of you may not be knowing, 50 billion tons of CO2 and methane every year we discharge in the sky. And we are treating sky as an open sewer. It has to stop. Since first industrialization, temperature has gone up by 1 degree centigrade. You are seeing the effect. What is the effect? If we remain unchecked, in next 10 years, temperature will go up by 1.5 degrees centigrade, another 1.5 degrees centigrade. If we gradually, what we are talking, we control pollution, this and that. If it goes unchecked, temperature will go up by 4.5 degrees centigrade. And we are treating sky as an open sewer. So friends, the challenge today is not only cyber attack, the attack which we are creating ourselves by treating sky as an open sewer. Thank you, ma'am.
Thank you, sir. Yes, ma'am. So, Dr. Tripta, we spoke about, Mr. R.P. Singh spoke about radical inclusion in terms of technology, in terms of people and digital disruption that is going to happen. With you focusing on NPTI, what are the overall sector skills that you are focusing on to develop that matches with this energy transition that even RP spoke about? So nuclear reactors are going to come up, and how do you evolve? What's the overall sector skills that you're focusing on?
Thank you so much. Thank you GRIDCON and Power Grid for giving opportunity to discuss about this. As Singh Saab has mentioned, the skill is very going to play a very important role, especially in the power sector where the energy transition is happening. So in this energy transition, we are focusing on digitalization, we are focusing on decentralization, we are focusing on electrification. So new and disruptive technologies which are going to play a major role. We are just in the verge of computing which are going to improve because of the quantum computing. And this is really going to change the entire scenario. So NPTI being national body for training and capacity building, so we are trying to impart the new skill to the sector professional. So NPTI is floating a lot of programs in data science, analytics, cloud computing, digitalization, and the use of AI and generative AI in the sector. Also, we know that when we are focusing on digitalization, the another threat which is going to come is cyber security. So we need to make our grid cyber resilient in future. So when this 2021 in August, when the CA came up with the guidelines, so we came up with the ministry has given mandate to us for the cyber certification. So we are providing cyber certification, basic level, intermediate level, as well as advanced level. So far in the past 15 months, we have trained and certified 3,000 power professional. But lot need to be done, because if you will not come up with the skill, especially when we are talking about real-time control, data, RTOs and transmission line, then we really need to train our manpower. If we will not train our manpower, we are not going to be with the what we are forcing in future. As Yatin Dwivedi ji has mentioned, our per capita consumption is 1/3 of the world average, but this is going to increase when we are having objective to become a developed nation by 2047. Not only this higher manpower skilling, but there is a need which Mr. V.K. Singh may put more emphasis, but I think there is a need even for the lineman to get the proper training and certification, which is entirely a missing link. We are subletting our contracts. The contract person, he is bringing the manpower, whether manpower is certified or not, that is entirely missing. We, NPTI and also Power Grid are imparting hotline maintenance training, but this hotline which is in the transmission sector, it is going to come up in distribution also in future. Because when we are talking about 24/7 power supply, which is the objective of Ministry of Power, we are able to give power supply to everyone, but the next focus is to give supply to 24/7. We need to come up with the distribution sector lifeline maintenance. Then only we will be able to give 24/7 supply. So all these new skills give lot of emphasis on training and capacity building. First time, as the Singh Sahab has also mentioned about RDSS, we know, sir, how difficult it is for the DISCOM to cope up with the objective of RDSS. But fortunately, this time the ministry has given and allocated very specific funding for training and capacity building under RDSS. Similarly, in the PM Surya Ghar Yojana, the ministry has given a dedicated objective of training the DISCOM professionals, because ultimately they need to bear what is going to come up as a PM Surya Ghar Muft Bijli Yojana. So training should be a mandatory component. I am requesting even regulator that why can't the distribution, generation and transmission company, when they are putting the ARR, annual revenue requirement, why can't they put a one dedicated budget in the ARR if regulator actually give them permission? So maybe this will be structure in future, but future is not possible if we will not train our manpower, especially in the upcoming technologies which are really going to change. We have seen the application of computers for replacing our files and paper, but the coming time with the quantum computing, this is going to replace our physical workforce in future. So we should be very ready. The time is who is adopting the technology, coming up with the technology, they are going to lead the world. So India also need to take an initiative in this direction. A lot of startups and ecosystem which Dwivedi ji is mentioning are going to contribute in this front. And so I can stop here, but training and capacity building, I am looking forward. If anyone wants very specialized training also, we can design for that. Thank you.
Very nice to hear, Dr. Tripta. Skill development is an integral to that, and you are actually helping the front line actually to get trained. So very nice to hear that. So now let's shift the focus to the academia, and Professor Mishra, to you. As we already spoke about, I think Dr. Jitendra spoke about a lot of digital transformation that Power Grid itself is actually executing and they're doing. what would you suggest as what are the upcoming emerging technologies in the future in the power transmission sector that industry stakeholders should actually focus on?
Good afternoon, madam. Thank you for giving this opportunity. The previous speaker has already told many things about the use of digital technique in different aspects. And two important aspects which probably might have slipped from their mind is, one is PMU and another is the electric vehicles. So as R.P. Singh sir has also already mentioned that distributed generation is the future, and the distributed generation will take care of the renewable also in a big way. So based on this philosophy, if we see the consumer, which is today so-called consumer, is going to be prosumer in the future. He will be a producer as well as a consumer. So under that circumstance, how do you make the tariff? Under that circumstance, how do you make a business case so that both transmission company, distribution company, as well as the generation company will coexist? Now, if suppose the consumer, which is today, become prosumer totally, and also demand a transmission or distribution connection to their local home, is it possible? How do you make it? Maybe the fixed tariff will increase, the variable tariff will reduce, some new thing will come up. And when that happens, the digital transformation is very much important, especially the blockchain will come into a big way. So whatever Dr. Dwivedi has already mentioned, I am not going to repeat. Over and above, I will tell, we should focus on blockchain. And when we talk about blockchain, automatically AI philosophy will come. Again, I am telling AI philosophy will come, because AI is a very, very, very vast thing. And where it stops and where it starts, nobody knows. Therefore, telling this is AI and this is not AI is very, very tough. Therefore, according to me, AI is nothing but adaptability to the situation. And how do you adapt? What is that algorithm that will adapt? What is the parameter to adapt? If we can define, then we will get achievement and philosophical advancement over the other country. Also, I will mention here that India is very good at software, and it is known in the world for the software making in a way, the manufacturing hub of software. And it is an opportunity for us again coming after the declining of the software and coming to the manufacturing hub. Again, we are giving this opportunity of AI, which is primarily a software. So we should not lose that. We should take hold of that. Like ChatGPT is already done, and now DeepSeek is competing with that. Can we make something in India which is Indianized, indigenous, and there the industry role will be very, very important, because the development will be done by someone and will be used by someone else. So if the user feedback is not there, then it may be coming something which may be a demon for the country. Therefore, these 3 points, the data that is coming from the PMU, which is a primary thing for the power grid and our POSOCO and Grid India today, where the reliability and other aspect will be taken care of, and it will be having huge data and intervention of big data, blockchain, AI into the power sector is going to be the future. Thank you.
Thank you so much, Professor Mishra. And I think that's futuristic, correct? We're talking about distributed power, we're talking about more data, we're talking about securing it through blockchain. as well, how the transactions will happen in the future, how tariff will be decided. So many things actually evolve around that. So with that, Mr. Anish Dey, as your role as a global head, energy, natural resources and chemicals, what best practices that you can share with us from your global markets in terms of what we can adopt as part of emerging technology, digital transformation in the power transmission sector, and as well as the skill development that we as a country need to take up?
Sure. Thank you for having me here. So, as we heard from everybody, that the sector has become very, very complex. It's vast and complex. So if you go back, when Mr. Singh started his career, it would have been, those thumb rules were there. Today, it's very difficult to maintain those thumb rules because it's become so varied. You didn't have something like battery storage coming in there. You didn't even think of rooftop solar becoming so large, and suddenly it mushrooms overnight. So we have the asset base, which we don't even know what asset base exists in the sector, okay? Leave aside going to each of them and trying to train people on each of them on a physical basis. So that's where the whole concept of, making training much more accessible, affordable, and impactful becomes very, very important. And that's something digital technologies allow you to do today. So, for example, if you have digital twins of those assets, let me stop and step back a little bit. You have these wind turbines where the hub heights are at 150 meters up, okay? And this has happened all in the last few years. You've got higher and higher. You've got turbines which are 5 megawatt size, on land turbines, not even offshore turbines. You can't send people up the turbine to see, get trained and see over there, see what defect has happened. So you need to have technologies which will allow you to understand the environment inside, including the physical environment which prevails, the temperature, the gearbox condition, whatever, without having to go up there and train people on that. And that's where new technologies become super important, like digital twins. Also, it has to be done in a manner where people can absorb it the best, because you can do it in complex English language with technical jargons, okay? But that makes retention extremely hard, right? And many of these people are not literate, and they're not engineers, right? They're trained to do a job over there, and we need to make this very, very easy for them. And this is where just not the digital twin, but the combination of, say, the large language models you were talking about and the foundation models, in the language they are comfortable. So if they're comfortable in Tamil or Gujarati, it should be able to give you that answer in Tamil and Gujarati in the manner you would ask and consume. That makes retention much more accessible and retention much, much better. It's also not just about training. The same environment is applicable for operations and maintenance. So they should be able to troubleshoot. So if they see that there's something which is coming, and you're getting a feedback to you, you have the question in your mind. You can't go back to your textbook and understand. You can't go back to your trainer and you understand. So this phone becomes your trainer. Effectively, if they put that picture over there, whether the data is transferred out to your central databases and then you get the answer, or sometimes the intelligence resides in the phone itself, in the app itself, you should be able to get that answer in the manner which you consume. This is where digital technologies are making, and combined with AI, in fact, it's never one or the other. We call it AI plus X, because AI combined with IoT, digital twins, and other technology, AR, VR, everything, makes a complete transformation which is possible. Okay, and let's come to power grid and the power transmission system. You have exactly the same problems. You have assets in remote locations, extra high voltage assets. You cannot go physically inspect that asset or training people on that asset. You must have the ability to do it, make it much, much more accessible. And by that, you actually can get the spread of coverage which you need in a complex sector that we have become. So I think it's a sea transformation which we have seen, especially in the last 4 or 5 years, with digital twins coming in, and AI enabling the digital twins to be queried, and the answers coming in the way people absorb it the best. Okay, and I think it's a great opportunity, but we do need advanced tools and techniques for allowing that to happen. So the more effort you put it in the creating those capabilities in the and in a manner that it is absorbed the most easily, the better will this become. And this is not just about, training the EHP for the EHP assets. It's actually training your prosumers as well, we talked about. It's training the citizens, training Dr. Thakur and I were talking about. It's training the woman who runs the household, okay? To make that accessible for her as much as you need it for your super specialized engineer. It is possible today. And I think that's the best part about these technologies today.
Thank you, Anish. And very rightly said, I think we're talking about operation maintenance, digitizing everything. With AI was there earlier as well. It was there even 15 years back. But with Gen AI coming, the evolution is happening very, 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 very fast. I personally have seen, I think in just a 6 months gap when people were talking about Gen AI will disrupt it. But now I think people have started realizing, people who were saying possibly 6 months back that Gen AI will not disrupt their jobs, they've started to realize that jobs will get disrupted with this. So,
but just if I can add, I mean, before people take away a negative view on that, Gen AI can be enormously empowering. So what is disruptive is also empowering. I think we need to understand that it empowers the person, the lost person on the ground, much more than our traditional technologies ever have done.
Perfect, Anish. Yes, and I think that's where Dr. V.K. Singh, how do you see that with this digital transformation, we spoke about AI, the opportunity that Gen AI brings in, to even have our jobs getting done faster and more fulfilling, etc. What are the key skill gaps that you see, and how do you see that as a power sector skill council leading it? How can we bridge that? The disruption is coming faster. The adoption of technologies have to be faster as well. So how do you look at, sir, bridging this gap?
First of all, thank you, GRIDCON and PowerGrid, for giving me this opportunity. Regarding skills, because this topic is skill development and transmission, particularly digital transformation. So whatever my co-panelist speaks about the area they mentioned, these are the key areas where all the skill need to be focused. And the most important thing in skilling is skill is never ready built actually. Most of the organization believe that they can have skill as at their fancy, because even leading organization takes even 1 year to build. Even if you take the best talent from IITs, you need 1 year to top their talent, build them, make them comfortable in the organization. It's just a long process. So my first focus is that you need time, investing time in terms of building skill. And number two, India is a hotbed for skilling. We have a very demographic dividend that helps us. And if we do skilling properly, I think we would be able to 20% of the global manpower can be built in India. That's kind of potential country has. And regarding the digital technology, most of the organization, they are trying to assimilate this technology at the first lap of opportunity. And that's a key area. If you want to be economical, reliable, with safety and all the key parameters if you want to achieve, the most important thing is to get onto the first opportunity where you get a technical know-how. And the most leading organization now, they need to reorient themselves, because instead of waiting for technology to happen, a larger innovation can come within the organization. And another, what I would say, because the people who are closest to the work, they can better innovate than the people at the top or anywhere. I mean, that's so a lot of innovation come from big organizations like NTPC, PowerGrid. They're doing a lot of job. So there are two contrasts also in skilling. I'll say the CA has issued one regulation where they want people in distribution, transmission, generation who are not ITI pass, they should acquire at least ITI qualification. That is one contrast. Other contrast is digital transformation we are talking about. That is for, and people who are not even ITI passed in the distribution sector particularly, it's a very large number. So see, at the one hand, we are trying to make people who are not even ITI passed, make them equivalent to ITI, and on the other hand, we are talking about digital transformation. So both. So what we have seen in skill gap, that we did a skill gap analysis with a big leading consultant, and most of the key areas we realize would be required in the future, they don't exist now, because obsolescence of manpower is very fast. I mean, most of the organizations are facing this challenge. 20-30% of population, the employee they are having, they get obsolete. Even people at the bottom of the pyramid, even the top of the pyramid, getting obsolete with the new technologies. That's a challenge. They need to reskilling, continuously skilling, and that's what they need to do. So skilling is a continuous journey because it has always been there, and leading organization are the one. And I would say that Power Grid is one where the entire turnaround of this company hinged around major focus on HRD, where they could brought a lot of changes in the organization through human resource development. So biggest disturbance in skill ecosystem is getting obsolescence. Whoever you may are, you may be the best IT professional, but if you are not up to date, you will get obsolete. So I think most of the organizations are handling this issue. They need to, the only way forward is the continuous skilling, upskilling, and building talent for the country as well as for the organization. And as a leading organization like Power Grid or NTPC, call on them is that they should build talent for the entire country, not only, and I'm thankful that Power Grid is taking a leading role. They've already started some centers where they're training people for their contractors. That's a really great initiative when you develop skill pool for the entire country. So that kind of focus is required. Most of the leading organizations need to spend not only on skilling but R&D also, which is one area which is lacking in the most of the Indian organizations. We are not spending money in terms of innovation and R&D. There they need to focus. So a lot of technology they can build for in-house use at least. That is my saying. Thank you.
Thank you so much, sir. I think you brought up a very important point in terms of research and development that should be included within our ecosystem as well. So with that, what we will do is with Viksit Bharat 2047, maybe we'll go around the table and one thing that you all can share from your wisdom, your experience in terms of what's in future for digital transformation and the skill development. So we'll just go around the table. And Viksit Bharat 2047, our journey as a country towards 2047, power transmission as a sector is going through an evolution. What would be one suggestion and a takeaway that you would want to have, give it to the audience? So Dr. Tripta, we'll start with you.
Yeah, so 2047, especially in transmission sector, is a huge challenges and opportunity as well, because we are going to add a lot of renewable capacity into the grid. We are also doing a lot of digitalization. So both the challenge which I mentioned are going to be very, very important, and we really need to skill our manpower. Mishra ji has rightly mentioned that I forgot that PMUs and RTUs are really changing the wide area monitoring system in the transmission. So there is a huge requirement and potential for skilling the people with this new technologies which are going to penetrate. Huge requirement for even conflict management, because if you really need to cope up this 800 gigawatt capacity in the coming 15 to 20 years, whatever we have achieved in 75 years, we would like to achieve the same capacity addition in the coming 15 to 20 years. This is very challenging, and right of way, which was not a very issue in India, this is going to come up, sir, in India as well. So we really need to, whatever has been designed. When I joined this sector 3 years back, so I was always appreciating whenever I am discussing that our future planner has really added a lot of transmission capacity. And now they realize that we need to add a lot more in future. So when we have more diversity in terms of renewable capacity, a lot of challenges of system integrations are going to come up, a lot of challenges of cyber resilient grid. Although those who are doing this certains know that how many times different attacks has been reported, but if they materialize, this is going to happen disaster. So we really need to make our people so that everyone will become a cyber jagruk and cyber scenic in future. So a lot of skill scope in the new era which is going to come up in under Viksit Bharat.
Thank you so much, ma'am. RP sir, piece of wisdom at your end, sir.
देखिए ऐसा है, आई टोटली एग्री विथ यू, बट सबसे बड़ी चीज़ ये है कि जब आप खाना खाते हैं और गरीब हैं, डेवलप कर रहे हैं, स्टिल वी आर ए डेवलपिंग नेशन, तो सबसे बड़ी ज़रूरत है हमको, वी हैव टू बी मास प्रोड्यूसर ऑफ इक्विपमेंट, मशीनरीज एंड पीपल ऑल्सो, not population wise, qualified and committed. Today the major problem is what I'm seeing it and across the disciplines, whether it is universities, colleges, or people working on the streets, or domestic servants, or in power grid or NTPC, there is a huge cultural problem today. Nobody wants to be committed. Everybody wants to be glitter loving. क्या सुन रहे हैं साहब? सिर हिला रहे हैं, ठीक बोल रहा हूँ गलत बोल रहा हूँ? इसीलिए मैं हिंदी में बोल रहा हूँ ताकि दिल की बात आएगी. So that glitter loving will not work. Whether we talk in terms of AI, IoT, and how we are going to monitor, everybody knows, and we are very good on IT side. We are leading in the world. Let me share with you today, and I shared with you. I read in news yesterday in the newspaper. Elon Musk has threatened Ukraine. Behave yourself, otherwise I will see that the war is controlled within 3 days. How many of you have read this news? It is a threat. और उस जैसे मैंने उसको पढ़ा, हमको ये इमीडिएटली याद आया तुलसीदास का एक दोहा है, छोटा सा, ज़्यादा याद नहीं रहता हमको, बट थोड़ा सा याद आया. समर्थ के नहीं दोष गोसाई. अगर हम मुस्तंडे हैं, गुंडे हैं, पैसा हमारे पास है, मसल पावर, हमारा कोई दोष नहीं है, हम कुछ भी कर सकते हैं. Therefore, as we grow, as we are growing big and big, power is needed. Electricity is for IA, IoT and everything for our living being. And the reverse is true, that AI and IoT is needed and cyber security is needed for protecting electricity. So there is an interdependence now, and great interdependence. What I said, that it is not only cyber attack which is threatening. The other thing can be the supply chain tomorrow. China can say, जाओ तुम अपने घर जाओ यार, हम नहीं देते, अपने transformers नहीं देते. What is the status today on HVDC? The equipment which used to be supplied, transformers, reactors, etc., in 2 years, they are talking of 4 years, 5 years. I'm sure most of you must be knowing. The worst problem today is the power grid is going to face, distribution companies are going to face, is of trained manpower, not in IT and not in cyber security and AI, to erect the towers and see the projects are completed. Every single contractor, be it L&T, be it Tata, be it Jyoti Structures, be it APAR, or any company, they are not getting laborers. Nobody wants to do hard work. So therefore, important today, madam, is the message I want to send, because all I see here, all senior officers and from various companies and all that, that we have to spread the message that, look here, there has to be a commitment, culture of discipline, culture of performance, and culture of commitment, and culture of spreading emotions. In fact, I am a strong believer that unless there is an emotion between you and me, there will be no motion. We will not go closer to each other. Will we go? No. So today, I don't know what has happened to this country. Emotion has been been the backbone of this country, and today we are totally emotionless. माँ बाप में कोई रिलेशनशिप नहीं है, माँ बेटी में रिलेशनशिप नहीं है, ये अजीब तरह का हो गया है. Where is the question of creating emotion that I belong to power grid? And let me tell you how many of our population employed in power sector or in anywhere, how many they say that I belong to power grid. The theory of belongingness, 20 years back, it went off. फिर आ गया अमेरिकन सिस्टम. भाई आप नौकर हैं, आइए, आपको नहीं काम पसंद है आप जाओ, हम बोल देंगे एज ओनर, और आप कल आपको बोलना सुनेंगे जाओ जी तुम बहुत हमारे पास बहुत ओनर्स हैं, हमारे कहीं और काम कर लें. So there has to be a little bit of emotion. We have to create emotion and commitment of the people that things work. अगर कोई हार्ड वर्क नहीं करेगा, ट्रांसमिशन लाइन नहीं बनाएगा, ठीक है ड्रोन से आप मटेरियल ले जाएंगे, ठीक है ना. अब आज ये भी बोल रहे हैं कि ड्रोन से हम ट्रांसफार्मर भी उठा लेंगे, बट ट्रांसफार्मर के बारे में जानना, देखना, प्रिकॉशन लेना, ड्रोन को कोई बताएगा तो, कोई गाइड तो करेगा, क्यों साहब. एंड देन above all, we are a populous country. हमारा जो गुरु कतवारू गांव में है, ये यहाँ झुग्गी झोपड़ी में भाग के आ रहे हैं ग्लिटर देखने के लिए, what are they going to do? So that वो पॉलिटिकल चीज है और ये है वो है, उसको छोड़ दीजिए. But what I am saying that emotional attachment and education, madam, training only, ITs will not work. Let me tell you एक छोटी सी बात आपको बता दूं. My son wanted to go for IT technology way back in 1994 when he joined engineering. I told him, no, you will not go to IT. You go and become a mechanical or electrical engineer. He is not regretting. आज आप अमेरिका में एडवर्टीजमेंट देखिए, IT प्रोफेशनल प्लेट ले करके कंप्यूटर लेके भीख मांग रहे हैं. ऐसा आ रहा है, देखा आप लोगों ने कि नहीं? सुरेंद्र साहब देखे हैं? एडवर्टीजमेंट पेपर में आता है यार, कैलिफोर्निया का, लॉस एंजलिस का दिखाता है, रोड पर बैठ के कंप्यूटर ये कर रहे हैं और भीख मांग रहे हैं. सो फ्रेंड्स, it is a coexistence, social coexistence. We have to do hard work. We have to do the soft work. And we have to be leader in every aspect. थोड़ा बूढ़े की तरह हम बोले हैं, बुरा मत मानिएगा आप लोग, गलत बोला हूँ तो माफ कर देना. But I thought I'll share with you what I have watched and what I have seen. Thank you.
Thank you, sir. नहीं सर, आपने हमें grounded रखा है कि while we are talking about digital technologies, human is integral, human is the center, and technology sector will revolve around that. Yeah. Yes, sir. Yes. Thank you for keeping us grounded. So, Dr. Dwivedi, sir, what will be your few wisdom that you want to share with the broader
coming
group?
back to Viksit Bharat. So, top skill requirement for the Viksit Bharat related to transmission sector, top 3 skill requirement would be, as per me, would be first is developing the skill for the offshore platforms, because these are the new technologies and we are venturing into it. Second one is getting the skill requirement for the integration of renewable energy related to intermittency and variability. The third would be the storage system and the skill requirement for the energy storage system and integration with transmission sector and the generation sectors. What Power Grid is doing, basically, as Sir was telling that there will be requirement for contractors manpower for building the transmission lines, erecting the towers and stringing. We have started capacity building programs, employee development, capacity development initiatives at Malda and Baka, where when we resource the unemployed youth from villages and then they get trained into power transmission, tower erection and stringing jobs. So we have started, it's already working in Malda and Baka. We are going to implement 2 more in Rajgarh and Bassi and 1 more in Rourkela. So, so skill requirement of that contractors and manpower could be mitigated with these initiatives. We have trained around 6,000 unemployed youth in the power sector skills through Power Sector Skill Council. Another 6,000 unemployed youth we are training in RDSS work, smart metering work, again through Power Sector Skill Council. We have AR/VR lab at Power Grid Academy of Leadership at Manesar, and we get trained manpower through IIIT Bangalore for AI/ML requirements. So we basically develop our own AI/ML experts so that they can develop the whole system. Now, getting one, Dr. Mishra was telling that what India is doing for LLM, he was telling. Actually, LLMs like chatbot, DeepSeek, Copilot, Gemini, Grok 3, these are all being developed worldwide. But India, I think, treading very strategically for small language models, SLMs. So in 5 to 10 years, you will see that world will be having 5-6 chat GPT type things, but India may have thousands Chatur GPT type things.
Very nice.
So this is the strategic development. Our IT minister was also telling that we are going for SLMs, not the LLMs. So that is the strategic, because those are domain specific. In Power Grid also we have developed chat GPT type of chatbots. So these are all domain specific, and a lot of SLMs are being developed in India. Thank you.
Perfect. Thank you so much, sir. And again, SLM is a new thing that we all learned about, right? Small language models. Thank you so much, sir, for that. Okay, so Professor Mishra, what will be your few pieces of advice? And she's already looking at me, so possibly we'll have to, we are between lunch for the audience. Okay. So, sir, to you.
So I'll be quick. So that's an signaling. Okay. So see, when we talk about Vikasit Bharat, we need, the primary thing is vitamin M for that. M stands for money. So how do you get money for the country? So when we talk about money for the country, then one important point what Professor Dr. Singh mentioned is the research and innovation. Because you have to go to something deep tech startup sort of thing should come. And when we talk about research, development and innovation, we need human being to do something new. This chat GPT and other things are not going to give you research and innovation in that. Now when we talk about human being, as Dr. Singh mentioned, industry should have R&D base, that is perfectly good and should have. However, educational institution has an opportunity to have cheaper R&D manpower. Because we give a degree, which is a professional degree like PhD or postdoc, they come to us with a less vitamin M, which may not be true for an industry R&D setup. On the other hand, in an educational institution, we have multiple departments. For example, in IIT Dhanbad, I can give, we have 17 departments with us. And maybe if you take the subset of that, maybe in 200 different domain research are going on. And when these students sit together in the canteen, over a cup of tea, chai pe charcha bahut hota hai. And those chai pe charcha brings interdisciplinary discussions, and that makes something new. So a blend of industry R&D along with the academic institutions is the need, where the focus should be the need of the industry to be clearly mentioned. Now what is happening in the educational institution, we are doing library based research. We go to library, we find out some papers, and my students do on that. Because I do not have a clear cut database what I should do. So there, the country as a whole, industries should come forward, and I am happy that Grid India has started that with IIT Delhi, at least to start with. So they have identified certain problem and they are giving to the academician to solve. So this type should increase, and that will actually give a industry academia flavor where the problem of the industry will be solved, and in the process we will come up with something new, because the industry might not have thought of that it can be solved in this way, because we have that interdisciplinary page. And if we can do that, then in a time frame of maybe 20 years, we will be able to go to Vikasit Bharat. Thank you.
Okay, thank you. So there's clearly an opportunity for the industry and the academia to actually collaborate more. So to you, Anish.
Yeah, very quickly. Let me just call it out. If we really have to go to Viksit Bharat by 2047, then we have to transform from a projects economy to a products economy. Most of our companies are projects companies. They don't make products. And today, Ashwini Vaishnav also called this out. I've been calling this out for a while. And we need to do everything what Professor Mishra mentioned, that Mr. Singh mentioned, without which it won't happen. But the fundamental orientation has to be towards that, and the whole ecosystem needs to come together for that. It could be SMRs, it could be your HVDC reactors, it could be anything. It could be your large language models, foundation models, small language model, doesn't matter. Has to be towards a products economy.
This is a very powerful thing that Anish said. It's about product and not, project is always short term, right? Product is what is actually for the future. You use it for present and for the future as well. Thanks, Anish. Dr. VK Singh, your advice.
मैडम मेरा कोई यही कहना है, विकसित भारत के लिए विकसित माइंड चाहिए, माइंड के लिए स्किलिंग चाहिए. और मेरे को एक शिफ्ट मैं देख रहा हूँ जो अभी तक जो academia was developing. Now industry need to come and develop their talent. But like a big organization, they need, I mean, their dependency on even premier institution need to be reduced. Rather, they can build their own talent actually. So industry need to come forward to build talent. That will be Viksit Bharat. I mean, because industry is much more faster than academia, than anything else backward. That is what I would say. So leading industry need to come forward to build skill and talent in the country, at least for their own consumption.
क्योंकि हम दोनों साइड में रहे हैं, एकेडमिया में भी मैं 20 साल से काफ़ी लगा हुआ हूँ, इंडस्ट्री में भी हूँ. मैं देखता हूँ कि जो एयर गैप की हम लोग बात कर रहे हैं ओटी और आईटी में, ठीक है ना भाई, वो एयर गैप है बिटवीन एकेडमिया इंडस्ट्री. 1965 से शुरुआत हुआ, जब डीएलडब्ल्यू बना था, मैं बीएचयू में इंजीनियरिंग ज्वाइन किया था, कि भाई इस एयर गैप को ख़त्म किया जाए. आज तक नहीं हुआ. मिश्रा जी, मैं गलत तो नहीं बोल रहा हूँ? इसमें दिक्कत ये है कि दोनों अपने अपने एरिया में पंडित हो गए हैं. दोनों पंडित झगड़ा लगते हैं. नहीं तो एयर गैप हो गया ना दोनों में. वो क्या इफेक्ट होता है, जो क्या इफेक्ट बोलते हैं भाई इंजीनियरिंग में, इलेक्ट्रिकल में, जो एक दूसरे को प्रोपेल करते हैं, है ना. दोनों पॉजिटिव या नेगेटिव इलेक्ट्रोड्स हो गए, फिर रिपल्सिव फोर्सेज हो गई है. इसको ब्रेक नहीं हो पा रहा है. इसके लिए थोड़ी सी हमारे पावर ग्रिड लोगों को पता है, थोड़ी सी डंडा चलानी पड़ेगी. बिन भय हो न प्रीत.
So I think, yeah, on this stage we have academia sitting, we have industry sitting, and we have consulting firms sitting. I think we all have to come together. That's the key takeaway. Innovation will continue to happen. With that, thank you so much, esteemed panel members, and I give it to the lady at the desk.
Thank you, ma'am. Thank you, Ms. Mukesh, and a huge thank you to our esteemed panelists for this insightful discussion on digital transformation and workforce development. That was a highly engaging discussion. To honor, before we proceed further, I would like to request you all to please kindly stand for a group photograph, please. To honor our distinguished panelists, may I now invite Shri A. Nagaraju, Executive Director, Southern Region 1 Power Grid, to present a memento to each of our esteemed speakers and moderator as a token of appreciation. While I request to please kindly present the memento to Dr. Yatindra Dwivedi, Director, Personal Power Grid. Proceeding further to Mr. R.P. Singh, Chairperson, Board of Governors, IIT Kharagpur and IIT Bhubaneswar. Proceeding further, kindly present the memento to Dr. Tripta Thakur, Chairperson, NPTI. Proceeding further, kindly present the memento to Professor Sukumar Mishra, Director, IIT Dhanbad. Proceeding further, would request to kindly present the memento to Mr. Anish Dey, Global Head for Energy, Natural Resources and Chemicals, KPMG. And now would request to kindly present the memento to Dr. V.K. Singh, CEO, Power Sector Skill Council. And now would finally request to kindly present the memento to our moderator, Ms. Amanjeet Makesh, Partner Digital Transformation and Cyber Security, Energy, Infrastructure and Manufacturing, PwC. Thank you so much, everyone. It was very interesting and amazing session. Thank you so much once again. Ladies and gentlemen, we now break for lunch. We encourage you to take this time to network, exchange ideas, and connect with industry peers. We request you to return on time as our afternoon session will continue at 2:45 p.m. sharp with a plenary session on grid forming, converter, and inverter technologies. Enjoy your lunch, and we look forward to seeing you back for the next session. Thank you so much, everyone. Ladies and gentlemen, I request you all to please kindly settle down as we are restarting with our sessions. Welcome back, everyone. I hope you all had a refreshing lunch and some great conversations. Now it's time to dive back into action with a session on an emerging and transformational technology, grid forming, converter, and inverter technologies. With the rapid integration of renewable energy into power grids, ensuring stability, reliability, and seamless operation has become a critical challenge. This session will explore how grid forming technologies, including advanced inverters and Statcom solutions, and revolutionizing grid management and enhancing resilience in the modern power landscape. To share his expertise on this subject, we are honored to have with us Mr. Michael Halonen from Hitachi Energy, Sweden. Please join me in welcoming him to the stage. Thank you so much, everyone. Before we begin, let me introduce our esteemed speaker. Michael Halonen is Hitachi Energy's Application Engineering Manager for Grid and Power Quality Solutions and Service since 2014. Michael have been involved in projects for integration of power electronic solutions and power grids across different industries for more than 25 years. In 2010, Michael joined the Saudi Electricity Company in Saudi Arabia, where he was involved in projects for DRPC, series compensation, and HVDC. Prior to this, he joined ABB in 1995 and worked in the product group FACTS in a variety of different positions, primarily in the area of system design, system studies, and commissioning. Michael is the chair of IEEE PES Substations Committees, WG, I4 Static, War Compensators, and WG I9 Dynamic Reactive Power Compensation. He's also leader of several task forces within WGI3, including TF for grid forming. He has authored numerous technical papers and holds or has filed several patents showcasing his contributions to innovation and research. Ladies and gentlemen, let's give a warm round of applause as we welcome Mr. Michael Halonen to share his insights. All yours, sir.
Thank you so much. Hope everyone had a good lunch. I understood that we are running a little bit late, so I will do my best to catch up. I have quite many slides that I would like to share with you today, but let's see what we managed to do. So first, the agenda. We will have a small introduction about the energy transition. I know that we have been speaking about this quite a lot during the conference here. We will continue with Statcom technology, just an introduction to what you can do with Statcoms today that you couldn't do in the past. We will focus on grid forming, look at what you can do with grid forming functionality and how it relates to what you can do with machines. Short information about enhanced Statcom, basically Statcom where you have an energy storage. We'll touch base on grid codes with respect to GFM. What have we done so far? What must be done in the future? One important topic is simulation models. I would like to say a few words about software in the loop. And then finally, comparison of technologies. But let's start with a short introduction, energy transition. So we all know that we are having large integration of renewables and that it is putting a lot of changes into the grid and that we also have a lot of challenges. We have all heard about decarbonization towards net zero. It's ongoing all over the world and many countries have already set up targets when it comes to net zero and also some targets where you should be 2030. So have India. So we have here requirements to be net zero by 2070. And we are also going to have 500 gigawatts renewables by 2030. It's a huge amount of renewables and something needs to be done with the grid to support that integration. We also know that today we have approximately 20% electrification. And we also have 20% of total energy consumptions mainly from coal and gas. 2050, we will have more than 50% electrification. And we also know that the global power system of 2050 will require 4 times today's generation capacity. That also means that we need to transfer more power, and that will be approximately 3 times compared to what we have today. So how to manage that? We also know that the power systems have changed a lot. In the past, we had typically generation in one location and the loads in another location, and then you were feeding the loads in one direction. By the integration of renewables, this will change. We also had very, very limited level of digital information in yesterday's power grids. Today and the future, again, we will have the renewable integration, so basically we will have bi-directional flow in the system. We will have much more need of power quality solutions and HVDC solutions to transfer the power and to support the transfer of the power. We will also use solutions like grid forming to make sure that you can install converter-based solutions and basically replace the rotating machines. The converter-based solutions will do the same type of job. They will have the same price or lower, and they will have less losses. So basically, if we summarize this, so basically what kind of services are required to operate a stable and secure grid, both now and in the future? And generally, I'm using this type of wheel to illustrate which type of services that we have requirements for. So we have voltage control, we have system strength, fault current, inertia, and frequency control, and then of course system restart. And this is the complete set of services. And if you look at the table there, then basically you have the characteristics in the first column, and then we go from today's or yesterday's power grid to tomorrow's grids. So basically tomorrow we know that we will have high renewable penetration. And that basically means that inertia will go down because you don't have the rotating machines anymore. You don't have the large masses in the system. Short circuit ratio will go down because you don't have the machines again. That will have a direct impact on the protection relays in the system. So basically we need to think about if we need to have new relay protection systems. And then, of course, we will have a direct impact on the stiffness in the grid, both when it comes to voltage and frequency. So what about Statcoms? So a few words about Statcoms first. So we have learned to know that the Statcom was developed in the mid-90s. At that time it was 2 and 3 level converters. Those were quite much generating a lot of harmonics, resulting in quite large footprint. And basically over the years we were developing the MMC concept, and then basically we were able to build branches up to 150 megawatts. And we were using the grid following functionality, and most of the converters were connected in a delta. Today, it is possible to build much larger converters because we have possibilities to use semiconductors with higher current capabilities. So it's possible to build a Statcom today up to 400 megawatts in one single branch. That gives quite compact footprint, and we can also use the new functionality which is called grid forming, which basically is providing the same type of service like a rotating machine. This type of system also comes in different type of topologies. So basically we are not stick to the delta anymore. We can use delta, Y, or a double Y. So larger capacity, reduced footprint, increased functionality. For tomorrow, of course, there is also possibility to develop the concept further. And basically, that will be the same type of traditional Statcom with single branch up to 400 megawatts, but we will also include an energy storage. So basically, you will get the e-Statcom, and then you will have also the possibility to provide active power. And we are using the MMC concept, and we have all learned to know also that the MMC concept, when it was introduced, it was fantastic. Because with this type of concept, then basically you have a very, very, very smooth wave shape. That also have a direct impact on the harmonic generation and power quality. So basically, you don't need to have low-order harmonic filters, and it's less sensitive to network conditions. Still, we are using high-pass filters for this type of device to make sure that you have a good damping for the controls in higher frequency range, basically. Reduced footprint, I was mentioning on the previous slide. Since you don't have the filters, you can squeeze down the footprint quite a lot. This type of converters is also coming with high degree of modularity, because you have a number of converter cells that you are just adding, and the number of converter cells is basically determined by the rated power that is required. And then finally, the losses. We are using same type of switching frequency for this type of converters as you did for the 2 and 3 level converters, but the switching frequency is distributed across larger number of cells, and then basically the switching losses will be lower. Typical single line diagram, we will not spend much time here, but you connect to the transmission grid via power transformer, and then basically you have one single branch. Not very much equipment in the yard. It's only the transformer and the phase reactors. Typical layout, quite compact, as I said. So only reactors, transformers on the site. One is connected in a delta, so you can see the bus bars here. And then you have the valves, control and protection inside the building. This type of installation, if you install it in an environment with heavy pollution, then of course there is a risk to have failure or flashover. So then basically there is a trend today to build it like this, where you basically put an enclosure on the outdoor equipment as well. And then basically you have a semi-indoor solution. Very, very low probability for failures. And also lower requirement for maintenance. Now we come to the grid forming technology, that is the new functionality. But first, again, we go back to the wheel here. So what could we do with the technology in the past? So basically we were installing machines long time ago, and that was to provide voltage support and reactive power. Then we had the classical SPCs for many years. It was introduced in the 70s, and then the Statcom was basically developed in the 90s, and today we have this superior voltage support solution available. And then basically it was developed for voltage support only. So basically you could do fast voltage support and slow voltage support, similar to switching of mechanical devices. So this was not very much you could do with the stuff in the past, actually. And now then, if you introduce the grid forming functionality, then basically you are emulating the behavior of a machine in addition to the Statcom. And then a new world is opening up. So this is basically the same type of converter. So the same type of hardware. And then you're adding a control system, which is basically emulating the behavior of a machine. And then you can extend the wheel to all these sectors. So you can provide fault current, which is kiloamp. System strength is more or less keeping the waveform. You can do the voltage control again, of course, because you have the megavars. And then you can also do system restart. It doesn't mean that you can do black start, because that you need to have active power for, but you can restart in much weaker conditions, because you can also provide fault current contribution. And again, it's the same hardware. And basically what we are doing here, we are integrating a machine into the Statcom. And of course, a machine is providing high overload current, 4 or 5 times the machine rating. In a Statcom, it will always be limited to the converter rating. So basically, the amount of short circuit current that you can take out is matching the converter rating. So that's basically the short circuit current capability of a converter. So if you have a 70 MVA machine, that will match 300 megavar Statcom. But then, of course, if you are going to buy the 300 megawatt Statcom anyway, because the requirements for megavars, then you are adding the machine to that one by adding the control functionality. And then you don't need to buy the machine if you need to have that one. So Statcom, it has been there for some time already. We'll come back to that. But basically, the grid forming Statcom and the grid forming functionality, it will be tomorrow ready. And it's designed for tomorrow's power system. What is also good with this type of functionality, I said that you can represent any type of machine. You can do parameterization in the control system. So if you would like to have a machine that provides a lot of fault current, you do the parameterization for that. If you would like to have a machine that is providing damping, you will put in that. And you can change whenever you would like to do that. If you buy the machine, you need to live with that machine for 30, 40 years. And this is future-proof because power systems are still changing. And also it is reasonable to believe that you will have more oscillation frequencies, both in the lower order harmonics, but also in the sub-synchronous frequency range in the future, especially if you have wind farms. So basically, we have learned also to know that the grid following concept, it is basically a Statcom acting like a current source with an impedance in parallel with high impedance. It will be synchronized with the grid, but it will be relying on the firm voltage available, and you don't have the fast instantaneous response, not for voltage and not for frequency. And then of course there is also limitations from this type of device when it comes to how low in system strength can you go down to and still have a robust control system. IEEE says that it should be a factor of 2 between the short circuit strength of the grid and the Statcom size. If you go to grid forming, it will be acting like a controllable voltage source, and then in fact it will be emulating the voltage source behind an impedance, or emulating a machine basically. It will create and maintain its own voltage. It will be synchronized. It can be used both for instantaneous support for voltage. If you have the Statcom, if you're adding a storage, it will also be for frequency. And you can go down to very, very low short circuit strength and still be stable. We'll show one example there, but we are talking about operation far below factor of 1. This technology is not for tomorrow. The technology is here. And it's here today. So basically, a large number of installations have already been installed. There are installations in US, installations in the Middle East, installations in Europe, installations in Asia. And there are different type of applications. So in US, we come back to that. There we have support of grid forming Statcoms for offshore wind farms. We also have in Texas a lot of air conditioned loads, and they have problems with fault delay voltage recovery. This type of application is superior when it comes to to motor stalling. Since you have something that is fast responding, it means that the voltage will not drop as much. So you need to have less bars to bring the speed back again to the same speed where you were before the fault. And Middle East, Asia, a lot of discussions about providing fault current. And in Europe, a lot of integration of renewables and wind. So a lot of projects up running. And on this slide, you basically see the number of the Statcoms that is installed. Okay, now this is actually Hitachi Energy's Statcoms because there are no information available in trade associations when it comes to reference lists for Statcoms. So basically, Hitachi Energy installed the first Statcom in 2018. It was grid following, and this is basically the red bars. And then we took a lot of converters into service up to 2022, where the first grid forming installation went into service in Germany. It was a 300 megavar installation, and it was installed as part of the change of the grid code in Germany. And then since 2022, 23, 24, 25, large number of grid forming installations goes into service, and from 26 up to 30, it is basically interpolation of the expected volume. What is interesting here is basically that there are 20 products in service. We are using grid forming for all different type of applications, for utility, for renewables, and also for arc furnaces. By using it for arc furnaces, you can increase the flicker reduction up to a factor of 8, 9, 10 instead of 6. First product went into service 22, as I said, product in Germany. It's called Opladen. Customer was Amprion. Single VC 300 megavars. Germany has changed their grid code already. So basically it's a requirement to install grid forming devices in the German power system nowadays. Second example here is basically a Statcom in Texas called Lockout. A little bit smaller, it's only 120 megavar. Here we had this problem with fault-induced delayed voltage recovery. By using grid forming, the Statcom do a great job, and basically the Statcom is seen as like a large device in the power system, so you can prevent motor stalling and you can prevent load shedding. Grid following device would require a much larger size of Statcom to do the same job. And then finally, smaller Statcom, only 75 megavar for an offshore wind farm, also in US, in New York. And here the problem was that we had a lot of problems with low short circuit ratio. And that will basically also prevent the relay protection from operating, because if you get the fault, you get also large DC offset. So you don't get the current zero crossing. So you need to push in a lot of short circuit current to get the current back down to zero so the relay protection can operate. Very interesting application. There is a large number of those applications right now also in Europe. When it comes to grid forming, we will not go into the details on all these schemes here. What I wanted to say is basically that there is a large number of methodologies for implementing grid forming. So we have what we call group control. We have something that we call synchronous machine-based control with the virtual impedance, swing equations and so on. And there is a lot of other control types. What I would like to convey today is that it's important that anyone that is going to buy a Statcom with grid forming should specify the need for the power system, not the methodology for how it should be implemented. It needs to be up to the vendors to do that, to make sure that it is done in an optimized way. So functionality for power system required should be in the specification. And then the one that is basically providing solutions should come up with a methodology. What is important when you have a grid forming device is basically, it is acting like a voltage source behind an impedance. So in case you have a fault, you need to make sure that you have converter current limitation, else there is a risk that you will damage the converter and the semiconductors. And this can be done also in different ways. So basically you can have a switch over scheme between grid following and grid forming, because if you have a grid following device, you will have a current device again, so you can control the current. At the same time, it can be unstable if you switch in between grid following and grid forming, if the system is weak. You can add an inner current control loop and start to saturate the current. This is one very common use method. Or you can introduce what they call the virtual impedance concept, and that we will have a more detailed review on today. So I mentioned droop control here. We will not spend very much time here, but the droop control is basically organizing from power sharing between parallel units, and similar. It will be similar as use of slope for SVC and Statcoms. If you have a virtual synchronous generator, then basically you implement the swing equation into the control system. So the machine equations are basically implemented in the control logic, and then basically it will balance the kinetic energy of the rotating machine. So this is two ways of doing it, but there are also other ways, like the virtual impedance scheme. And the virtual impedance scheme is quite simple. So basically what you do here, you have a voltage source behind an impedance, and then you have the grid. And then basically you see the virtual impedance, one example there. It's just 1 divided by SL plus R. So it's an RLC circuit, exactly what you have in a machine. And then by selecting the inductance and the resistance, you can basically put up the characteristic for the machine. By doing this, you can make sure that the converter maintains the voltage source behavior before, during, and after the fault. And this is exactly what we would like to do in order to limit the current as well. When it comes to how it will perform, so this is just one example where we are looking at the small step in the voltage. And then what you see on the right side here on the screen is basically the grid voltage at the primary side, and you see the active power and the reactive power from the converter. And then we are comparing a voltage source with grid forming and grid following. And what is important to point out here is that you should look, if we look at the active power, of course we don't have active power in a reactive power device, but we have actually some power in the DC capacitors. And this is exactly what we are seeing here in the active power part. So if you look at the blue curve, that is the ideal voltage source, and the red one is the grid forming. Then you can see it has same behavior initially until the DC capacitor is discharged. Then it starts to go in the other direction. If you look at the yellow curve, it doesn't do anything. And this is basically grid following. Same if you do a step in the angle, a little bit more difficult to see maybe, but there is a 20-degree step in the angle. And again, you see the same type of behavior when it comes to grid forming and grid following. What is also good with grid forming is that it will emulate the behavior of a machine, but it will also provide both positive and negative sequence. So that also means that you will balance the faults, balance the voltages during a fault. And if you have a grid following device, then basically you will only provide positive sequence, and you will also have lagging response to fault recovery. And this is also seen in the graph over here. Of course, you can also provide fault current injection with this type of device, but then you need to have a supplementary controller, and you need to work with priorities again. The last example here is basically harmonic sync. So with this type of device also, it will act like a machine, So that also basically means that it will not amplify harmonics because the virtual impedance is always inductive. If you have a grid following device, you also have operating conditions where the converter itself and the control system will be capacitive. So in this case, if you have an inductive grid, you can get amplification, and this is basically what you see in this example here. So basically, we are injecting 0.1 per unit third harmonic, and by having the LR circuit as a virtual impedance, you will basically bring down the response, while the grid following device will amplify. So this is also a good feature for the grid forming device. It will basically provide harmonic sync. We go back to Statcom for Germany again, and this is basically the first Statcom that went into service, and I just wanted to show the response for this Statcom here. And again, we did the voltage response and the phase shift. It's on the left side, on the right side, and you can see here that the grid forming device is acting much faster, and that the grid following device, that is the red curve, is basically having a much slower voltage response. And this is due to that it was not stable. You need to have much higher gain, and then it starts to be oscillatory. Then what is also important when it comes to German grid is that it needs to be designed so you can have a large jump in short circuit strength. So in this case, you went from 4000 MVA down to 300. And then you need to make sure that the system is stable. This is in the grid code in Germany. And you can see that we have the grid forming device. It's the curves on the left side. We have the primary voltage, secondary voltage, and the current on the secondary side. So you can see that the response is stable after the change. While grid following, it is oscillatory and then it trips. What is also important here is to see the last bullet here. So basically, with the grid forming device, you can operate at very low short circuit ratios. So we can go down to 0.25 for this project. 0.25. Grid following will do 2, so it's 10 times lower. Then finally, one test also from system faults. It's very difficult to do the tests for grid forming devices and also for grid following devices. Right now, there is no standards available for how to do the tests. So basically, how to do a step change in the voltage or step change in the angle. But one way of doing it is to switch a large capacitor bank, and this was done here. And then you can see that you get the instantaneous response again in the current. While for the grid following, in this station, there is also a deadband implemented to make sure that the system is stable. And basically, by injecting or switching a capacitor bank, you will not get out from the deadband, so the Statcom will not do anything. And just 2 slides on the enhanced Statcom. We will not go into the details here, but basically, if you are adding an active power device, a storage in the neutral, and we are doing that with what we call supercapacitors. It's a capacitor with high capacitance and low resistance. Then basically you will close the wheel, so you can provide all services that is required to have a stable grid. Then you put the inertia, frequency control, and system restarts in addition to the other services provided for the Statcom. And this basically means, if you remember this one now, that if you do the voltage step, if you don't have the storage, instantaneously it moves in the same direction as the ideal voltage source, but then it will go down. But if you add the storage, then it will follow instantaneously and it will follow continuously. So then basically now we have shown that the Statcom with energy storage It's basically following the voltage source behavior, and now you're emulating the machine. And that basically means that this type of solution, since this type of solution is independent on the frequency change in the grid, a machine is rotating. So if you have a small change in the grid, you will get small amount of inertia. If it's a little bit larger change in frequency, you get a little bit more, but still you are only using maybe 4, 5, 6, 7% of the machine rating to provide inertia. Time constant, inertia time constant, 1 to 2 seconds for a machine. If you put this flywheel on, 6, 7 seconds. If you take this enhanced Statcom, 30, 40, 50, 60 or more when it comes to seconds. So, and you can use everything you have in the storage whenever you would like to do. So this type of device is replacing 10, 15, 20 machines. A few words about grid codes with respect to grid forming. Europe, here we have started to change the grid forming. We have started to change the grid codes when it comes to grid forming. Germany has implemented requirements for grid forming. We have it in UK. And basically we also see large changes when it comes to short circuit conditions which requiring grid forming capability. Most countries in other parts of the world has not started to change the grid codes, but it is a must to do. And I'm sure it will be done here in India quite soon as well, considering the large amount of renewable that is coming into the grid. There is unfortunately no standard available for this, no definition either for grid forming, but there is a large number of existing guidelines and standards that is discussing grid forming. So I think this is good. So we have ENSO-E, we have AMO reports, we have UNIFI reports, and a lot of AMO reports also in Australia discussing grid forming behavior. So this is great. All these documents are also available on the web, so there's a lot of interesting reading. What can also be noted is that when it comes to IEEE standards, 1547 issued 2018 and 2800 issued in 2022, they are good discussing the grid forming capabilities, but there are no information about how much grid forming inverters can operate with synchronous machines. So you need to find a level there also. Is it possible to go down to 0% machines, or should it be something else? There is also some examples when it comes to documents. We will not read everything here, but what I would like to point out is if you look at the German grid code, it basically says that the objective of providing this instantaneous reserve is the immediate counteracting to changes. So it should be fast. If you go to UK, it says enables the converter to instantaneously react to any change on the grid. It needs to be fast again. IEEE P2800, it says basically the objective of the grid forming IBR should not be simply to reproduce the behavior of synchronous machines. Instead, the focus should be on understanding the needs of the involving power grid and how utilizing IBRs in the most cost-effective way. And then, of course, we have India. It's not implemented here, but considering all the renewables that is coming in here and also the short circuit ratio that we have in the grid here, it is not fulfilling the requirements that we have in the grid code. And just one example is this Grid India report from late 2023, where we are actually discussing short circuit level in renewable complex. And here it is clear that the requirement is 5. So short circuit ratio at the interconnection point where generating resource is proposed to be connected shall not be less than 5. It's clear in the grid code. It also says that many major polling stations are having lack of short circuit capability, And at the same time, we are also adding a lot of Statcoms into the grid. So basically, just taking this example here, of these 8 stations, 4 of them has lack of short circuit ratio. In several of those locations, there are also large Statcoms. So why not have grid forming functionality for the Statcoms? Then you will get the reactive power that is required, and at the same time you will improve the short circuit ratio, because you will have the 70 MVA machine, as I said, in a 300 megawatt Statcom, or if it is larger Statcoms, machine size will be larger. And then basically you don't need to invest in the machine at the same time. So for me, it's a no-brainer to do this. Few words about simulation models. So we all know that there is 2 types of simulation models. You can do software in the loop, which is basically meaning that you're using actual control code already when you do your simulations at the early stage in the project. Then basically you're emulating the hardware. Or you can do hardware in the loop, you do it late in the project, and you're using your actual control system with cubicles, and you connect it to a simulator. There is always 2 sides of the coin. I strongly believe that you need to do both approaches in any type of project. And what is good with the software in a loop approach today is that now it has been shown that when you're using the actual control code, you can use DLL files directly into the simulation tool. So you can take your software in the real control system and just plug it into your simulation software. Then you can find out any type of problem at an early stage in any type of project, and you can correct it. You don't want to do that very late in the project when you are doing factory acceptance testing. If you have a problem, you will be late on site. At the same time, if you have also software in the loop, you can use software in the loop to reproduce scenarios or faults or TFR records that you have from site. So basically, if something happens on site, you can take this control code, bring it into the software in the loop, reproduce the incident on site, comparing the results with the transient fault recorder. If they are similar or identical, then you can basically do fault tracing using your simulation tools, rerun the case, make sure that this looks good again, and then just download the code. We have done that many times, straightforward. You can be full confident that it will work when you're re-energizing the plant again. And this is my last slide. So I would like to emphasize again that it is important that, of course, we need to do comparison of technologies, but again, it's important that we specify functional requirements from the power system when you are going to buy this type of devices. And then by doing that, then you need to start to do the comparison. Which type of technology is the most optimized one? And this is just one way of doing the comparison, but if you're using this type of spider diagrams here, we are looking at a Statcom with grid forming, a Statcom with an energy storage, and a synchronous condenser with the flywheel. So if you start with the fault current here, then of course the machine is coming with its overload capability, so it will be much higher capability compared to a converter which has limitation in the converter, and this is basically why you have a high value for the fault current and a lower for the converter-based solutions. Then if you look at the reactive power, you know that the Statcom comes with plus minus. If you buy a machine, then typically a machine is having its full capacity on the capacitive side and 50% or less on the inductive side, and this is basically why it is not as good as the converter-based solutions in the value proposition for reactive power. Inertia, you can believe that the synchronous condenser that has a rotating mass should be the best one, but it is not like that. Again, you can only use 5 to 10% of the machine rating when providing inertia. When you use a converter-based solution with an energy storage, then you can use full rating whenever you would like to do that. And then finally, system strength is also important. Here we can do much more with converter-based solutions compared to the machine solutions. So again, functional requirements is important. If you have functional requirements, then you can let the manufacturers do the optimization, and you will avoid over-specifying this type of devices. And since you can do much more today with today's technology compared to what you could do in the past, this is also a must. Thank you.
Thank you, Mr. Hallonen, for the enlightening and highly informative session. Your insights on the topic provide a crucial perspective on the evolving grid landscape. We now open the floor for Q&A session. If you have a question, please raise your hand and our volunteers will bring the microphone to you. Do we have questions? Yes, we do have right there. Can we just pass the microphone there, please?
Hi, Mikael. Good afternoon. Thanks for enlightening your thoughts on grid forming technologies. In one of your slides, you were saying that the protective devices, protection IDs, will become it will become adaptive. So can you throw some more light on that?
Well, difficult to hear the question, so can you take it one more time? So.
I mean, in one of your slides, you were saying that due to this protection devices, protection IDs will become adaptive in nature in the grid.
I will come down so here. Sorry. Apologize. Sorry for taking it third time.
Sorry. In one of your slides, you were sharing that the protective IDs requirement in the grid at the moment, the way we protect our grid will become adaptive in nature. So if you could throw some more light on that.
I don't remember which slide it was, but when it comes to adaptation, we can have adaptive virtual impedance, for instance. So that basically means that that your grid, if the grid is changing, then you can also change your virtual impedance in the Statcom itself if you have grid forming functionality. So for some operating conditions, you need to have high damping. Let's take that you have a wind farm and maybe you have subsynchronous oscillations from that one. You will provide damping for this. Then suddenly the grid is changing and you have very high TOV requirements. And then the set of parameters that you had for the subsynchronous frequency range is not the optimized one for TOV, so then you need to change those. So then you change the impedance characteristics again, and then you can bring down the TOV. So this is just one example. So
thank you. Thank you.
All right, so we have one question right here. Gentlemen, please.
Hi, Mikael. Luke Robinson from the Australian Energy Market Operator. Thanks for the excellent presentation and nice to see a couple of references. From our perspective, we are developing a grid forming standard and also working with IEEE and IEC to develop a global standard and a joint standard between IEEE and IEC that will define grid forming capabilities. And I think you pointed out quite rightly there's a strong need to define the standard sets of capabilities. The question I had for you relates to the polygon on the last slide regarding the fault level and system strength contribution. We define system strength as resilience to changes in the AC voltage waveform, and typically fault level or machine combinations are used as a way of quantifying system strength in the system. Just really interested to understand how you've defined system strength contribution as opposed to fault level contribution on that polygon, and just really the rationale for the Statcoms being able to provide more than a synchronous condenser. Thank you.
Let me see now. If I remember it correct, there's also a lot of calculations behind that. But when it comes to the system strength, it's basically to maintain the waveform within a certain voltage band. And I think it's like plus minus 0.2%, 0.2 or something per unit that we are using. But it is not, again, there is no definition and no standards defined for that. So I think this is also needed in the industry. And I know AIMO also have discussions about this. I know that you have also the grid forming voluntary specification. Yeah. And in addition to that, there is also a survey ongoing right now. And the documents that has been presented is having quite high focus on solutions which has the energy storage. We also believe that you need to think about adding definition for the Statcom itself that you don't have the storage for. So this is important. And then when it comes to fault current, then it is related to the current that you can get out from the machine by using reactive power, of course, if you have a Statcom device. And in this case, as I said, the machine itself will be much more efficient to provide the current. But still, you can use what you have in the converters. I don't know what is the definition in your document. So.
Yeah, I mean, we have a document, system strength explained. In fact, I developed which defines the resilience of the AC voltage waveform as system strength. But there's no perfect definition, and it's certainly something we're working on defining more granular, in a more granular way, so that we can actually utilize different technologies to provide system strength. As you said rightly, it's not well defined. So I think, yeah, interesting to clarify what's meant by system strength on there. Thank you for that.
Welcome.
All right, so we do have one more question from the gentleman.
Yes,
can you please pass the microphone?
Question in context of the climate action and application of the grid technologies. The question is that how relevant to the Indian condition, one grid, one sun and one district, access to energy for a public domain?
It's a difficult one. I don't know if I have an answer on that one. So, what do you have any comments yourself, or?
My comment is how to get it relevant to an Indian condition. We are Indians. We are not living in Australia or Finland or Germany. How to Indian climate action system development 13. Yeah. How to make it relevant to Indian conditions, so the access to energy, access to environment, access to ecology, and access to ecological systems.
I think one good thing is if you go with a converter-based solution instead of a machine, the losses will be much lower. So this is also environmental friendly, of course. It's good for the environment. And just taking a machine full load will have 1 to 2% losses. Converter will be in the same range approximately, but if you go towards 0 megawatt, where these type of devices should operate majority of the time, because they are insurances for the power system, and when do you use an insurance? When you need it, of course. So it should be operating close to 0 megawatt, and then the losses are much lower for the converter-based solutions. It's 1/10 of the machines. So that will also not only be environmental friendly, it will also give lower operational cost and lower maintenance requirements. So this is one way of seeing it, of course. And then having the grid forming solutions will also provide support to the grid, so you can increase the amount of renewables that you have. And that is also what we would like to do.
All right.
It can be a policy matter. It can be a policy matter.
Yes.
How to make a grassroots level access to energy systems.
Correct. We can discuss more after the session. So thank you.
All right. I understand the urge to ask the questions, but due to the possibility of time, we won't be, we are really sorry, we won't be able to take questions any further, but thank you so much, sir. Thank you so much. Well, ladies and gentlemen, to honor our esteemed speaker, thank you so much, everyone. I really appreciate for the cooperation. To honor our esteemed speaker, may I now invite Shri A.K. Behra, Executive Director, PESL Asset Management, TBCB, to present a memento.
Check.
Well, once again, can we have huge round of applause? Thank you so much, everyone. Once again, thank you, Mr. Halunan, for sharing your expertise, and Shri Bhairaji for joining us in this honor. Ladies and gentlemen, as we move ahead in our discussions on the future of power systems, our next session explores one of the most significant shifts in the industry, digital transformation of utilities. The power sector is undergoing a rapid transformation with emerging digital technologies, automation, and AI-driven solutions, revolutionizing the way utilities operate, from smart grids to real-time monitoring, predictive maintenance, and cyber security. Digitalizing is enabling more efficient and sustainable power infrastructure. To guide us through this exciting domain, we are honored to have with us Dr. Tom Turbush from Electric Power Research Institute, EPRI, USA. Please join me in welcoming Dr. Tom Turbush to the stage. Before we begin, let me introduce our esteemed speaker. Dr. Tom Turbush is EPRI's Vice President of Sales and Member and Technical Services and EPRI International President. He is accountable for EPRI's overall funding and collaborative engagement with members and partner organizations in the United States and over 45 other countries in support of EPRI's mission to drive innovation to ensure the public has safe, reliable, affordable, and clean energy around the globe. Since joining EPRI in 1997, Dr. Turbush has held a wide range of positions in Europe, Asia, and North America, involving economics, nuclear, power delivery, sales marketing, and technology transfer. Prior to joining EPRI, he worked with US and Japanese organizations on energy, economics, technology, and deregulation. Ladies and gentlemen, let's give a warm round of applause as we welcome Dr. Tom Turbush to share his insights. Over to you, sir.
Great, thank you very much. That's a very kind introduction. Thank you. I think, I think I'm the last speaker before the very, very important people come in to close up the thing. I think it really, I need to thank our host, PowerGrid, for putting on an amazing conference. And I think EPRI knows something about what it takes to put on a conference this size. It's a lot of work to make it look smooth and effortless and, quite frankly, glorious. So I think the first thing, rather than me, we should give applause to the PowerGrid staff who put this on. Thank you very much. I also want to thank Seagray, who helped support this event. Everybody knows who PowerGrid is, but if you don't know Seagray, you need to get involved with Seagray. In a world that's awash with information and data, Seagray creates knowledge, shares knowledge, provides access to knowledge. So if you're an engineer, young, old, in between, and you're not working with Seagray, you go to that seagray.org website, hit the red button to join, get involved. It will change your career, and it will change your ability to impact energy in India. Very important. So, all right, we already talked about me. I am an economist, so my PhD is in economics. So I'm happy. I've been working on restructuring and digitalization and AI most recently. I can answer a lot of questions about that, but later on, because Q&A, if you really want to get technical about HVDC or transformers or waveforms, I'm probably going to have to find an SME to answer some of those questions. So I think most of you guys in the audience can probably answer those questions. I'm going to focus on the digital transformation and the latest wave of AI, which is nothing short of a revolution. So we're going to talk about that. And actually, let me see if I have the clicker. Here we go. All right, before I launch into the topic, real quick about EPRI. So for anybody who doesn't know EPRI's been around for over 50 years. We're really a not-for-profit, objective, science-based organization that has a lot of experts both on staff and on call around the world that we work with. We're really focused on working collaboratively with all of our members and our stakeholders around the world to identify the challenges that we need to most critically overcome in all sorts of areas in electricity. And then we crowdsource who's the best person to solve that problem, what are the technologies that need to be identified, developed, accelerated, demonstrated, get deploy ready so that everyone can use these technologies to help make electricity cleaner, more reliable, safer, more affordable, more equitable, more accessible. So that's what EPRI does, or at least that's who we are and how we work. We work with 500 energy companies, more than 500 energy companies around the world, in over 45 countries, including India. And again, there's a lot going on. We have 500 plus members, but we have thousands of other stakeholders, universities, labs, OEMs, others that we work with. What we cover is the gamut. So obviously, we're talking about transmission today. EPRI has SMEs, R&D, members that are focused on nuclear, the creation of electrons, whether it's by nuclear or fossil, renewables, other things, the transmission of electrons, the distribution of electrons, the end use and consumption of electrons, and everything in between. And nowadays, there's a lot in between, right? Storage, low carbon resources, flexibility, dealing with the market transformation. We're talking about policy choices on how to make electricity accessible and everything in between. So that's what EPRI does. I'm going to plunge into digital transformation real quick. So I think there's been some talk earlier today, and I think most people are familiar with digitalization. There's a lot of benefits to transformation. I'm not going to go too deep. I'm going to talk at a high level what it is, what the benefits are, things to think about, and maybe how to approach it. So obviously, through digitalization, you can leverage data to get much better performance if you do it right. You can increase reliability and resiliency. You can increase operational efficiency. You increase security. But how do you do that? You can't just adapt technology. You have to think about where you're at and think about your journey. Everybody is on this journey. But the question is where? Some people are starting out. Some people think they're finished with the journey, but the journey never really finishes. Technology keeps changing. Data keeps changing. I mean, it not doesn't change. It increases almost exponentially. So, some things to think about as you're thinking about digital transformation is you really need to focus on specific outcomes. You want to be ambitious, but you want to be focused. And you want to think about what you're trying to achieve. You need alignment across your organization. You can't just have the IT department doing digital transformation. That's not going to work. You need OT very involved. You need alignment. You need metrics. You need to be able to measure the progress, justify that investment so that you can keep moving forward and you really learn lessons from where you're going. And, there's a lot of shiny objects, but you got to crawl before you can walk, and you got to walk before you can run. You need to see where you are on the spectrum, and you need to make sure you've got your crawling down before you start walking and running. And that's really important when you're talking about a digital journey. Generally, again, EPRI works with hundreds of companies around the world. The approach we take wherever you're at, you need to assess where you are. And you really need to be honest about what is your digital maturity, what are your gaps, your weaknesses. Focus first on kind of expanding those functional capabilities. We'll talk about that in a sec. Leverage new technology, but again, crawl before you chase the shiny things, and then work on the project implementation, system integration. But again, be very focused on your objectives. Foundational investment, really we're talking about things like data governance, the IT/OT architecture, security. You have to have those things. It's not easy. It's easy to snap your fingers and say, we got to do that. There's a lot of work involved. So if you're starting out your journey, you're going to spend a lot of time there to get that right, and then think through where you want to go from there. Data volumes, like I said, they're increasing. So whatever you think you need now, you're going to need more in terms of communication and storage and all that, and ability to process that information. And then, of course, there's generative AI, which we'll talk about in a minute. It's got a lot of potential. It's going to be disruptive. But again, like a lot of things, you can't just snap your fingers and bolt generative AI on top of what you're doing today and think you're going to accomplish something meaningful. So, all right, a couple other things. Goals and objectives, make sure they're clear. You really do need a roadmap. Again, starting where you're at, what's your journey going to look like, what are the important steps along the way, and you need to calibrate that pace of change based on your risk tolerance. How fast you need to move. Feels like today everybody has to move really, really fast. But if you move too fast, too soon on certain things, you're going to cause yourself a lot of problems. And you probably regrets, and you're going to waste a lot of money. Nobody wants to do that. So consider what's practical and make decisions based on that. All right, so that's really fast, because again, I know it's late in the day. I'm happy to do Q&A and answer questions, but I just want to give you a little overview. The really hot thing is AI, and AI's been around a long time. There's a lot of hype. In certain not so dark corners of the internet, people are worried about AI taking over, extinguishing humanity. I mean, that's like really dark hype. There's a lot of hype by the supporters, though, on what AI can do, how fast it's going to happen, how fast we have to embrace it. I think it helps go back in time a little bit. So I've got a few quotes here. The first quote, everything that can be invented has been invented. It's a quote from 1906 from the US Patent Office, thinking we were done with patents over 100 years ago. As we know, there's a lot that's been invented since then. We're going to continue to see inventions afterwards. I think there's a world market for maybe 5 computers. This was from IBM. The CEO of IBM, 60 plus years ago, didn't see a market for computers, right? And there was hype eventually, and we got through that. Internet, we're not interested in it. This was 30 years ago from Bill Gates, of all people, who was already running Microsoft as a very successful concern. Maybe he was, tricking us a little bit, but he seemed to believe in the early days when browsers were just starting right before browsers that they wouldn't be a market. So again, there was a lot of hype, and there's a lot of people that didn't believe the hype, and we kind of know what happened. And then with smartphones. So 2007, Steve Ballmer, who was the CEO of Microsoft, basically didn't really think iPhone or smartphones would have much potential. As we know, they changed the world. And I think it's useful when we think about digital transformation, AI, we go back to the past. So when I was growing up, when I went to university, there were no browsers. If you wanted to get data, information, let alone create some knowledge, maybe wisdom someday, you had to study, you had to read textbooks, you had to read books, you had to read journal articles, you had to spend a lot of time in the library, and you had to get really, really good at the card catalog, which anybody under the age of 40 probably doesn't even know what that is. So that's how you access knowledge. Obviously, sometime between 1993 and 1994, when the first browsers came on for the World Wide Web, 2007, when the smartphones started coming out, the world's changed a lot. Now we have data and information more than we could ever process. We're awash in it. My generation, for maybe a lot of folks in the room, it took a while to really embrace that and figure out how to sort through all this information to continue to do knowledge. I think the younger generations coming up are going to get better at that. AI could turn that all upside down, right? AI can move at a speed. It's already sucking up all this information. The question is, how do we leverage this to do impactful things, to create more knowledge, to effectively use knowledge, and do it in a wise way? So that's, again, that's sort of AI. We've got a lot of titans of industry and significant people that they've totally drunk the Kool-Aid on this. They really feel AI is going to disrupt everything. They're probably right. They're very focused on the positives. If you think back about the internet, smartphones, a lot of positives. They've changed our lives. You've got the world in your pocket, at least some part of the world, but there's the negatives. And so people that were looking at the negatives at that time, they couldn't even imagine the positives, and the negatives ended up being not what we expected, right? For the internet, especially smartphones, I've got kids, they spend way too much time. Screen time, phones, we all probably do it. There's doom scrolling, there's all sorts of other things. There's people that are addicted to social media, and that's where they live. And so there's a lot of negative things that have come out of an incredibly positive advance when you talk about internet and phones. AI won't be any different. We probably have a better job imagining the boundaries of the positives and the potential. We still don't know exactly what the final impact will be. We probably have less understanding or less insight on what the negatives could be, and that's the stuff we have to prepare for. So anyways, all right, so that's these guys. Value. Well, some of it's pretty self-evident, and I'm sure most people in the room are already looking at this. Some people are playing around with it. Some people are adopting. It automates things, right? Clearly. Even earlier generations of AI, machine learning, other things, you can use that to automate processes, right? Image recognition, all sorts of things, it saves time. Performs dirty, dull, and dangerous tasks for humans. Clearly, if you have an AI that's in certain remote situations, other things, can be very helpful. Can process an insane amount of data. That's one of the great things about generative AI. You can just dump a lot of things on it. Can't always trust what comes out right away, but a person who's a subject matter expert can sit there and evaluate what comes out. Proves reliability, repeatability, capable of generating text, images, other data. So I think most people know about those things. Performance is growing very fast. So generative AI is changing very quickly. And just between the ChatGPT, the first one that dropped in November 2022, to the second generation, the next generation, 2023, less than a year later, huge performance gain. And we've seen subsequent performance gains from that. And 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 really what's happening here, like I said, AI has been around a long time, long time, depending on how you define AI. Certainly in the last 25 years, we've had data scientists, we've been doing machine learning, we can do image we've taught computers how to recognize cats and dogs long before this latest generation of AI. The real thing that's changed in the last, well, now it's 8 years, the approaches keep changing. Google, there's a bunch of Google employees, engineers, that came out with a paper called Attention is All You Need back in 2017. And the basic idea and the aha was we needed to train these AI to think a little more like humans, and it's contextually. It's not enough to teach the AI how to say what dog means in 5,000 languages. You have to teach that AI the context of the word dog in 5,000 languages. And this is where the data needs and the energy needs for these data centers really takes off, because it's one thing to teach, what they're doing is they're scraping the internet, they're taking a look for every word in every language, they're teaching it the context. They're looking at every instance of the word dog, every word before and after the word dog in the entire internet, so they can understand and contextualize dog and knows how to use it, and it looks like it's thinking, but it knows how people use that word. As the models get bigger and bigger and bigger, it's giving deeper context. It's trying to scrape more data, but it's really going 50 words before, 50 words after. So this thing becomes smarter than pretty much anybody. It has access to all this stuff, and it's not thinking, but it appears like it's thinking. The problem for our industry right now, we all have challenges. We've been talking about the energy transformation, the transition that we're going through right now. We have a lot of challenges. We're trying to move very fast. We have an existential challenge when it comes to climate change and the need to decarbonize. Everyone in the world is trying to do the same thing at the same time. Somebody was on the stage earlier today talking about how ordering transformers went from a 2-year wait to a 4-year wait because everyone is ordering transformers. Everyone is ordering cable. Everyone is ordering panels. And when you're doing all at the same time, and then in parts of North America, parts of Europe, parts of Asia, all of a sudden this data center stuff is coming online. I mean, we have countries and regions in the world where 25% of the load is data centers. Ireland, Virginia, and the US. At the rate they're going, Ireland could be 33% by the end of next year. A state like Virginia could be 40% within 5 years. It's kind of insane. And we're trying to do that. We're trying to make it clean while we're trying to actually replace all the generation we've got and meet the load. Somebody earlier talked about 20% of the world's population doesn't even have electricity. And we're trying to get them clean electricity while we're building all these data centers. So challenge is, how do we find a solution in that? And really, if we're going to invest all this resource in AI, we better figure out how to make it work and help us with the energy transition. So, all right. Like I mentioned before, I've been working in AI for a long time, at least in the machine learning space, the deep learning space. There's a lot of use cases. I'm sure here in India, a lot of places around the world, we've already been doing, whether it's digital twins and leveraging earlier versions of AI to actually make decisions out of that, make fast learning out of that. Dispatch optimization, diagnostics, that's huge, right? And the maintenance of our assets. I mean, earlier generations AI have done us wonders. The new generation of AI we think could actually take us much farther. But the new generation could also do much more complex things for us, like operating a system, operating a plant. Again, we got to be careful. There's challenges. So I'm just going to go through a couple use cases. You have to get an idea. I know we have use cases here in India. Every utility in the world is either working on use cases with generative AI or they're thinking about them. Cyber is a complex one that we're seeing many companies around the world are starting to look at how they use generative AI to support their cyber. Because again, very fast moving. You have intrusions, you have monitoring, you have data, you have to know what it means, and people need to be notified. Decisions have to be made sometimes faster than a human can click a button. So how do you leverage AI for cyber? That's one good use case. We've been using, we've been using AI for image recognition, for checking condition of lines, checking vegetation. What we're seeing is some companies are using satellite data and generative AI to find out in real time where they need to make a plan for their vegetation management for the next few weeks. Or sometimes something's a little more urgent than that. We've been doing drones. Obviously, that's image recognition, But now we're seeing drones by some companies in the last couple of years, they're going without pilots in some cases, right? And this is especially important when you have storm restoration and damage, right? So you have a storm come in, a hurricane, a typhoon, whatever, takes out a lot of your grid, a lot of lines, and you're trying to bring things back up. Maybe you don't have enough sensors, you don't really know what the problem is, the state and the condition. There are some companies now that push a button or they put their people in the field, they send a bunch of drones out, and they're in pre-program, right? Our lines aren't changing. So these drones just go down the lines very fast, assess what's going on, report back. In a storm restoration situation, you have that data right in front of you, so you can make decisions on where you go first and who you need to send where and when. So that's another example. All right, and then health monitoring, we're already doing a lot of that in the machine learning space. I think generative AI we're already harnessing it a bit to kick that up a notch. Learning on a power network, this is one of the more complex things. So again, EPRI works with several hundred utilities around the world. RTE, who's a TSO in France, very cutting edge, they do a lot of cool stuff. We've been working with a lot of our partners there to sort of test an AI agent on how to manage the system. Risky, right? You're not just going to turn over your system operations to AI on a bet or a dare, but you want to start kind of working that direction to see, because sometimes you need to make very fast decisions, whether it's reviewing sensor information, making decisions, and at least it's providing quicker and quicker decisions to the operators themselves. That's the hope. There's some promising things, but it's early days. Power transformers. All right, so I've got something transmission oriented here. So EPRI, and I know I was talking to some power grid folks, you guys have a power transformer database you use for continuous maintenance and condition assessment and preventive maintenance. EPRI's been working with a lot of its members for many years. We have data from around the world on transformer failures and condition modes and all these things, and we're starting to marry that up with AI, which is some pretty interesting results. So those use cases, I'm talking fast because I want to make sure the VVIPs can get in here and I don't slow them down. Those are use cases for using just kind of things, either earlier generations of AI, or starting to think about how the new AI could apply. One thing that's obvious to us is, and we're seeing some crazy use cases or crazy places where AI has saved us person months of time. But usually what it takes is an SME, a very skilled, knowledgeable person, like several people in this room and their domain expertise, with a chatbot and maybe with their software for managing the system, designing the system, whatever it is. And they have to get really good at doing inference requests, pulling stuff out of the software, putting things in the software, doing modeling checks and all this. It's still a lot of work. It saves that user a lot of time, saves that SME a lot of time to do really cool things. But there's only so many world-class HVDC experts in the world that could do this stuff. And some of you in the audience, so congratulations on that. But what we're looking at for really how do we go beyond that to really integrate all these things together? ChatGPT, the latest version, it queries itself, right? So here's an LLM that you put an inference request like, I don't know, whatever it is. Usually it just kicks back an answer. Now the latest versions of ChatGPT, it gives you an answer, but before it gives you the answer, it queries the answer itself again and again and again. You can do the same thing with multiple LLMs, because different LLMs have different capabilities. If you benchmark them for certain types of questions, they're good at this, but not at that. Put different LLMs together, you integrate them with some of the software that you might use with whatever you're working on. And ideally, where we end up, we're not here yet. We're just starting this journey. We want to integrate those things together so that it's part of the software you already use, but it's a completely better, different software. Whatever tool that is. If you're a grid operator, there's a lot of that. Obviously, if you're designing HVDC, there's that. There's different things. We want to integrate this more effectively with the tools, but to trust it, we really want not just to rely on one LLM or one line of reasoning, have multiple lines of reasoning there. So that's, and for transmission, again, this is an operation space, it's very complex, but you can do much faster, complex analysis. You can get higher quality outcomes. You can debug things quick. You can do workflows. It's exciting, but we got to make it work. And it's not there yet. We are just starting that journey with our members. All right, that's the exciting stuff. I talked about the downsides. This isn't even the downside. This is the challenges just in getting some of this to work in places where you can count on it for reliability and these things. Obviously, regulatory, we have challenges, right? To have faith in our operating regimes and our assets and our maintenance regimes, we need to make sure that we're meeting regulatory requirements so that things are safe and they're reliable and that we're doing good by society. AI regulators are going to be very nervous about this, I would think, and rightfully so. So we have to work very closely with our regulators and with our other stakeholders to pilot this AI in different sorts of things so we can get confidence that it's reliable not 99% of the time, 100% of the time. That's going to take some work. Security, obviously, the more you digitize, the more you expose yourself to cyber and these sorts of resiliency challenges. If you don't understand how AI is getting the answers it gets, how do you know that's not influenced by some sort of cyber intrusion, right? So that's something to think through. How do we protect that? This, again, early days, the more advanced AI gets, the less we understand how it works, the more important this is going to be. And then data, that's tough. Used to be, say 25 years ago, you could ask people for their data and you could often get it. You might sign an NDA or something like that and people would share data. The more valuable data it becomes, the more useful it becomes, the harder it is to share, the more siloed that data is, the tougher it is to leverage that data to help our industry and humanity. So you have to think through data protection and all that. So that's, again, some of the challenges. So lastly, I'm going to talk about what's next. So we're working on these sort of platforms. One thing that EPRI's been doing, I'll just leave that, I've been talking to a lot of the Power Grid folks. This is something we certainly would want to invite Power Grid to join and be part of. We've been doing a lot of work with Microsoft and Amazon and NVIDIA and Meta and Google the last year on making sure there's enough energy, clean energy around the world, or access to energy around the world, or the efficiencies needed to make sure all these data centers can be built to support AI. But we're also working with them on how we can leverage AI to benefit the industry and our customers. And so we're launching an effort actually next week. Our CEO, who we were hoping could come here, but he had a conflict. He's at a couple other things in the US this week. He's going to be at the NVIDIA Developer Conference next week with Jensen Huang to announce this new consortium. And this is really all utilities in the world. So again, EPRI has over 500 members. We're all going to have them join. We're going to have other stakeholders, right? Labs, academia. We have a lot of university partners and a lot of these technology partners. And it's really about a few things. It's about thinking through kind of that platform approach I was thinking about, but the data, right? How do we work together to really, EPRI has a lot of data. A lot of people have a lot of data. How do we work together to provide secure access to that data so we can build a common, accessible platform for the whole world, for a whole industry around the world to leverage for AI and create basically what we call an AI sandbox, where anyone with an LLM or an SLM or an AI agent and your IT OT staff can come in and test their AI, their applications against the data sets that are here. This is a very ambitious meta version of many things that EPRI and others have done for many, many years. Even under machine learning, we used to do approaches like this. This is ambitious, and because what we want to do is we want to get this deployable. We want you to be able to come in and test the AI, see if it works, benchmark it against others, and then figure out if you can deploy that application. And then we want to learn from that. Did it work? Get the feedback. That's how AI develops. We need real-time feedback. AI gets better the more it gets feedback. And then maximize the knowledge sharing. And again, this will be a very open consortium. EPRI's mission is public, and EPRI doesn't really own this. EPRI is an operator that's going to be involved with many other people doing this, but we're trying to announce this to the world. And then, we're going to be doing this really across everything, every part of the electricity industry. That's a lot. That's a big sandbox. So obviously, I know a lot of our folks, certainly in Europe and the Gulf, are very focused on transmission, both assets and operations. They're going to be active members in that sandbox. I'm sure we'll be working with Power Grid on some of these things. But anyways, that's what we're launching. I'm just going to end there. I would want to say in conclusion, that, we're going through a revolutionary period, right? Went through the digital transformation, digital revolution. Now we're in the cusp of a real AI revolution. There's massive challenges. Climate change, supply chain. We don't have enough people. We got to train our people. We got to figure out how to get more productive and more efficient and do all these crazy things we need to do in the next 5 to 10 to 15 to 20 years. India has incredibly ambitious goals. 500 gigawatts of renewables by 2030. That's awesome. That's awesomely, crazily difficult. So you guys are well on your way to doing it. It's amazing. But I would say none of that's going to happen without the people. And it's really about human minds, people in this room, and industrial capacity. India is in a good position to really be a leader in this space. Great IT background. You have all of experience. You could be a real leader in AI. And I'm sure there's a lot of folks that would agree with my statement and would be willing to help you get there in whatever way. So I would say I just want to thank, I'm looking forward to working with PowerGrid on this, and I'm looking forward to your questions. Thank you.
Thank you, Dr. Tom Torbush, for that thought-provoking and highly informative session. Your insights into the digitalization of utilities provide us with a forward-thinking approach and embracing new technologies. We now open the floor for Q&A session. If you have a question, please raise your hand, and our volunteers will bring the microphone to you. Do we have a question?
We've warned them out.
Yes, I totally understand. Well, that was an amazing session. We all loved it. Thank you so much, sir. And to honor our esteemed speaker, may I now invite Shri Rajesh Kumar, Executive Director, WR2 Power Grid, to present a memento to Dr. Torbush as a token of appreciation.
Thank you. Oh, over here.
Thank you so much, everyone. Once again, thank you, Dr. Torbush, for sharing your expertise, and
right.
Shri
Thank you
Rajesh
very
Kumar
much.
ji for joining us in this honor. And with that, we officially conclude this speaker session of GRIDCON 2025. This is our moment to acknowledge the dedication, expertise, and forward-thinking vision that has shaped the discussions at GRIDCON 2025. We extend our heartfelt gratitude to all our speakers, panelists, moderators, and delegates who have made these discussions a grand success. And of course, our sincere appreciation to you, our esteemed attendees, for your enthusiasm, participation, and invaluable contributions. Well, can we have a huge round of applause for esteemed speakers, panelists, moderators, and delegates? Thank you so much, everyone. As the saying goes, the future depends on what we do in the present. Over these 3 days, we have explored groundbreaking ideas, debated critical challenges, forged partnerships, and sparked innovations that will drive the next era of energy transformation. But before we bid farewell, we have one final and significant segment, the valedictory session and award presentation. This isn't just about closing this remarkable event. It's a time to reflect on key insights, celebrate outstanding contributions, and look ahead to the future of GRIDCON. So let's step into this closing chapter of GRIDCON 2025 with the same enthusiasm and energy that brought us here. Once again, thank you so much, everyone. And for the valedictory section, we'll be starting in a while. So it's a very humble request from all of you to please kindly be back in next 15 minutes. Thank you so much, everyone. a summit that has epitomized the relentless pursuit of innovation and excellence in the power sector.
A very good evening to all of you. Dignitaries on the dais, respected Dr. R.P. Singh, Chairman, Board of Governors, IIT Kharagpur, IIT Bhubaneswar, or as well as our ex-CMD, PowerGrid. Mr. I.S. Jha, Patron, SIGRE India, as well as ex-CMD PowerGrid. Shri R.K. Tyagi ji, present Chairman and Managing Director, PowerGrid. Mr. Marcio, International HVDC expert from Brazil. Dr. Yatin Dwivedi, Director Personnel. Dignitaries on the first bench, Director Finance, Director Projects, EDs, ladies, gentlemen, and my dear friends. At the outset, at this closing ceremony of GRIDCON 2025 today, I am glad to welcome Dr. R.P. Singh, ex-CMD PowerGrid, at present Chairman Board of Governors, IIT Kharagpur and IIT Bhubaneswar. His visionary insights have a crucial formulating policies that bolster our power infrastructure and facilitate the advancement of Indian power sector, who has spared his valuable time for this valedictory session. Sir, I welcome you. I also welcome Shri I.S. Jha ji, Patron SIGRE India, ex-CMD PowerGrid. You all know whose strategic vision and mentorship have been always instrumental in Indian power sector growth, as well as PowerGrid and India power sector growth he is instrumental in bringing the policies for growth of this industry. Sir, I also welcome you. I also heartily welcome Mr. Marcio, who is international expert in HVDC. He's also in our expert group for HVDC, and we are really glad to see him in GRIDCON 2025, sharing his views, sharing his expertise with all of us. Sir, I also welcome you in this valedictory session. I heartily welcome Shri R.K. Tyagi ji, the mentorship, in whose mentorship this GRIDCON 2025 is being organized. Sir, I can say you that your strategic guidance and commitment to excellence to bring a best has played major role in bringing this GRIDCON 2025, and also lot of PowerGrid achievements and making this organization one of the world-class organization, which is third largest transmission utility in the world. Sir, thank you very much, and I welcome you all. I also welcome Dr. Yatin Dwivedi ji, Director Personnel. You all know his commitment for the capacity building and HR excellence is known to all of us. Sir, I also welcome you in this session, valedictory session. I extend my heartfelt welcome to all the distinguished guests, industry leaders, experts, delegates present today, exhibitors, visitors, PowerGrid employees. Your participants and insight have been invaluable to make this GRIDCON 2025 a platform for meaningful discussion and groundbreaking innovation in Indian power sector. GRIDCON 2025 was inaugurated by our Honorable Minister of Power and Housing and Urban Affairs, Shri Manohar Lalji, in presence of Shri Shripad Yaso Nayak Ji, Minister of State for Power and NRE, on 9th March 2025. Over the past 3 days, we experienced an exhilarating exchange of ideas, technological innovations, and meaningful connections between all. GRIDCON 2025 has provided an exceptional platform for thoughtful leaders, experts, industry pioneers to deliver on key strategies to enhance the power transmission efficiency, sustainability, and adaptability. The technical sessions and deliberation have led to a valuable insight that will contribute in shaping the future of energy landscape of whole India. As we stand at the cusp of the dynamic transformation of power sector, one thing remains very clear. Our greatest assets are our people. GRIDCON 25 has brought together these professionals from diversified backgrounds, ranging from young, enthusiastic mind, eager to learn, the seasoned expert with the decades of experience. This convergence of knowledge, expertise, and fresh perspective has driven innovation and progress in the last 3 days. Sir, GRIDCON 2025 has been truly a landmark event, bringing together an impressive almost 2,800 delegates, more than 6,000 visitors, 150 exhibitors showcasing cutting-edge technologies, advancement in power sectors. From all over the globe, 31 countries have represented this GRIDCON 2025. 160 papers selected. I can tell you there was 450 papers were submitted. Then we have seen that 270 was shortlisted. We asked for them to submit the full papers, 260, and after that 230 has been submitted, out of which we have selected 160. It was very, very difficult for the jury to select. They were telling, can we increase it to 160? Can we increase to 200? Because it's very difficult to select 160 out of it. This shows the enthusiasm. This shows the commitment of those who have written the papers. And I can tell you, these papers have a breakup. I can tell around 160 papers, 67 were from Power Grid, 19 from foreign country, and 74 papers from others. Total women participation in this paper submission was 1/3, sir. I want this forum to clap for them. 146 papers were from women. CPSU was representing 20, foreign country was 5, 10 from Indian private companies, 9 from student, and 2 from educational institute employee, 46 numbers. Sir, this was a really difficult task for my team, but I can say that you have visited the poster sessions. They were very, very illustrative. They were very, very informative. They were very, very knowledgeable. Things were coming out. People were in a queue. They want to listen to them. A special highlights was student innovation and startup pavilion, which features 9 promising startups. You must have seen, they were showing drones. They were showing a lot of things that everybody was discussing with him. They were trying to show what they are bringing up. There were 15 student pavilion. They were from IIT Ropar. They were from IIT Madras. They were from Jamia Millia Universities. There were 15 institutions were there, reinforcing the importance of nurturing young talent and encouraging the entrepreneurial spirit in energy sector. This is really required. We have to bring this young people up. The overwhelming participation and engagement in GRIDCON 2025 undershone a collective commitment towards building a more resilient, sustainable, and technologically advanced power transmission system. GRIDCON 2025 featured an extensive and diverse program, including 5 panel discussion at this room. Apart from that, 3 more were discussion, 2 were from women, and 1 is next generation. So total 8 panel discussions, 8 plenary sessions, and 5 technical sessions and 1 TL tutorial was each designed to address critical aspects of power transmission, grid resilience, and evolving energy landscape. This is the highlights. This we can show you. This is you must be seen in last 2 days. These sessions provided a platform for the global experts to share their knowledge, debate emerging challenges, and explore the innovative solutions that will shape the future of Indian power sector. So the depth and the breadth of the discussion reaffirmed the GRIDCON roles in premier forum for thoughtful leadership and industry collaboration. Panel discussion, it was in global trend of energy transmission, power sector in 2047, global energy governance dialogue, green finance and investment, all the topics, which is whether it is related to finance, whether it is related to technical, whether it is related to policymakers, whether it is related to governance, all were discussed in this forum. This session provided a comprehensive roadmap to Power Grid future, outlining goals of 2047. The plenary session of GRIDCON 25 covered key topics, which is related to UHV systems, virtual protections, automation, disaster-resilient infrastructures, batteries, storage, and grid-forming Statcoms. The technical session on SFC3 free technology, STLS, and innovative solution for transmission, a case study of 37 MT tower erection in a day was also given by our ED. WR2 was overwhelmingly accepted by all the crowd which was available. TL tutorial. These sessions showcased groundbreaking technology and best practices. Experts highlighted the importance of adopting environmentally friendly alternatives in strengthening the grid security, optimizing constructions, methodology, and enhancing the system stability. Next come to our paper presentation. Really it was heartbeat of 2025 GRIDCON. Each one of testament of human ingenuity, the abstracts and the papers, I can see, I also visited, everybody must have visited, the way they were trying to explain the things. It was really, really lot of innovative ideas have come from that. The depth and the quality of the discussion that followed each presentation, which underscored the commitment of the global power community to drive the mechanical, meaningful and good progress. The exhibition, it has showcased the latest innovation. 148 exhibitors. When we started thinking of GRIDCON, we never thought that all of the stalls will be covered. Yes, we put our heart to see that all the stalls are booked up. At the last moment, all the stalls are booked up. But when they have come here and then they start putting their own stalls, it was really overwhelming. Now they are telling those who have left out, they were coming to us and they are telling, sir, why we have not put up. That was a place where they can show their innovations and technology. Student pavilion, startup pavilion as a platform for next generation. An eminent jury has meticulously evaluated and selected the outstanding contribution. We are going to give the prizes after this function. First, second, third, 2 consolation for the academics. The best startup, the best stall, this is going to come up. After you will see in this program, the best pavilion startup, second best startup pavilion we are going to give up. Sir, the collective and collaborative spirit witnessed the exhibition was truly commendable. Industry leaders, policymakers, technological providers and researchers engaged in dynamic discussion and forcing partnership that will drive the future advancement in Indian power sector. The interactive sessions, live demonstrations and networking opportunities created an environment where knowledge and expertise converged that address real-world challenge in the power sector. Sir, I want to bring one thing here, that this concept was started around 6 months back when corporate AM team started discussing under the mentorship of Chairman Sir. He wants to make a GRIDCON 2025, which is much, much better than SIGRE Paris. It was given clear mandate that not less than 2,000 persons should attend. It was really a great thing for us. Then immediately, corporate EM team started working on that. Devnath Jha, Ravi Sushant, Anshul, Rana, Ravindranath Gupta, lot number of names. They start working on that. They run here and there to book a good venue. Then this venue was selected and the date was very difficult. They could get out the dates 9 to 11 March. Now, once the platform was set and now the thing was required to build it up. Sir, I can tell you my 300 comrades, which you see in the gray coats, they have made this possible because of their sweat. Lot number of committees, whatever committee you think, they have done a lot meticulous work. You can see they have worked each minute things, and they worked, and you can see that not a single person was unhappy or any problem he faced. It was perfectly gone from inauguration ceremony to today. We are at the valedictory session. I request everybody to clap for these 300 persons who have made this possible. As said by President of SIGRE during inauguration session, there is only one way to save the planet is 100% electrification with zero emission. For achieving the same required lot number of renewable energy, certain kilometers of line by 2050. In conclusion, I would like to emphasize that the resilient and sustainable power transmission is a collective endeavor. We must embrace innovation, foster collaboration, and invest in infrastructure to ensure a cleaner, greener, and more resilient energy future in harmony with global trends. Thanking you once again for participation and contribution to advance the energy sector, which require the collaboration and commitment for all of us. I look forward for seeing you again in next GRIDCON 2027. Thank you very much. Jai Hind, Jai Bharat.
Thank you, sir. Thank you, sir, for encapsulating the essence of GRIDCON 2025. This conference was indeed a confluence of ideas, solutions, and collaborative spirit. Ladies and gentlemen, the power sector's transformation is one of resilience and foresight, something that resonates deeply with Shri I.S. Jha, patron of SIGRE India. His leadership has been instrumental in shaping strategies that drive our grid toward greater reliability, sustainability, and inclusivity. May I now invite him to address this august gathering.
Good evening, everyone. Just now when I heard Naveen Srivastava, then I'm really thinking that I missed the first 2 days. And let us start at the outset. I must extend my sincere appreciation to the Power Grid, R.K. Tyagi and his team of 300 team, etc. for organizing such a mega event. It is really not less than any conference, whether it is SIGRE or anything. That is marvelous. You know? And of course, this has been organized under the patronage of Ministry of Power. That is a good support. And the SIGRE India, that I congratulate to them also. And in such event, I am really thankful to Power Grid giving me the opportunity. Really, I am feeling privileged to be here on the podium to address you in the GRIDCON. Because there are so many conferences out there, but this GRIDCON is the only platform which is dedicated to innovation and resilience in the transmission system, which is the core requirement. And as Mr. Naveen was saying, that was the one good thing I have seen, that there is a bulletin. And I was seeing the second bulletin. I have seen a lot of good things has been discussed in last 2 days. Just I have seen one bulletin. It was a good insight discussion and technology advancement I have seen in the exhibition. These all are aiming to reforming our grid, more sustainable, more reliable, more adaptable. This is the only prayas is there to make the grid. Now coming to that, as we stand at the crossroad of energy transition, I am telling you, in the energy transition, I have been seeing the SIGRE everywhere. The role of transmission is very crucial. Of course, role of transmission has always been great, but in this situation at the crossroad of the energy transition, never been so critical. Never been so critical. Today, renewable energy generation is driving the power generation. Integrating it to our grid efficiently is not a small challenge. It is a great challenge. That's why this type of seminar, this type of things will certainly help the thing. I am saying the two prominent, there are so many challenges in integrating the RE, energy transition, but there are two prominent. Being a transmission man, I am feeling that these are two prominent. One is the transmission development timeline and renewable energy timeline. There is a mismatch. We all know the gestation period of solar, wind is 18 to 24 months, while transmission, especially the long transmission line, is, we are saying now 3 years, 3 to 4 years. Now, if this mismatch, how to change it? Pressurizing the transmission licensee to do it in 26.20, unless it cannot be done. You can do it one line, two lines. It cannot be done by 500 gigawatt generation project. This has to be addressed, like China has addressed it, Germany has addressed it, planning the transmission system beforehand with the anticipation, and then plan the transmission system, and then plan the generation. Suppose if you are planning the transmission system announced today by 27 in Badla area will be 2000 megawatt available. This area, and then generation should come in that way. This is the only way. Otherwise, as you know, our target 500 gigawatt by 2030 means we are today at 200. 300 is to be added. For that, see, gigawatt make it simple, but if you say lakh megawatt, then 2014 I was seeing the paper from the Subir saying 1400 gigawatt. This is the huge, I don't know. That's why it is the time that this can be solved through the planning. Second issue, what I have seen it, like even in India we have started the establishment of green corridor. It was a step in that way. We have developed it, then generation came. This should have continued. That's why generation has to follow the transmission. Transmission has to lead. Second problem is transmission cost, price of transmission. That in cigarettes, so many people were saying the major constraint in the energy transition, the cost of the transmission time. Basically, not basically because we need long transmission system. If you see before the renewable energy, our resources was scattered. Sigroli area, Korba area, Ramagundam area, this. The load center is very nearby. The first line has come Sigroli, Kanpur, this is 400 kilometers. Then Allahabad, open Nopad, etc. And then there is a matching, some other part. All over the India, the principle of law of principle. But here, the renewable, those solar is available everywhere, but solar potential is guided by the line. They are very limited. That's why cost of the transmission to bring in the power without any displacement, etc., is very high. But major concern is that we plan the transmission system, their CUF, capacity utilization factor of the generation, solar, wind is only 20-25%. Means most of the time of the day, our transmission remain underutilized or not utilized. This has to be addressed. Some of the solution, it was suggested in Shigire, or we also have to see that how to increase the utilization. Like Khavda has come, Fatehbad has come. So you plan as a hybrid park. Start with hybrid park. It is not that first comes solar, then we'll try to bring the battery, etc. The planning has to start with the hybrid park, like solar, wind, battery, all the systems. If they are not there, then we need to pool it. Suppose there is a big major pooling station. I am not talking about the Fatehbad pooling station. I am not talking about Badla, where there is solar. If they are only solar, then you have to, the major transmission system, have to some major, that I have seen in the China policy. The major pooling station will come. Here, some solar, some wind, some hydro should be pooled, and then it should be, practice should be done, and then we can do it. Secondly, and overall planning criteria, overall parameter is decided for the base load planning. We are following the base load, the ambient temperature, etc. But now the time has come. Already Japan has started, Germany has started. Dynamic, we are using today a static temperature. Like capacity of the land is limited by thermal, what is the temperature. At that we take the very conservative figure, 85, 45 ambient. You keep every time, whether it is the ambient was 20 degree, we keep the same capacity. Now the time has come, especially for the dedicated, the evacuation line. Here, during a wind, if it is loaded, there is no chance of, if wind is flowing, temperature capacity increases. This is nothing. What they have done, they have put the one sensor in the mid of the line where there is a maximum sag. The computer just changes the transmitter. If you are not adopting all over India, we should adopt at least the renewable energy, we can save the cost. Thirdly is, that's why, what are the other challenges? There are a little bit other challenges. I have not discussed. This is the major two I have seen, which is power grid, C2 are concerned that we have there's a lot of mismatch even last 2 years. But other key challenges are there, like grid stability. Of course, now the time has come that forecasting. Just yesterday, day before yesterday, I was reading that the AI-based forecasting is the more perfect is coming for renewable energy. That they are forecasting in a day 5 times. In night they are changing it. Every time they are changing the forecasting, the ramping storage capacity. Most important, which is for CTU again, is the dynamic support system. The Statcom, synchronous condenser, etc. This is a basic planning. See, today we are saying to every generator to provide the dynamic compressor. Do you know that if a small Statcom will be installed by the generator, what will the cost? This all cost will cut the generation. That's why the main transmission system, only the dynamic compressors will come as a Statcom. These are the things I feel so that we must, there is a paradigm shift is required in the planning concept. The paradigm shift, and I take into there is a C10 group for system study. Why not, we should have one working group in that, a special task, what is the planning going on all over the world? Because, just see, this is the period, see, where I have been studying the CBA for last so many. All the time, we are following the Europe, all the things, the activities they have been brought in, etc. But in the age of energy transition, every country is at the same stage. America is also learning, Europe is also learning, India is also learning. Like, even India has done a lot of progress that can contribute. But still, what I feel that planning group, because we are discussing so many technology, but planning, lot of changing planning, because all the problem of mismatch, etc., should be addressed by the planning. And if SIGRE gives something, it will be easier to implement here, because there are so many ministries involved. That's why I request SIGRE to do something like that. Then other challenge, which is the most important challenge, is supply chain. Supply chain. Sir, people are talking of offshore. If they are going for cable, 4 years cable is not available. HVDC, since beginning there are only 3 pillars. One pillar, all are overbooked. Component is not available. The same is the transformer. Now we are not getting transformers. And there is a need that domestic manufacturing capacity has to increase. I don't know how to increase. Earlier, power grid used to be in the cost plus regime. They used to bring all the inventors, etc., by putting the qualifying requirements, etc. Under the age of TVCV, every licensee, I don't know who will take the responsibility of developing the vendor here. Because these are the basic challenges coming up. That should raise the issue in the ministry. The vendor development is very important. And therefore, what I feel, building a resilient and cost-effective and future-ready transmission. This transmission requires a paradigm shift in planning, technology adoption, and policy framework. The transmission sector must move ahead of the curve rather than reactive it. The generation have to complete it. No. Generator is to follow transmission, and then only we will be able to solve. In the last, again, I congratulate the full power grid team and SIGRE India and others. They have organized such an event, very in the massive scale. Whatever the thing we can thought of, everything is discussed. And before I conclude, I take this opportunity to extend my congratulations in advance to all the award winners who has contributed a lot to innovation, research, and making this seminar success. Thank you very much. Thank you.
Thank you, sir. Your inspiring thoughts remind us that the electricity that illuminates our cities and fuels our industries symbolizes more than power. It signifies hope, growth, and endless possibilities. Well, proceeding further, now I would like to request Shri R.P. Singh ji to kindly felicitate CMD R.K. Tyagi ji for organizing GRIDCON successfully as mark of honor with shawl and planter. Ladies and gentlemen, can we have a huge round of applause? Thank you so much, everyone. GRIDCON 2025 has been an incredible showcase of inventive research, cutting-edge technology, and pragmatic solutions for the power industry. Now it is time to honor those who have distinguished themselves through their work. May I now request our dignitaries to present the award. Well, the very first award category is Award for Best Paper. Total synopses received were 503. Total synopses accepted for full paper submission were 257. Total full papers accepted after review were 230. Total papers finally selected for paper post-representation session were 160, covered in 4 sessions. Total papers from women authors were 46. In the same award category, Best Paper in Women category, to present this very respective award, I would like to request from Shri R.P. Singh ji to please kindly present this award. And this very particular award goes to Fault Detection in Power Grids using a digital twin framework. To receive this award, I would like to call upon Gayatri Sivaguru and team from IIT Madras. Would request from Shri R.P. Singh ji to please kindly present this award. Many congratulations to the awardee. Proceeding further, Best Paper NGN category. To present this very respective award, would like to request from Shri Marcio Shitman, and this very particular award goes to Global Grid Resilience Strategies, a comparative analysis of developed and developing countries. To receive this award, would like to call upon Vaibhav Chandradas and team from Grid Controller of India Limited. Everyone please join in for the photograph. Many congratulations to the awardee. Well, proceeding further, Best Paper Overall category. To present this respective award, would like to request from Shri I.S. Jha, Patron SIGRE India. And this very particular award goes to Navigating Urban and Aviation Challenges, Danube Towers for Height Restricted Transmission Line. To receive this award, would like to call upon Naga RMSR Murthy Manda and team from Power Grid. Everyone please join in for the picture perfect moment. Congratulations to the awardees. Proceeding further with the next award category, Awards for Student Innovation Pavilion. Well, under the same category, Consolation Prize for the Student Innovation Pavilion goes to Archana Tamarkar from Motilal Nehru National Institute of Technology, Allahabad. But unfortunately, she's not here with us. She was supposed to catch the train. We'll make sure that she shall receive her trophy. Proceeding further, Consolation Prize for the Student Innovation Pavilion. This very particular award goes to, and to give away this award, would like to request from we would like to request from Shri Yatindra Dwivedi, Director Personnel. And to receive this award, would like to call upon K. Basu Maitre and Anmol Sardhalia, IIT Jammu. Many congratulations to the awardees. Moving ahead, third best student innovation pavilion. And to present this award, would like to request from Shri Naveen Kumar, CVO Power Grid, kindly come to the dais to present the same. Can we have huge round of applause for the gentleman, please? And to receive this award, would like to call upon Gayatri S from IIT Madras, and she is coming along with her father to receive her award. What a proud moment for her father. Well, let's give her a huge round of applause. Congratulations to Gayatri along with her father. Well, proceeding further, second best student innovation pavilion. And to present this award, would like to request from Shri R.P. Singh ji, and to receive this award, would like to call upon Shubham Tiwari, Riddhi Saraf, Khushi Sharma, Siddhant Jain from ABS Engineering College, Ghaziabad. Would request Shri R.P. Singh ji to please kindly present this award. Many congratulations to the awardees. Proceeding further, Best Student Innovation Pavilion. And to present this respective award, would like to request from Shri R.K. Tyagi, CMD Power Grid. And to receive this award, would like to call upon Ankur Bhargava, Dr. Mohammad Sarwar, Rayyan Ahmed, and Vikas from Faculty of Engineering and Technology, Jamia Millia Islamia, New Delhi. Many congratulations to the awardees. Well, ladies and gentlemen, proceeding further with the next award category. Awards for Startup Pavilion. Well, proceeding further, second best Startup Pavilion. To present this respective award, would like to request from Shri R.K. Tyagi, CMD Power Grid. And to receive this award, would like to call upon Sthir Energy. Many, many congratulations to the awardee. Proceeding further, Best Startup Pavilion. And to present this respective award, would like to request from Shri I.S. Jha, Patron Sigray, India. And to receive this award, would like to call upon Sagar Defense Engineering Private Limited. Many, many congratulations to the awardee. Well, ladies and gentlemen, proceeding further with the next award category, Awards for Exhibition Stall. Third position in Best Exhibition Stall category. And to present the respective award, would like to request from Shri G. Ravi Shankar, Director Finance Power Grid. Kindly please come to the dais to present this award. Also, can we give him a huge round of applause, ladies and gentlemen? Thank you so much. To receive this award, would like to call upon Modern Insulators. Many, many congratulations to the awardees. Proceeding further, second position in Best Exhibition Stall category. And to present the respective award, would like to request from Shri Vamsi Rama Mohan Burra, Director Projects Power Grid. Kindly please come to the dais to present the award. Let's give him a huge round of applause, ladies and gentlemen. This very particular award goes to Taurus Powertronics. Many, many congratulations to the awardees. Well, proceeding further with the next award. First position in Best Exhibition Stall category. And to present this respective award, would like to request from Shri R.K. Tyagi, CMD. And to receive this award, would like to call upon Hitachi Energy. Many, many congratulations to the awardees. Hearty congratulations to all our award winners. Let me share a quick anecdote from one of the student pavilion entrants. They mentioned that their journey, starting with a modest prototype, culminated in a refined product capable of addressing real-world grid integration challenges. It is these stories of perseverance and creativity that make GRIDCON a success. May I now request Shri R.K. Tyagi, CMD Power Grid, to present a token of appreciation to Shri I.S. Jha, Shri R.P. Singh and Shri Marcio Shetman. We are truly grateful for your time, leadership and continued guidance. I request Shri R.K. Tyagi ji, CMD Power Grid, to present a token of appreciation to Shri I.S. Jha, Shri R.P. Singh and Shri Marcio Shetman. Thank you. We hope these mementos serve as a reminder of your invaluable contribution to GRIDCON and to the broader power sector. To express our collective gratitude, I invite Director Personnel Power Grid, Dr. Yatindra Dwivedi, to deliver the vote of thanks. He will acknowledge the many hands and minds that have shaped this conference and made it a grand success.
Good evening. Respected Sri R.P. Singh Sahab, Chairperson Board of Governors at IIT Kharagpur and Bhubaneswar. Respected I.S. Jha Sahab, Patron Sigre and ex-CMD. Respected Sri R.K. Tyagi Sahab, Managing Director and Chairman Power Grid. Director Finance Sri Ravi Shankar Sahab, Director Operations Naveen Srivastava ji, Director Projects Sri B. Vamsi ji, CVO Sri Naveen Kumar ji, distinguished guests, esteemed delegates, industry pioneers, policy makers, innovators, and cherished friends of the global energy community. I am grateful for the opportunity to address you as we reach the conclusion of GRIDCON 2025. A remarkable 3-day journey that has unfolded here. Under the inspiring banner of innovations, this conference has been a beacon of hope, a hub of collaboration, and a launchpad for transformative ideas. As we stand at this pivotal moment, I invite you to join me in reflecting on what we have accomplished and envisioning the boundless possibilities that lie ahead. I express my sincere thanks to Honorable Minister of Power and Housing and Urban Affairs, Government of India, Sri Manohar Lal ji, who in spite of his busy schedule, inaugurated the event and spared his valuable time to provide direction and guidance. His visionary leadership has truly been the cornerstone of the event's success. I would also like to thank Honorable Minister of State for Power and NRE, Sri Sripad Yasho Nayak ji, who spared his valuable time to participate in the inaugural session. It was our great privilege to have Secretary Power, Sri Pankaj Agrawal ji, with us today, whose invaluable guidance has been pivotal in shaping GRIDCON 2025. I extend my sincere gratitude to Sri R.P. Singh Sahab and Sri I.S. Jha Sahab for honoring this valedictory session with your presence. Your vast experiences and visionary leadership continue to be a guiding force for Power Grid. My heartfelt thanks to President Sigre, Dr. Constantine, who has come all the way to share his experience with us. I extend my special thanks to Chairperson CA Sri Ghanshyam Prasad ji also, and Director General International Solar Alliance Sri Ajay Mathur ji also, for their encouragement and continuous support for the event and their special addresses in the inaugural session. I'm also thankful to Mr. Marcio, HVDC expert from Brazil, for gracing the occasion and sharing the experiences. We extend our grateful gratitude to our CMD, Sri R.K. Tyagi Sahab, whose instrumental role, guidance, and unwavering support has made GRIDCON 2025 a reality. Tons of thanks to you, sir. We are all enjoying credits because of you. Let me extend my deepest gratitude to our fellow Board of Directors for their continuous support. Thankful to Director of Finance, Sri Ravi Shankar Sahab. Every moment he monitored the activities and guided us. Thankful to Director of Operation, Sri Naveen Kumar ji. Basically, it was your show. We only synergized your actions. It was only your show. A lot of thanks to you and for continuous support. Thankful to Director Project B. Vamsi Mohanji for guiding at every moment and bridging with the stakeholders and partners. Thankful to CVO Naveen Kumarji for his guidance. Thankful to our distinguished speakers and panelists. Your insights and expertise have been our guiding light, sparking important conversation and thought-provoking discussions. To our exhibitors, your innovations and cutting-edge technologies have provided a glimpse into the future of power transmission and energy resilience. To our paper and poster presenters, your research and groundbreaking ideas have enriched the conference with knowledge, inspiring collaboration and new directions for the industry. To our sponsors and media partners, your unwavering support and outreach has amplified the impact of GRIDCON 2025, ensuring that our collective efforts reach the broader global community. To our delegates, your active participation, discussions, and engagement have been the heartbeat of the conference, making it truly interactive and impactful experience. To our moderators, your skillful facilitation of the panels ensured that the discussions remained insightful, engaging, and impactful. Thankful to our organizers, all the committee members. Your dedication, attention to detail, and tireless commitment ensured that every aspect of GRIDCON 25 was executed seamlessly. From planning to execution, your behind-the-scene efforts have made this event a grand success, and we owe much of this achievement to you. Friends, GRIDCON 25 was not just about ideas, it was about action. Now the real work begins. That what we have learned here, the insights, the partnerships, the inspiration, and turn it into action. Build grids that withstand the storms, power communities, sustainability, and adapt to world of flux. The future of energy is not a distant horizon, it's a canvas we are painting together, stroke by stroke, starting today. Let's rise to the challenges with boldness and unity, because the power to shape tomorrow is in our hands. चिरागों को आंखों में महफूज रखना, it's like protect the sparkle in your eyes. चिरागों को आंखों में महफूज रखना, क्योंकि बहुत दूर तक बात ही बात होगी. This I have changed, क्योंकि बहुत दूर तक बात ही बात होगी इस GRIDCON 2025 के बारे में. मुसाफिर हैं हम भी, मुसाफिर हो तुम भी, GRIDCON के इसी मोड़ पर फिर मुलाकात होगी. Thank you, have safe travels, and we meet again to celebrate the progress we have made. Until then, let's keep the energy flowing reliably, sustainably. Thank you. Good day.
Thank you, sir, for that gracious acknowledgement of everyone's contributions. Indeed, organizing a conference of this scale is a monumental task involving countless hours of preparation and dedicated teamwork. Ladies and gentlemen, as we conclude GRIDCON 2025, let us remember that the real measure of success lies not just in the knowledge exchanged over the past few days, but in the tangible changes we will bring about in the lives of millions. The discussions here, ranging from grid modernization to renewable integration, affirm our collective resolve to build a resilient, sustainable power sector. On behalf of the entire organizing committee, I thank you all for your active participation, your invaluable insights, and for creating a forum that stands as a beacon of innovation and transformation. We hope you leave GRIDCON 2025 with fresh perspectives and renewed determination to shape the future of energy. Wishing you a safe journey home, and we look forward to welcoming you again at the next edition of GRIDCON. Thank you so much, everyone.
Excuse me. May I request all the organizers, whoever is available here from any of the organizing committee, to kindly come on the stage to have a photograph with the management. Please, anybody with a grey coat, either received, whether wearing it today or not, doesn't matter. Please come on the stage. Whosoever has been the proud recipient of a grey coat, please come here on the stage. We need to rush. CMD sir is already on the stage. Please. No, he's already there. Grey coat, please come.